Okay, let's take a look. I have only looked at the first 4 pages only. I'm so sorry. Wow, still got 14 pages total. Okay, let's begin. So this one, you have the question paper with you? Open already?
Yeah,
You have the solution also?
Oh, solution?
I didn't give you the solution. Wait. Huh, really? I thought I got sent the solution. Oh no.
Um,
Oh, I didn't send. Okay. Yeah, I sent it. I sent it already. July 20.
huh? Oh.
Yes. Okay.
Oh.
I think from now on, I'll just give you both the questions and the solution. Then you can maybe mark on your own after trying. Yeah. Then you can highlight those questions that you got wrong and those that you really careless mistake. Then you can just do your own correction at the side, or you say, I know this already. I don't want you to go through that kind of thing. Then you identify those questions that's really conceptual. Like you read the solution already, you still don't understand one. Then we go through so we can save time. Is that okay?
Okay, can.
Yeah. Okay, good. Yeah. If not, really go through every single question with algebra mistake is not worth it. But for now, I'm just going to do that because I don't know what you know and don't know. Okay, let's take a look at question 9 part 1. This one is worth going through. Let me tell you straight first. When you have fx plus 2 equal to fx, it appeared before in one of the A-level question. This is what we call a periodic function. Can you tell me graphical transformation? You see plus 2, what happens to the graph? Move left or move right?
Right.
Plus you for left and right, you need to think reverse psychology. Plus 2 you think right, because positive x-axis, right? But reverse psychology, think of it like you are given a extra boost of plus 2, so that means that the f itself can afford to be lazier, don't need to work so hard anymore. So he will move left. You reduce the amount of effort it put in. So actually it moves towards the left by 2 units. Okay, translate 2 units in the negative x direction. So what does that mean? It means that every single x is equivalent to every single x, but you plus 2. So you move left by 2 units. So that means this graph, right? Your graph is incomplete. It's actually starting from 1, 0 all the way to, you know how to read the piecewise function, right? Have both the question paper and the solution open. So it's basically 1 less than equal x less than equal to 2 and e less than x less than equals 3. So that means that your graph should actually be from 1 all the way to e. So if I continue all the way until here, this is e comma ln e, which is 1. That's e. And then it continues all the way until oh sorry, you already had an e. This is e comma 1. You already have your x equal to e. And then you want to have 0 when the x is from e to 3. So maybe here is 3. Then where is my 0? It means that your graph is actually over here. Okay. But where is my empty circle? Where's my solid circle? Here and here. Which one should be empty? Which one should be solid? Left and right.
The left.
Should be what?
Empty circle.
Empty circle, very good. Then because it is strictly more than or strictly less than. How about right side? And solid or empty? This one has an equal, so solid circle, very good. That is a full graph that you should be drawing. Then how about here, this point, e comma 1, solid or empty? There's an equal sign here.
Solid.
Solid circle, well done. Okay, so just to make it more dramatic, I'll draw a circle, then I shade in to remind you, need to shade in. And then this one x plus 2, right, just means that if you move the graph by 2 units to the left, you will still get the same thing. Fx plus 2 is the same as fx. So what does it really mean? It means that you'll actually get a periodic function, just like sine x and cosine x. You just keep on repeating the same graph again and again. Let me show you how to draw it.
I think I just read from the GC, so I never continue.
Yeah, so that's not so good. So basically, right, the graph it will look something like this. First, you start from 1 all the way to this solid circle E, 1. You drop down an empty circle. You within a vertical line, you to pass vertical line test, you can only have one solid circle that cut the vertical line. Oh, vertical line test is for function to exist. We haven't covered functions also. Okay, don't know.
Yeah.
Okay, never mind. Yeah, so this is one copy of it, but actually, you can just now make multiple copies of it to the left and to the right. Okay, so in other words, I can do the following. Let me try and copy and paste. You see that?
Yeah.
So then you copy and paste again, maybe on the right side. Copy and paste again on the left side. Copy and paste again on the right side. Many copies of the same thing. So all these cannot be one anymore. You just have to relabel the coordinates accordingly. So what do you think is this coordinate here?
3.
Yeah, correct. Not really. This is E, right? So actually, oh sorry, my y-axis is in the wrong place. Let me just be a bit more precise. It should be here. This point here is E minus 2. I'll just tell you. If you do a bit of calculation, right? And this next point will be 3. Okay. Then after that, the next point will be 4. This is 4, ln 2. This is E, something. It doesn't really matter. E, 1. This one is E minus 2, ln E minus 2. Okay. This is a similar idea to if let's say you have sine of x is equals to sine of x plus 2 pi. What does that mean? It means that every time the sine graph you move to the left by 2 pi units, plus means move left by 2 pi units, the graph will still look the same. So what does that really mean? You draw a sine x. You move by 2 pi units to the left. So copy the entire thing, but 2 pi units to the left. It will be equal. So that's why the graph will look the same. So it means that doesn't just mean it only works for one set of values of x. It works for all values of x. So that just means that this graph will keep on repeating forever and ever. Do you get what I'm saying?
Oh, yeah.
Now this is a periodic function. Okay, good. Another example would be cosine x equals to cosine of x plus 2 pi. Of course, it can also be minus 2 pi. You move to the right, move to the left, it's the same thing. Okay. This is basically periodic function, which is application topic that's not exactly taught in the syllabus, but it appeared before in A levels. Yeah, okay, so what is wrong with your working? Here setup correct, here final answer wrong. I'm not sure why. Let me double check. Okay, so you have ln x bracket square already. What do you do? So you pick ln x as the u and then 1 as dv by dx. That's where everything is wrong. Okay, here you are supposed to pick ln x bracket square as the u, okay?
Oh.
The entire thing.
Oh, okay.
Then now do I need to continue?
Don't need.
So it's 2 ln x and over x, blah blah blah. Yeah, so wrong u. You pick the wrong choice of u when you're using integration by parts. This guy. Okay? Yeah. Moving on. So part 2. What is part 2 asking? Part 2 is asking you sketch the graph of y equal fx from -3 to 4. Okay, so I already drawn the graph way beyond that, but we only need -3 to 4. So let me see. The solution already gave the graph. Let me try and copy this down and present it nicely. Sorry. So we want to draw the graph from -3 to 4. Where is it actually? Here will be a -1. Here will be a E-4. Here will be a -3. And what else? You want to go until 3. So Up to here is fine. The rest don't need. So I'll erase it away. Okay. How did I get this graph? How did I get those coordinates again? Basically, I am drawing from the original domain. 1 less than equal x less than equal e, then e less than x less than 3. So 1 to 3. This is the original copy. Then I know that the distance here is how long? Maybe I'll just change everything to black color. What's the distance? What's a period, in other words? It's 2, right? The period is 2. So in that case, if you have period 2, that means all the others will also have period of 2. Period of 2. Can you see those 2s? 2, 2, 2. Then from there, you can just do a bit of math to work backwards. If here is 1, you go backwards by 2, so minus 1. Just it's similar to sine curve. If you have here, like let's say, if here is a pi, then what's the coordinates here? You just take pi minus away 2 pi. You minus away the period. Is that clear? This will be negative pi. So just like sine curve, just like cosine curve. Same thing. So how do you go from 1 to negative 1? You minus 2. How do you go from minus 1 to negative 3? Minus 2. Then this one, how do you get from e to e minus 2? Because the period is minus 2. How do you get from e minus 2 to e minus 4? Because you minus away the period 2. How do you get from 3? Then how do you get from 3 to 1? Minus 2. How do you get from 1 to negative 1? Minus 2. How do you get from minus 1 to negative 3? Minus 2. Then you get the pattern already. Okay, good. Yes, this is the graph. This is the graph that they're asking you to sketch worth 2 marks. Hence, find the integral from minus 3 to 4. So here to, wow, where is 4? How come my graph stopped at 3? Oh, sorry, I should have continued on all the way to 4. Sorry, I'm missing a branch. Here, 4. Yeah. Can just one half, don't need continue. So we want to find the area from here to here. Is that clear?
Yeah.
Then that means that it's really just, I hope you can see this weird shape. Not exactly a quadrant, not exactly a triangle, and just something close to it. But you have how many copies?
4.
4 copies, right? So you actually need 4 times of that area. Is that clear?
So I can just integrate 1 times 4, right?
Correct, exactly. But you must know how to draw the graph before you can know you need to do that. Okay, do I need to go through the rest? I think I don't need, right?
Yeah, don't need.
Don't need. Okay, just 4 times of integral, maybe 1 to e of the function, which in this case would be ln x. Okay, that's your answer already. Then the rest, I'm sure you know how to integrate ln x. Just integration by part. Choose your u and dv by dxyz. 1 times ln x. Okay, that is part 2 done. Moving on. Question 10a. What do we have? 10a is using substitution u equal to a tangent x. Then a is a constant. Show that the exact values of the integral blah 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 is 2 plus pi over 8a cubed. So over here, the main problem I found is that du by dx. By the way, I don't want you to manipulate straight away. I strongly advise you to copy down this u equal a tangent x first. I know it's very silly. It's already in the question mark. Why need to copy down? The reason is you can immediately check once you have it over here that your differentiation is wrong. Do you see that your du by dx is missing a factor of a? Like for example, if u equals to 3 tangent x, what is du by dx? 3 secant square x. Do you see that? If there's a number in front, you just continue multiplying. All right. It's not a constant. If it's like, for example, 3 tangent x plus 5, okay? Plus 5. Then you differentiate the plus 5, you get plus 0. It's a different idea. It's a separate term altogether. Here, it's a being multiplied to the tangent x. I think you're confused because there's a letter, is it?
Yeah, I thought it's a constant, so can remove.
Constant factor, you factor out, just like a 3, or you can change the number to, I don't know, a 7, you factor out. So what I mean by factoring out is, if u is equals, I need to write down this. If u is equals to like 7 tangent x plus 5, it's how many terms do you see?
Like step 2.
2 terms, separated by plus sign. Then when you differentiate, du by dx, what do? You differentiate term by term. So you d by dx of the first guy. Please do not show so many steps for differentiation. I just know this in the back of your mind. Then you differentiate them term by term. First term, second term. 1, 2. Then when you differentiate this guy, you got a constant factor. What do? factor out. Constant factor out. Okay. Then this one differentiate out 5, you get a 0. Differentiate 5, you get a 0. That's why we say constant can just remove. But it's a separate constant term, not a constant factor. Factor multiplied to a algebra expression. Understand now?
Yeah.
Then after that, you get 7 secant square x plus 0. Plus 0, then you remove. It's a separate term. Here, the a is not a separate term. It is a factor. Factor need to factor out. So you factor out the a. So that's why I have error carry forward, set face. Okay, can yeah, moving on. So here something went wrong with okay. So you found the limits. That is very good. Here something went wrong with your integrand, the middle part. Integral always got 3 parts. Number 1 is the upper lower limits. Limits. Then after that got the middle part, it's called the integrand. Then after that got the last part, the d something, d happy face. This is an independent variable. In this case, we are using u, so something went wrong with our final answer. I'm not sure why. So let me examine a bit first. Haven't had a time to look at it exactly. So you have lower limit 0 and a. You're using a substitution u equals to a tangent x. So you did the working over here. Sub in a a, sub in a 0. Then you get a pi by 4 and a 0. Correct. Yeah. Your limit is okay. But then the integrand something is wrong. Let me just check it. So 1 over a square plus u square bracket power 2 is actually equal to what? 1 over a square plus substitute the u step by step. So you get u, which is equals to a tangent x, which means that u square is equal to what? A square tangent square x. Then you sub in a square tangent square x bracket square. Factor out the square inside the bracket. What do you get? You get 1 plus tangent square x. I'm just gonna skip a step here. I'm gonna erase away 1 plus tangent square and convert it into secant square. Is that okay? Clear so far?
Okay.
And then after that, what do you notice? Outside have a square. So you have to bring in, what do you actually get? A power 4. Okay, wait, don't forget 1 over first, then a power 4 secant square power 4. Do you see your mistake now? Here you put square and square only. It should actually be power 4. You factor out a square, that's wrong. It should be a power 4. 1 over.
Oh.
And why did you make that mistake? Because you do too fast. I strongly recommend you to do this integrand. Maybe you work it out at the side. Just do it step by step. You sub in with whatever. Then you factor out the a square. You get 1 plus. Okay, maybe since I'm saying do it step by step, I should also follow my own advice. To prevent careless mistake, you should try and 1 over, factor out the a square, bracket 1 plus tangent square x. Is that correct? Is this correct?
No.
No, what's missing?
A square.
Square bracket square. Very good. Okay, now you are not below. Okay, good. So please do that. Then I'm not gonna go through the rest. Okay, should I go through the rest? Do you want me to go through?
I don't need.
Don't need. Okay, then yeah. So this is power 4. I'm sure you can handle it. Yeah. Oh wait, sorry. But then of course, don't forget that there's a dx you have to replace. Dx must replace with the 1 over a secant square x. I also realized something is wrong again. Oh no. Okay, I think I go through this part as well. You made du the subject over here, huh? You see this part?
Yeah.
Bad idea. Should replace with make dx a subject. I think it's easier. Make dx a subject. So what do you actually get? You get dx equals to du divided by a secant square x, right? Okay, we're gonna copy that. So du over a secant square x. So that means that if I replace my dx, if I take my integral of this guy dx, I mean du, I would actually need to replace my dx from before. Sorry, yeah, what am I doing? Sorry, du. Integral with du, right? I replaced it with the substitution u equals to a tangent x. I will eventually simplify the integrand down to this guy, 1 over a power 4 times secant power 4 integral. But the du, you need to now replace it with, oh, sorry, I was the one that's confused. Your substitution is correct. Oh, right, sorry. Keep the du. Oh, we're replacing u with x. Oh, it's not x to u. Sorry. A secant square x dx is okay. Then you can put it over here.
Okay.
Yeah. Okay, then you can continue on your own. But don't forget the limits. 0 pi by 4. Yeah, I haven't factored out the a power 4. So you can continue. Okay, moving on. Next one, B part 1, what happened? Oh no, why is the answer wrong? Let me read the question first. B part 1, the region R is bound by the y-axis and by the graphs 1 over 1 plus x squared, and y equals to x plus 1 over 4. Find part 1, the area of R, giving your answer correct to 3 decimal places. So bounded by y-axis, so yeah, you have identified the region correctly. So maybe it would be smarter if we integrate with respect to y. But actually, with respect to x is also not too bad. You just need to integrate from here to here, get this area, minus away this tiny trapezium here, right? Okay, let's see our working. Your setup is 0 to 1 of the top function, minus away the bottom function. Okay, it's correct. Yes, good. The setup is correct, but the algebra is wrong. Somehow the answer is wrong. Let me check. So 1 over 1 plus x squared is just tangent inverse. Okay, x plus 1 over 4. You can factor out the minus 1/4 first, then you got x plus 1 inside. Integrate x plus 1, you get x squared over 2 plus x. Okay, it's fine. So it's just a substitution wrong. Let me see. Tangent inverse 1 minus away 1/4 times 1 square. Oh my goodness. Is this 12 or 1 square?
12.
Oh no, this is x square. You sub in 1, you get 1 square, which is just 1.
I think my school was extra big. I think it's 1 square. I did it as 1 square.
Okay. Can 1 square, can. Then plus 1. Then next one you sub in with 0, sub in with 0. Okay, how come you get pi over 8? That's not correct. Tangent inverse of 1 is what?
0.
No. Oh, no. Okay, exact value. Let me draw for you this triangle, 45 degree, 45 degree, 90 degrees. Let's say that this guy here is 1, 1. Then what would be the length here? Pythagoras theorem, square root, what?
Square root 2.
2. Okay, so that case, can you tell me what is tangent of 45 degrees? Opposite over adjacent, so it's 1. Okay, so that means that tangent of pi by 4 is equal to 1. So can you tell me what's tangent inverse of 1 now? Pi by 4, 45 degrees. Not 0. I think that's a mistake. Is that the mistake?
No way. I use calculator, so I will get pi by 4 also.
Oh, okay. Actually, no, your calculator, pi by 4, they'll sub in the pi with the decimal value.
Yeah, but okay. I will divide by pi to get the exact value.
Oh, smart. Can do that. You can do that too. Okay, let's just double check the rest. Tangent inverse of 0, what would it be? I think it's a 0. Then this one, 1/4 times 0. So this is gone. This whole term at the back is gone. 1/4 times 1 square over 2. So let's see. Minus. Wait. I am confused already. How did you not get the correct answer? Your working is fine. This part here is minus 3 over 8, right? That's the only thing that's missing. Minus 3 over 8. And this should be pi over 4, not pi over 8. How did you get 8? I got 8. Don't understand.
I I must have key into my calculator or something funny.
Yeah. Sorry, what question is this? 10B part 2. 10B part 2. Oh no. Oh no. Wait a minute. This is part 1, sorry. Yeah, so it should actually be pi over 4. Then you subtract away the other guy. But actually, this question, I just realized, sorry. They didn't request for exact answer. They didn't request for exact answer. So you could have just, you could have just used a GC to calculate. Answer is 0.410.
Oh.
Yeah, so yeah, but okay, good practice, I guess, to get the exact value. But something went wrong with the algebra. Up to all 3 steps are okay. Just the final step wrong. Can I move on already? I move on. Question.
Give me like method marks.
Yes, definitely will up to here. Because you got all 3, the working perfect. It's just the substitution. So yeah, show this working, then you can get method marks. Safer. Okay, moving on. Question B, 10B part 2. If you want to find the volume of revolution formed by rotating R through 4 right angles about the x-axis using a non-calculator method. Basically, you just need to find the volume of revolution, standard formula. So let's see if you used it correctly. So you have pi times integral from 0 to 1. Okay, because the region R was from 0 to 1. And then you have to take the top square minus bottom square dx, right? Top square minus bottom square dx. So what have you done? This square minus bottom square dx. Okay, good. Oh, by the way, a tip for you, maybe even though they ask for a non-calculator method, just give them the decimal value on the GC. If maybe, hopefully, they'll be kind and give you some method marks. But maybe not, because they are specifically requested for a non-calculator method. So something went wrong with your final answer. I'm not sure why. It should be a pi square, not pi cube. Let me double check your work. Okay, what happened? 1 plus x square. If you try to integrate that, you get supposed to get a 2 plus pi over 8. How do you even get that in the first place? Let me see. This guy is not tangent inverse x square. Wrong. This is wrong. It's not that simple. You cannot just integrate within the term. By the way, integration of f of g of x is not the same as just leaving the f alone and then you integrate g of x inside. No such rule. You cannot bring the integral inside. No. Only for very special cases that will be true. So for example, if you try to integrate I don't know, like a sine of cosine of x dx, it is not the same as sine of, you integrate cosine, get sine, so sine of sine x. No such thing, nonsense.
Oh.
Here, what you did is you treat the square as an outer function, and this guy as an inner function. Then you integrate the inside, then you square on your own. You're coming up with your own integration rule. No.
Like that,
how to integrate? What happens when you have a square? Maybe you should have no choice but to expand the whole thing. Yeah, then after that you get a power 4 at the bottom, 1 over. Then that's actually a bit difficult. How would you do it? You might need to use a substitution. Let me think a little bit. This is not that easy. Get a quadrant. Partial fractions. Is that useful? Not really. Let me think a little bit. Did they give you any hints at the beginning how to integrate 1 plus x square?
No.
Yes, they did. Yes, they did. Sorry. Can I just give you the answer for 10A first? For 10A, if you go and work it out later at home, so it's also in the solution. It's 2 plus pi over 8 cube, 8A cube. to save some time, I'm gonna not show you the reason, the exact working for y. Let me know if you want me to show. Okay. So this is the final answer from 10a part 1. In other words, the integral of this guy from 0 to a du is equals to 2 plus pi over 8a cubed. Is that okay?
Yeah.
Can but can we use that to our advantage? Can we use this information to help us to solve the very difficult integral that we are struggling with? Integral of 1 over 1 plus x squared bracket square. You see the similarity? A square 1, u square x square, outside bracket square, bracket square. Can you see the pattern? They are the same. They are essentially the same. But here is a u lah. So you need to learn how to improvise and adapt. The u is now a x. Then the a is now the a square is now a 1. So a is equal to
1.
just 1. Yeah, don't need to care about the negative value. So it's just a positive 1. Then in that case, you can also sub in the limits. Sorry, you need the limits 0 to 1. Then since you already have a formula for the final answer, what do you need to do with your a? Substitute with
1.
1, exactly. Then your answer is 2 plus pi over 8 times 1.
But if I just substitute, like, there's working meh?
Can. That is considered that. Yeah, that's fine. They will give you the mark if you can get the correct answer. To be able to see that you need to use part A, I think that's already a little bit challenging. Yeah. Okay. Can Yeah. So you're just using the answer from part A, but substituting the A with 1. So over here, yeah, you come up with your own integration rule. That's why error carry forward all the way wrong. This part, let me see if is it correct? Let me double check. So you get x cubed over 3 plus 2x squared over 2. The 2 cancels off, just an x squared plus x. That's okay. Then you have a 1/4 square, so 1 over 16. Then here your pi is missing. You have a missing pi. Do you see that? You miss out a pi?
Yeah.
There's supposed to be a pair of invisible brackets around the integral with a pi outside. Then when you sub in, you integrate already, and then you sub in upper and lower limits, you will end up with pi times the first guy minus pi times the second guy, if you try to distribute the pi. Also, you forgot about this pi. This pi is very sad. This is a sad pi. Okay, you left out the pi over here. That's why error carry forward. Here, don't have a pi. So that's why your answer is wrong. Eventually, there's supposed to be an extra pi here. Can I leave that to you to check on your own?
Okay.
So I identify the error. You just go and add on the pi, then you recalculate. The answer is totally wrong. Moving on, let's go to question 11 part 1. So what is 11 part 1? Let me read the question first. Find the integral x power 4 over 1 plus x squared. Oh, you got it right. Okay, can. Nothing to talk about. Well done. Can. Moving on, part 2, question mark. Then after that, you got it wrong. Then after that, after playing around with it a bit, you realize secant square is u squared plus 1. Then you can just sub in u squared plus 1. Okay, actually, what you're doing is a bit backwards. A bit backwards. You should actually start with u squared plus 1, then just sub in the u with tangent x, right? No? Is that what you're doing? Wait, let me read again. So you start, okay, let me read part 2 first. By using the substitution u equals to tangent x, show that the integral of tangent power 4x from 0 to pi by 4 dx equals to pi by 4 minus 2/3. Your answer is correct. Yeah, you just need to realize that after you do a substitution, you get back to an integral that looks exactly the same as part 1. Right? X power 4 over 1 plus x squared becomes u power 4 over 1 plus u squared. There's a u power 4 in front. Yeah, okay, then it's fine. It's fine. You did the u substitution correctly. Well done. You even substitute the limits. Good. Then you can just recycle the information from part 1. Then you sub in and you get the final answer. Okay, nothing to go through. Your working is fine. Just don't need this part. But even if it's wrong, don't just strike off during exam. Just box it up. All right, box it up, and then you just skip it. Leave some working there, even if it is wrong. Just try like 3 different ways if you can. if at least one of them is correct, at the correct method, you will be awarded the mark. Don't cancel away your working during A levels. Is that clear?
So I boxed up the wrong one or the right one?
Boxed up the wrong one, box up the wrong one and then maybe say sorry, ignore, but don't something like that. But you don't want them to totally ignore. Just say sorry. Okay, then just move on. Just say sorry and move on. Okay, then part 3. Deduce the exact value of integral of this guy from negative pi by 4 to pi by 4. So you should draw the graph and you realize that it's symmetrical, pi over 4. Actually, I don't know how the graph looks. I just know that every time you have an even power, the graph will be symmetrical about the y-axis. Also, if I can just quickly draw the graph, how does it look? Let me see. Y equals tangent x power 4. I don't show you the graph that I'm drawing. I'll just sketch it out for you because it's a bit faster. Okay, so here's how the graph will look. It will look like a happy face like this, and then after that, another happy face, but it's more like a U more than a parabola. Like this. So many of these arcs. Y-axis, x-axis. This is your y equal tangent power 4x. So the key thing to take note is that it is symmetrical about the y-axis. Can you see the mirror reflection about the y-axis?
Yeah.
Okay, good. So that means that when we try to integrate, we just need to times 2 to that area to get our total, which is what you did. Well done, Ken. Okay, moving on. Okay, now part 4. Part 4 part 4 is asking a curve is defined parametrically by x equals secant square theta, y equal tangent theta, 0 less than equal theta less than equal pi over 2. Show that the area of the region are bounded by the curve and the line x equal to 2 as well as the x-axis is given by the integral blah blah blah. Find the exact area of region R. So the first part you need to show, next part you need to evaluate the integral, then you can get the area. Okay, I don't know what you're doing. Here, technically, no, did I move on too fast already? Yeah, still part 4. Okay, I don't know what you're doing. I'll just go through entirely. Is that okay?
Can.
From scratch, Can, good. Okay, let me add a new page. This is 12. Okay, I'll use a blank paper. Okay, so let's just start the question. So what we have is x equals to secant square theta, y equals to tangent of theta. Then we have 0 less than equal theta less than equals to pi over 2. So what we want to eventually show that the region R is equals to blah 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 and eventually equals to 2 times of the integral from 0 to pi over 4 of tangent power 4 theta plus plus tangent square theta d theta. Okay, how? Let's see. So what we should realize is that the region R, how does it look? We don't know, right? So maybe we can use our GC. Let me just change my screen now to my GC. Hold on a second. We can use the GC to help us. I'm going to change to my GC now. Okay, I'll start from the home page. Can see the GC?
Can.
Okay, so how we do it is we go to mode, we go to parametric, enter. Then after that, you draw y equals. So now you got the two functions x1 and y1. Pretend you didn't see that. I'm clearing my screen first. Then after that, you just change your x to what? We have secant square. Now, unfortunately, the GC doesn't have secant square, so you need to auto convert yourself 1 over cosine square. So 1 divided by bracket cosine x, or in this case t, sorry, power 2. Close the bracket. All right. Then the y is tangent theta, so you type in tangent t. Close bracket. Is this clear?
Yeah.
Take note that cosine square, the GC must display it like this. Cosine t bracket then power 2. Okay, you cannot have the square in the middle, unfortunately. I don't know, fortunately or not. But okay, anyways, now you can just draw the graph. Oh, let me just change my zoom to zoom square. Maybe zoom standard. Oh, you realize something. Do you see? It was a bit fast. It moved to the right and then it came back. Moved to the right and then it came back.
Oh.
You see, it moved right and came back. So actually, it's can you predict what shape it will be?
Ellipse.
Yes, yes. So let's just start from the x minimum. We just start from like let's say -1, and then the x maximum we go to maybe a bit too much, 30. Let's see what it looks like now. Oh, still a bit too small. Let me zoom out all the way to maybe 200. Wow, it's even bigger than 200. Okay, okay. Let me go to 800. Oh, it just keeps going. Okay. At this stage, you realize it keeps going. There's no point to finding out already. Let's just try to solve the question. Because what we realize is that the graph only interested the question is only interested in the parameter theta from 0 to pi over 2. On the GC, they use the letter T, capital T. So you just change it accordingly. T here, you press window. Just now you are at graph. Now you press window, you reach this page window. T min sub in the 0. T max, you just sub in the pi over 2. So where is my pi? Second pi divide by 2. Enter. You'll get a rounded off value 1.57. The step size, you can leave it alone. The T step, they will calculate for you. You don't need to deal with it. Just press the graph. Then realize here's how the graph looks. Sorry, I realized that my quality may be not so good. That's why it's drawing so badly. Hold on a second. Let me change back to my function mode first. Then I'll press window. Then xres is 1. Okay, never mind. Why is the quality so bad? I am a bit confused. Go to parametric first. Then go to window 1.57. Okay, I'll just zoom to standard. Zoom to standard. Okay, and then here instead of 6.28, I'm just going to change it to pi over 2. Oops. What is going on? Unlock all buttons. Second, pi over 2. Draw the graph. You realize it goes all the way to the right. So in this case, I am not exactly confident that it is an ellipse, but I will just sketch whatever I see first. So from 0 to pi over 2, that's what the graph will look like. Now I'm going to change my screen back to. Okay, hold on. Maybe I can do a bit better. Let's say 500 and draw the graph. Let's just track the path. Right. I get it now. That's actually a horizontal asymptote. That's why the graph keeps going. It's not actually an ellipse. I don't think it's an ellipse. Maybe we don't pick such a big value. I mean, you can calculate it manually and get everything in terms of x and y, but then that will be very slow. So can you give me give me 1 minute. I will try to get the shape of the graph out.
Okay.
Right. It's actually a parabola. Right. That makes sense. That makes more sense.
Parabola.
Happy face, sad face, like y equal x squared. But here is now x equal y squared.
Oh. Where's the happy face or sad face?
Happy face, but you turn around sideways.
Oh.
Yeah. Okay. I call basically it's a curve. Okay. So what happens in a parabola is that it actually goes all the way to infinity. Why do I know? How do I know for sure that it is a parabola? Actually, you can do a bit of algebra. This is extra. What you can do is you can say x equals to secant square theta. Then we know that there's what are the special identities? Sine square plus cosine square equal to 1. Divide throughout by cosine square, you get tangent square plus 1 equals to 1 over cosine, which is secant square. Then you have divide throughout by what is it? Sine square, you get 1 plus cotangent square equals to divide throughout by sine square. So you get 1 over sine square, which is cosecant square. Which identity is useful? Here, the oh wait, I'm writing. I sorry. I forgot to share screen.
Oh.
No, I don't want GC anymore. I want the iPad screen. Okay, now we are at the iPad screen. So I was writing this. So what I'm saying, oh, that's what you meant by you cannot see the happy face.
Yeah.
Oh, sorry. Oh yeah. Okay. This is happy face when you have y equal x squared. But here, what I'm saying is the graph is actually a sort of x equal y squared. Not exactly, I'm not sure. Maybe there's a +1 or something. Then I'm saying that this happy face, you can just turn it around. Then you will pair up nicely. Can you see? Happy face?
Yeah, can.
Okay, can. So throw that away. Then what I'm saying now is that how do you know for sure it must be a happy face? You can just do a bit of algebra, which is extra. You don't need to. X equals secant square already. Which one is useful among these three Pythagorean identities? Sine square plus cos square equal 1. Divide throughout by cosine square, you get tangent square plus 1 equals secant square. Or divide throughout by involving secant square. So it must be this one, right? Tangent square plus 1. So that means that this is actually tangent square theta plus 1. But tangent square is what? We have y equals tangent. So here you can replace with y square plus 1.
Yeah.
Which means x equals y square plus 1. That's just the inverse function of y equal to x square plus 1, right?
Yeah.
So you can draw a sketch of y equal x square plus 1, and then you just reflect about the y-axis. And there you go. That's your graph.
Oh.
Okay, it's just y equal to x square plus 1 is this guy. You can figure out how to sketch it on your own. Y equal x square plus 1, then you reflect it about the y equal to x. Okay, but actually this is extra. You don't need to know this. I'm just going to box this up under the red color box and say extra. You don't need to know that. Just trust the GC and your intuition a bit that this will be a what do you call it? Quadratic curve. So from 0 to pi over 2, so you have to stop somewhere, right? Let's figure out if theta equals to pi over 2. Oh, sorry. I mean, let's calculate the limits. If theta equals to 0 and theta equals to pi over 2, what's the corresponding x and y? In this case, let me read the question again. I forgot the question already. Show that the area of the region are bounded by the curve and the line x equal to 2. Right. Okay, so we draw a sketch of the curve, then we need to indicate the coordinates. Here 0, 1. Then here is x equal to 2. Then we want to find the region R. So it's actually this region here. But you realize that it's really just by symmetry. It is just this region R. Maybe I'll call it A1. Then the bottom is also A1, right? Okay, then we don't need the subscript. Is that clear? R is just equal to 2 times A.
Yeah.
Then in that case, we can just find the region of area A. Let's say the top copy. Then how do we do that? Now we know it must be the integral of y. This is like some y equal f of x. Y dx from 0 to 2. Then do we try to do this and solve for y in terms of x squared plus 1, and then you integrate? No, don't do that. That's not the point of the question. They want you to use the parametric integration technique. Okay, so this graph is a bit a bit blocking up my space, so I'm going to move it to the side and I'll bring it on top. Okay. And so the graph is over here. Then what else do we need when we want to do parametric integration? What we do is we have to identify the 3 components of our integral: the limits, the integrand, and the dx. We need to change all 3 of them from the x world into the theta world. Theta world. Okay, we're changing into the parameter theta. Okay, d theta. Look at the question. They ask for 2 times integral of whatever d theta. So it must be theta world. So what should we do? First thing, let's deal with the limits. So for the limits, we have the upper limit x equal to 2 and x equal to 0. So we should start there. Then that means what? How do we find our theta value? Just sub in x equal to 2, so we get 2 equals secant square theta. So secant square is 1 over cosine square. Cross multiply, you get 2 cosine square theta equals to 1. That means cosine square theta is equals to 1/2, which means I have not enough space. I bring down my x equals 0. Cosine theta must be equals to plus minus square root of 1 over 2, which is plus minus 1 over square root 2. But here, we know that the theta is in between 0 to pi over 2. Pi over 2 is 90 degrees. So that's really just quadrant 1, right? Right, quadrant 1 here. Then what's cosine theta of a quadrant 1 angle? Positive or negative?
Positive.
Positive. So do we need the negative root anymore?
Don't.
So maybe here you can say reject negative, or rather negative 1 over square root 2, since 0 less than equal theta less than equal to pi over 2. Q1 cosine positive. Okay, yeah, you don't need to give the reason. Just reject the just give me the correct value of cosine theta. So cosine theta is just the positive 1 over square root 2. So can you tell me what's theta now? Exact value. Same as square root 2 over 2 in case. Do we have an exact value for this? Don't have. It's actually square root 3 over 2, right? So in this case, we can just, what should we do? Did I calculate wrongly? Let me double check. Oh, wait. There is, sorry, my bad. This is actually just 45 degrees, which is pi over 4. Is it not? Did I calculate wrongly? We check, 45 degree, 1 square root 2.
But I get 0.785, which is, oh, okay, yeah, it is.
Correct, huh?
Yeah.
Okay, good. Then in that case, it's pi over 4. Okay, so yeah, actually, let me think a little bit. Yeah, this is square root 2 over 2, which is 45 degrees. Okay, so it's just exact value from A max. Don't want to dwell too much on it. So if x equal to 2, this one is simpler. We just sub in into the formula again. This time is x equals secant square theta. So 0 equals secant square theta, which is 1 over cosine square. 1 over cosine square theta equals to 0. So what do you think is the value of theta? The curve x equal to 2 and x axis. Okay, sorry, shouldn't be x equal to 0. I made a mistake. Can you see the mistake I made? What's the coordinates here?
1.
It's actually 1, 0. Sorry. There should be 1, 0. So what should be the lower limit here?
It should be 1.
Okay, good. Should be a 1. That makes more sense. Why? Because now when we have our lower limit, if it's equal to 1, I think it's easier to solve. 1 equals secant square. If it was a 0, we multiply like cosine square. 0 times cosine square is 0. So 0 equals to 1. Doesn't make sense, right? So it should be the original 1. So if you cross multiply, you get 1 times cosine square theta equals to 1. Solving, you get cosine theta equals to plus minus square root 1. But do you need the plus or the minus?
The plus.
The positive one. So you don't need the negative square root 1 or negative 1 because theta is in between 0 to pi over 2. So what is the value of theta? Draw a graph. So what is the value of theta? Sorry?
0.
0, very good. So theta equals to 0 over here. 0, 1. I mean over there. Okay, so we get our two values of our limits already, pi over 4 and so maybe you can take a piece of scratch paper during exam, then just write down all this working. Okay, theta equal pi over 4, theta equal to 0. Go through it step by step. So now finally we go back to our original integral. We get 2 times of, oh, by the way, do you know how I got this integral? Is it clear?
The 2 times of y.
Correct.
Yeah, can.
Integrate from 1 to 2 of the y. Then now you just have to replace the upper limit and lower limit with what we just found, which is the pi over 4 and 0. Just a hint, just advice for you. Upper limit I like to write on top. Lower limit I like to write at the bottom. So that when I get my 2 answers, I see on top and below. I also write down on top and below. I won't get confused between my limits. Some students will write down 0 on top and pi over 4 below. So just take note of that.
Okay.
And I'll also write down theta equals just to remind myself, yes, I have successfully moved to the theta world. So 1 down, 2 more to go. What are the 2 other things you have to deal with? They are the integrand as well as the dx. Must go into the the theta world completely. Limits change to theta already. So next one, maybe we deal with the integral, with the integrand. Easy. We know y is equal to what? Y equals to?
The cosine theta.
No. Look at the question. Is my handwriting too bad? Please read the question. Y equals tangent theta. Okay, so now how about dx? Don't know yet, right? So what do we need to do?
Must differentiate the x equals
Yes, correct. So let's just do that. Differentiate the x equals secant square theta. I need more space. I'm just going to shrink my working down a bit.
Okay.
You can zoom in later. So x equals to secant square theta, which means that we want to find dx by d theta now. Differentiate secant square, what do we get? It's not tangent. Please take note. Differentiate tangent, you get secant, but differentiate secant, it's secant square itself is a different idea. There's a chain rule going on, 2 secant theta. Then you multiply by the derivative of secant theta. What is secant theta? It's actually just cosine theta power -1 now. So if you try to differentiate this guy, what will we get? Chain rule again. Bring down the old power, -1 to get the new power. Then you have to times derivative of the inside, which is cosine theta, becomes negative sine theta. Is that okay?
Yeah.
Simplify, what do you get? Negative become positive. Sine theta on top, cosine theta power +2 at the bottom, so cosine square. If you simplify it down, you actually get sine theta over cosine theta multiplied by 1 over cosine theta, which is tangent theta secant theta. Actually, I believe this is available in the MF26. I am not sure. Okay.
I think it is.
Can? Okay, good. Then you can just sub in here. So that's why you'll get tangent theta secant theta. Simplify a bit more. 2 tangent theta secant square theta. Can? So what do we need now? We need to solve for dx, right? So dx will be equal to times the d theta over. Then that's how you get your dx. Is this okay?
Yeah, okay.
And then you sub back in. So now, no space. Shrink it down a little bit, and then we can write down over here times 2 tangent theta secant square theta d theta. Then you just have to why is there a plus over there? Did I do something wrongly? Yeah, okay, so far still okay. Let me just bring my working down to the bottom so that I have more space over here. So try to squeeze it on the right side so you don't get confused. So now that we have this guy, we can try to simplify a bit more. 2 times integral from theta equal to 0 to pi over 4. Then tangent theta times tangent theta is 2 tangent square theta secant square theta d theta. So far, okay?
Yeah.
Okay, good. Then how come they have look at the question again? They requested for tangent power 4 plus tangent power 2. How come there's a plus here, 2 separate terms? Here we only got one single term. What's the odd one out? One of these things don't belong. Which one?
The secant square.
Secant square, right? Because you have tangent, tangent, tangent everywhere, but suddenly got one secant square. So what should you do with secant square? Replace it with?
The 1 plus tangent square.
Yeah, you need to remember this or learn how to derive it. Memorize one of them, sine square plus cosine square equal to 1. This is a shortcut. Then you learn divide by sine square, divide by cosine square. Eventually you get to secant square equal to 1 plus tangent square. Do you need me to show you this?
Don't need.
Don't need, okay, then you can substitute in with 1 plus tangent square theta. D theta, everything else copy down. Copy, copy, copy. Then what do you get? Now you can multiply out everything. Hopefully you can see that this can be simplified down into, did I do something wrongly? Why is there a factor of 2? I think I did something wrongly. Let me double check first. Oh, right. Don't need a 2 times. Let's read the question again. Sorry. Show that the area of the region R bounded by the curve. Okay, so bounded by the curve, line x equal to 2, and the x-axis. Okay, so maybe this question is not so good. We should also mention, can you add on one more, if you have the question paper with you, add on one more part above the x-axis. Not just and the x-axis, should be above the x-axis. So we are focusing only on this 1/2 of the region. Sorry. Please correct that. Only focus on the top half.
Okay.
Which means that we actually don't need the 2 times. Sorry, you don't need the 2 times here. Don't need the 2 times here. Is that okay?
Yeah.
Okay, Ken, I'm so sorry. So this, now that there's no 2 times, there's a factor of 2, you can take it out. Then you're left with 2 times of integral from 0 to pi over 4 of tangent square times 1 plus tangent square. Multiply out, you get tangent power 4 theta plus tangent square. Is this okay?
Can.
So here we have shown already. Good. So now that we have shown, now we need to find the exact area, exact value of R. So R is equal to the above integral. Then we can just try to integrate this guy. Integrate tangent power 4. How do we do that? How do we do that? If only there was a previous part. Now it's currently part 3, part 4. If only there was a previous part of the question that could help us. Are you looking at the question paper?
Yeah. I'm looking at the
11 part. No, look at the question paper. That's all you have during exam. 11 part 4. How? We need, look at part 1 to part 3. Which one is useful?
Part 3.
Part 3 is tangent power 4, but negative pi by 4 to pi by 4. Here we got integral from 0 to pi by 4. Is there something simpler?
The second one.
Oh, so already answer is right there. Integral from 0 to pi by 4 of tangent power 4 dx is equal to pi over 4 minus 2/3. So that means that this is just, if I show you a bit step by step, it will be 2 times integral from 0 pi by 4 of tangent power 4 theta plus, d theta first, then plus integral from 0 to pi by 4 tangent square theta d theta. What's the mistake I made over here? Leave a gap here. Why did I leave a gap here? What's the mistake I made here? I'm copying your mistake.
The 2.
2, yes. Must have a 2, just like just now the pi. When you have a 2, there's an invisible, there's an invisible pair of brackets here and there. Then when you try to split up the integral into 2 separate terms, you have to distribute the 2. So that's why you have a first 2 over here and a second 2 over there. Okay, good. Now we can simplify. This guy, wow, finally we get the pi over 4 minus 2/3. So it was all connected. Then this one, 2 times integral of tangent square. Tangent square, if I am not mistaken. Yeah, you have to replace it with secant square theta minus 1. Okay, so 2 times integral of secant square minus 1. It's just a special identity. Then how do you integrate secant square minus 1? You can just do it term by term. So this will be plus 2 times of bracket tangent theta minus theta. But you have to change round bracket to square bracket. Put in the limits 0 to pi by 4. Is that okay? Is that okay? Oh.
Yeah. Can.
Can okay, good. So then you get this this answer plus 2 times of whatever. Then do I need to continue? Sub in and simplify.
Okay.
I skip, is that okay?
Can.
Can, you can work it out on your own. Let me know if you got questions. Just send, I'll answer you. Okay, wow, that was very slow. Okay, now this is part 4 of question 11. Let's move on. Oh, we're only at page 5. Okay, let's take a look at question 12, part 1. So the diagram shows the curve with equation y equals sine inverse of half x from 0 less than equal x less than equal to 2. Then we have R1 and R2. Actually, do I have the question paper? Oh, okay. Yeah, so over here, the question did not request for exact value. So you could just use the GC.
Oh.
Over here, your setup is perfect, is good, but then something went wrong with the integral over here. 2 times cosine of pi over 12. Okay, good that you identified minus minus become a plus. But cosine of pi over 12, actually there is an exact value, but you don't know its value. You don't need to know it. It's not required. So over here, you simplify as 2. That's wrong. Right? I think what you did is you key in this guy, you got 0.9999 and you approximate it as 1, is it? Is that what you did? Cosine? By the way, change to make sure you're in degree mode. Sorry, you're in radian mode.
Yeah.
If you're in degree mode, you'll get 0.9999895609, which is number 1. It is wrong because it's in degree mode.
Yeah.
Number 2, that's a
radians is
0.96592. So you know that it's not equal to 1, right? It's not a calculator error. No.
Yeah.
It's not equal to 1. Cosine pi over 12 is what? It's, if you look at the cosine graph, here is pi over 2. Then where is pi over 12? It's somewhere very, very close to the 0. Which means that it's very, very close to 0.1. So it's just slightly below. So it's actually the 0.9659, cosine pi by 12. Okay. So actually there's no exact value. You don't even need to calculate an exact value for this question. They did not request for it. Just use GC. Then key in. Do you need me to show you how to key in? This one? I can demonstrate. Do you want me to show you? If not, I skip. Mic test, I cannot hear you. Oh, you're thinking.
I also cannot hear you. I think that my connection.
Mic test. Am I connected? Mic test, can you hear me?
Just now, like the connection got problem.
Oh, okay. Is it better now? Can you hear me?
Oh, can you hear me?
Yes, I can hear you. Can you hear me?
Yeah, can. Just now it was breaking up the connection.
Oh, okay. Sorry. I'm not sure. Okay, so yeah, I'm saying that, do you need me to show you how to type this in the GC? Hello, I cannot hear you again.
Don't need.
Don't need. Okay, good. Can. Let's move on. Then moving on. So part 1 is easy, just type in GC only. Part 2 is the one that's a little bit more challenging. You want to find the volume of revolution when the region R1, not R2, R1. So it's okay, this is not relevant. I'm going to shrink it down. R1 is referring to, yes, this part here. Like, okay, I'll just draw a quick sketch. And this This is R1. You want to rotate this about which region? About which axis? About the x-axis. So 2 pi radians. Turn this around. So what should we do? We should always take top minus bottom, right? But here in this case, what you should realize is that there's a diagonal line here. All right, there's a very sharp turning point here. So that means we actually need to split it up. Can you see that this is really just a cuboid once you turn it around, but with a hole in the center? There's a big cuboid and then a small cuboid. Can you see that?
Yeah.
Can or? Then you just need to take the big cuboid minus very small cuboid to find the first half here. Then afterwards, the other guy, there's another triangle. You also need to take the big cuboid here, like this large rectangle. Or maybe one way that you could do it. Many ways to do it. You get a huge cuboid here, and then you subtract away this weird shape. You turn around, another weird cuboid looking thing. Okay, so you need to split it out into 2 parts. So let's see. What did you do? Okay, what did you do? You started off with equating to 1/6 pi. Then after that, you bring the sign over, get sine pi over 6, which is sine 30 degrees, which is a half. Then half equal to a half x. Solve for x, you get 1. Okay, that's fine. Then you equate to pi over 12. This one, this time you know that you have no exact value. So sine pi over 12, you just type in a calculator straight away. You get a 0.258. Here I think you are using degree mode, is it? Are you using degree mode? Let me see.
I think so.
No, degree mode will be 0.0045. Here we got 0.26489. It's wrong. How did you get 26489? Is my calculator wrong? Or you type wrongly?
I type now.
Yes.
But I got 0.2588.
I also got that. Yeah, so what I don't know what went wrong over here. I don't know where you get the numbers from. So yeah, error carried forward. Okay, so half x equals to 0.258819. Then you times 2. That's how you get the. You should get the 0.51763. Okay, good. So now yeah, how do you do it? You took that lower limit to 1, then you times pi in front. You take this square minus that square. That's not correct. Wrong. Cannot. Reason being, reason being there's a sharp turning point here. Okay. So actually, what you should do is to split it up. I'll just show you. So basically, this first light blue region, how do you find the volume? Then this orange region, how do you find the volume when you turn them around? So let's just work it out step by step. So I'll call this V1 and V2. So V1 is actually equals to pi times integral of what is this turning point here? Let me see the coordinates. Let me see. So it's 1 comma. Actually, no, I don't know the value. I don't know the x coordinate, but we worked it out already. When this is pi over 12 and this is pi over 6, you get a corresponding 1 as well as a 0, the correct value of 0.51763. Okay, so volume V1 is actually just pi. Oh, you don't need an integral. Sorry, this is just a cuboid. You have standard formula for cuboid. Pi times the radius square times the height. Can you tell me what's the radius square? For a let's say we treat it as big volume minus small volume.
So the big one is pi over 6.
Correct. Pi over 6. Then the small one will be?
So pi over 12.
So you fill in the blank, pi over 12. How about the height? If this is the radius, what's the height? It's this one, right? Which is? You start from 0 to 0.51763. Maybe I draw a nicer diagram, then it makes sense. What I meant is...
Is 1
No, it's 0.51763. Can you see? Up to here. You may draw a nicer
Is
diagram.
one?
No, it is not 1. It is 0.51763. Mic test, can you hear me? Mic test, can you hear me?
Wait, like it keeps breaking up. Wait, I'm not sure why.
Oh my goodness. Hello, mic test, can you hear me?
Can.
Oh my goodness. Sorry. Okay, I need to keep checking. I think my phone is heating up. That's why it's not so good. Okay. I'm saying no, it is not
Yeah,
1.
sometimes like it just lags.
Okay, I'm going to test for lag now. Mic test, can you hear me?
Yeah, now can.
Oh, it took 5 seconds for you to reply. I guess the lag is 5 seconds. Is that a correct assumption?
Now can hear, but just now got like very bad lag. Like you just like sounded like a robot.
Oh, okay. Sorry. Yeah, I think it's my connection and my phone heating up, the issue. Okay, let's continue now. The radius, can you tell me again? Should it be a 1? No, the light blue region. Look at the radius.
No,
I mean, sorry, the height. The height is not 1. The height is actually
the 0.51763.
yes, correct. So it's over here 0.51763, 0.51763. Maybe if I just draw a nicer diagram, what I am visualizing in my head is something like this. There's like a log, a huge log. This is in the background. And then there's a smaller log somewhere like here. Wow, this is testing my art skills. This is already invisible. You cannot see it. It's at the back. Can you see or not? Can you visualize what's going on? Like a toilet paper, toilet roll. Can you see the toilet roll? Is it clear?
Can.
Can. Yeah, so you take the big volume of the cylinder minus small volume of the cylinder. So that is only for the light blue region when you rotate the light blue region around. So big minus small. Straight away you can actually factorize out the pi as well as the 0.51763. And then you get pi over 6 square minus pi over 12 square. Okay, so this is your volume V1, but we're not done yet. We need volume V2. We leave that alone. We leave that alone. Later, then we combine. So V2 is now what? We actually need this part here, top minus away bottom, square. So that means it's actually what? Pi times integral of 0.51763 to 1 of, can you tell me what is it? Dx. Can you tell me the function? Mic test, can you hear me?
Sorry, I think the internet connection is my problem. Yeah.
Okay. Can you, so let's fill in the blank here. What should this be? My test, can you hear me? Oh no. So what should it be? Yeah. Can you hear me or not? Oh no, no reply. Hello, I cannot hear you. Let me send you on Telegram. Hello? Oh no.
Hello?
Hello, can you hear me? I heard one hello and then it disappeared.
Hello, can you hear me?
Now I can hear you. Yes. Okay, can I continue?
Can you hear me?
Yes, I can hear you.
Okay.
The light is very strong. is it a good idea if you leave the room first and come back in?
Okay, I try.
Yeah. Is it a good idea? I am not sure. Does it help? Mic test. Mic test.
Hello?
Can you hear me?
Yes,
Mic test. Can you hear me?
can.
Okay, now faster. Okay, that was a good idea. Leave and join back in. Okay, Ken, so now answer me. What is the integral? What should it be? To get the orange region, you must take the what minus what? Or tell me in full. What should be in the middle? Open bracket.
Is integrate like y?
But okay, more exact. You can't just put a y, right? That doesn't, you can't solve the question. What should be here to get the orange color region? Rotated about x-axis. Volume of revolution.
Pi over 6 square minus but it's a triangle.
It's not a no, it's not a triangle. This is a smooth curve. This is not a straight line.
Oh.
What function is this? The bottom?
The sine inverse x.
Sine inverse. Can we just leave it, or do we need to square it?
Need to square.
Need to square. Must remember, always top square minus bottom square. Top square minus bottom square. Okay, good. They did not ask for exact value, did they? They didn't. So just use GC. Just use a GC. All right, good. So yeah, then you get some calculator value. I'll leave that to you to type in a calculator. Then eventually just take these two answers. Total volume V is equal to V1 plus V2 equals to ... Oh, that is one way that you can do it. Then you get your final answer. Okay. Yeah, you eventually get to 0.510. Okay, moving on. Unit square. Sorry, unit cube, because it's a volume. Yeah, so this answer is wrong. Yeah. Okay, I'll just move on. Let me know if you got any questions.
Okay.
Okay, now for part 3, unfortunately, we cannot use GC anymore. They said without using a calculator, find the exact area of the region R2 bounded by the curve, the lines x equal to 1, x equal to √3, and the x-axis. So what do they want? Exact areas of region R2. So it's really just this region R2. How they want to find this exact region. How do we do that? Well, we have to integrate from sine in of the function. So let me see your working. Sine inverse from 1 to √3. Yeah, perfect. Yeah, that's all. Then now you need to try to integrate this sine inverse. You pick u and use integration by parts. That's correct choice. So sine inverse you pick as u, dv by dx is a 1. Correct. Integrate, you get x. Okay. Differentiate, you get 1 over 1 minus square root the function square. But here is a mistake. You remember there is a half x in front. It's a function in a function already. So you need to use chain rule. You need to differentiate half x to get an extra half. I think you didn't do that. So your derivative is wrong. Then error carry forward all the way. All right. Is it okay if I skip this question? Because your answer is wrong.
Okay.
Can I ask you your error carry forward? You must remember, they are always tricky, very tricky. If you see just a half x, if you see a half x, not an x, you cannot just use the formula list anymore. It is different, right? It's slightly different. There's an extra half, you need to differentiate the half x as well to get an extra half. Oh, use the formula list, but use it smartly. So yeah, this part is okay, but that part is not okay because you missed out a half. This is extra. This should have an extra factor of half. So error carried forward. I don't go through already. Okay. The rest is confirmed wrong. Yeah. So it's not. Yeah, you can check the working in the answer key for the method 1 and method 2. Okay, moving on. Oh, actually, the what you did was a method 2. Maybe it's worth discussing this method 1. So what they do is they interpret the hold on a second now. Let me think a bit. Minus 1 times. Oh, sorry. Give me a moment to think about this. 1 times pi over 6. Integrate 2 sine y from here to. Oh, right. Okay, there's another way to do this question. Okay, that's under method 1 if you're looking at the solution now. Let me explain to you what they are doing with method 1. This is still under question 12. Sorry, I am going very slowly. Let's take a look at this curve. So what happens here is that they have another way to interpret this by thinking of it as integrating with respect to y. Okay, integrating with respect to y. So let me draw some dotted lines here and there. Then what they are doing is they are finding out the area under they are finding out the area under this entire curve, which is actually a rectangle. Can you see?
Yeah.
Cross. Then after that, where's my R1? It's actually here. R1. Then you just have to take away all the white color area. Can you see?
Yeah.
So how they took away those white color area, instead of treating it as this weird quadrant shape and then this curvy triangle, which is a bit difficult to find, what they did is they split it over here so that they have a rectangle shape here, and then you got a weird shape here. But this weird shape, lucky for us, it is underneath this curve, which if you reinterpret it, the current function is y equals sine inverse of half x. Then you can just make x a subject. So bring the sine over, then times 2, so 2 sine y. Do you understand how I got from here to here?
Yeah. Okay.
Yeah. Yes. Okay. Good. I'm skipping a few steps. Bring the sine inverse over. You get sine y. Then half x equals to sine y. Then times 2 to get the 2 sine y. Okay. So now you can actually integrate. Maybe we also know we need to find out the coordinates. Here it's a pi over 1/6 of a pi. There was a R1 bottom. Here is 1 over 12 pi. That is not relevant anymore. We need to find this new coordinate, the y coordinate. If x over here is equals to square root of 3, this implies that y will be equals to what? Sine inverse of square root 3 over 2. But square root 3 over 2 is an exact principal value. So in that case, it would be 60 degrees, pi over 3. Okay, this is 1/3 of a pi. Is that clear?
Yeah.
Okay, good. So now we can set up the integral already. You just have to take to find R1, it's really just finding out the total area of this rectangle minus the area of this pink color rectangle. Then you minus away another red color area. Does it make sense?
Yeah.
Maybe I'll call this the gray color rectangle. So in that case, I'll use blue color now. Your total area of R2, maybe I'll label it like R2, is actually equals to gray color rectangle. Then you subtract away pink color rectangle, the small one. And then you subtract away the red color region. Subtract away the red color region. So that is really just what? 1/3 of a pi multiplied by square root of 3. That's the gray color area, rectangle area, minus away the pink color rectangle area, which is, there's a 1 here. 1 times pi, 1/6 of a pi. So far, okay? Gray and pink?
Yeah.
Then you subtract away the area of the red color region. This one, you integrate with respect to what y. So you go from bottom to the top. So here is 0, then so you start from 0, you go all the way up. So it actually goes from pi over 6 to pi over 3, right? So it should be integral from pi over 6 to pi over 3. Then the function is what? 2 sine y. Then with respect to d what?
Y.
Very good. Then this one you can just try to get the exact value. I think this is easier to integrate. Correct or not? Easier to integrate? This?
Yeah.
Negative cosine, right? Why? Sorry?
But a bit hard to see though. Like
A bit hard to see. Okay lah, yeah. This curve and then with respect to the y-axis, you must get familiar with it.
no, like I wouldn't think to do the gray triangle. I will just like integrate.
Rectangle. Oh yeah. Then you need to make sure that your integration by parts is perfect. Especially with your half x. You will forget the half, then error carry forward, you can't get the correct answer. This one, they are thinking, so this method is what they said preferred, and actually I also agree. Actually, it's a little bit more creative, but it makes your work a lot easier. Integrating sine is a lot easier. So maybe next time if you see sine inverse, you must think, wow, so troublesome, need to do integration by parts. If only there was a lazier way. Then you must think of this question. Bring the sine over. Sine y equals whatever. X equal to sine y. Oh, then you make x a subject, it's easier to integrate. So you try to integrate with respect to y instead. Okay, think lazy. Wow, integrate this one, so lazy. If only there was an easier way, then you'll maybe come across this method. Hopefully you can think of it during A levels. Okay, moving on. This is the volume question 12 part 3 done. Let's move on. Do you want a short break? Actually, I also need to use the toilet a bit. Can we come back in like 5 minutes? Can do you need to rush off?
Can.
Okay, we have a short 5-minute break. We'll come back in 5.
Okay.
Mic test. Okay. Hi.
Hello.
Okay, let's continue. Are you ready? Or can we
Yeah.
a bit? Can I?
Can.
Okay. Let's take a look at question 13a. You want to integrate this x times ln x bracket square dx. So you want to show that it's equal to that integral. So what you have done is you haven't shown it. It doesn't look like what they are trying to get you to demonstrate, right? X squared over 4, you got x squared over 2.
Yeah.
So something went wrong. You're supposed to have 1, 2, 3, 4 terms with a plus c. But here you only got 3 terms, which is wrong already. So let's see your working what happened. You pick u to be ln x squared bracket square, that's okay. Then dv by dx as x, that's fine. This one integrate, you get x squared over 2, okay. This one differentiate, wrong already. D by dx of ln x bracket square. You must see the outside function. What is it? Power 2. So what do you do? When you differentiate, bring down the power, inside keep the same, minus 1 get the new.
2 ln.
Yeah. What else is missing? Inside the bracket is not just a single x, it's ln x. What do you do now?
That is 1 over x.
Times 1 over x. So that means you actually get 2 ln x over x. What do you write over here? Actually, I can't really read.
2 times 1 over x.
Wrong already. Should be a ln x, not 1. Okay? Okay, good. So now what you so in that case, I'll shrink this down a bit. So oh no. Shrink this down. Should be 2 ln x over x. So what you should end up getting if you use your choice of u and dv, you will end up with dot 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 equals to integral, uv, right? So it's x squared over 2 multiplied by bracket ln x squared minus away the integral of v du. So it's x squared over 2 times 2 ln x over x dx. Coincidentally, 2 cancel off. X squared and x can cancel off one copy of x. You simplify it down to x squared over 2 times bracket ln x squared minus away integral of x ln x. So what you've essentially done is you have brought the power down. Do you see that? Ln x power 2 become just a ln x power 1. This is called power reduction. If you intend to study engineering or go into any of the science fields, you will eventually need to know this. It's called a power reduction formula. They'll start off with power n, then you have to change it to n minus 1. And then you come up with a general formula, and you need to know something that has already been removed from your syllables, called the recurrence formula. It's been removed from your syllabus. It's in further math. But if you are planning to study anything else, you don't need to know. Okay, moving on. X squared times ln x bracket square over 2 minus integral x ln x. How to do that? So u dv by dx, differentiate, you get du by dx, integrate, you get v, equals to maybe, what do you think it will be your choice for u and dv? Liate,
The u is ln x.
Very good. Then dv by dx is the other guy, x, right?
Yeah.
Okay, differentiate, you get 1 over x. Integrate, you get x squared over 2. So you just fill in the blank now. uv minus vdu. So minus square bracket first. I don't like minus. I get very confused by minus. So I like to draw square brackets. Later, then I deal with it. So let's do uv first. So x squared over 2 multiplied by ln x. Of course, it's the same. I'm just swapping it around. U times v and v times u is the same. Then minus away the integral of v du. So it's x squared over 2 times 1 over x. Don't forget the dx. Anything to cancel? Yes. X and x squared cancel off. You're left with x over 2. So integrate x over 2. Maybe I can factor out the half first. So negative half integrate x dx, which will give me negative half x squared over 2, which will simplify down to negative x squared over 4. Is that okay?
Okay.
Then plus c. But wait, now we still got square bracket. So here I'm doing the lazy way. This guy simplify as this guy with the minus simplify as this guy, then finally this guy. Now I change it to red font and I continue my working. I'm being lazy. I don't want to copy and paste the rest. So I just skip the rest, bring down. So this will be equal to Okay, no choice. I have to copy and paste the x ln x bracket square over 2. Then minus square bracket. Remember minus square bracket now you bring in. So minus x square over 2 ln x. Then minus bring into the minus over here. It becomes a plus, right?
Yeah.
So plus x square over 2. What's missing?
The
Indefinite integration, don't have. So plus c, very good. Then that's your final answer. Okay?
Can.
Okay, shown already, shown. Okay, Ken, moving on. So now part B, find the integral of 1 minus cos 2x. Wow, that is quite challenging actually. Because you need to, one method to do it is to use something called the Weierstrass substitution, which is in further math and you don't need to know that. If this, actually, that's only if it's like integral of format like this, a plus b times sine or cosine of x. In this case, you try to integrate this format, right? You need to do something called Weierstrass substitution.
Oh.
You do not need to know this. Okay, here it's a lot simpler. You can just, yes, you use the identity. Cosine 2x is really just cosine square minus sine square, or you can use another formula, which is 1 minus 2 sine square. This one is available in the formula list MF26 for A levels. Then you can just find out what's 1 minus cosine 2x, or you just sub in the cosine 2x. So sub in, you get 1 minus 2 sine square. Subtract away the 1 minus 2 sine square, you get minus 1 plus 2 sine square, which is positive 2 sine square. Okay, good. Then you integrate, you factor out the half, then you integrate 1 over sine square. Simplify that as cosecant square. Then you realize it's negative cosine x if you integrate. Oh, no, negative cotangent x. Okay, good. Then get negative cotangent x over 2 plus c. Can. Moving on. C part 1. Let me read the question first. The curve C is defined parametrically by x equal t square, y equal ln t, t more than 0. Region bounded by the curve, y-axis, and the horizontal lines y equal ln 2, y equal ln 3 is denoted by letter R. Part 1. Sketch the graph of C for 4 less than equal x less than equal R, indicating clearly the coordinates of the endpoints. I am not sure how the curve looks. Let me draw on my GC. Maybe I'll share screen as well. Okay, I am now changing the screen to the GC. Note to myself, please remember to change the mode back to the. Okay. So x is equal to what? T squared. So you write down t power 2. Then the y is what? Ln t. So we write down ln t. Close bracket. Draw the graph. Oh, that's a bit small. So we zoom in. Maybe zoom box. Move a bit here and there. Move a bit to the right. Go down. Okay, close enough. Maybe I'll just change the y maximum to maybe like 1. Okay, so that's how the graph looks. So yes, you have sketched it correctly. Let me just find the intersections since I'm already here. Second, calculate, find the value. Okay, I can't exactly find the intersection here, unfortunately, because this is a parametric mode. So I'll just clear this. I can quit. Oh, I have to trace it and approximate. Where is my cursor? Over here. So you can approximate it as some value over here. What is the value? Is it 1, 0? I guess so. Should be. Then in that case, you can actually confirm it by doing it manually, subbing y equals to 0, and then you solve for x. Solve for theta first, then solve for x. Okay, I think that's also what we're going to do. We're gonna find out the exact values manually. Okay, now I'll change back to my iPad screen. Okay, so over here, if we have, let me copy the function first. If we have x equals to t squared, y equals to ln t, t more than 0, when we have y equals to 0 to find the x-intercept, that means that ln t is equals to 0, which means that t is equal to 1, which means that x is equals to t squared, which is 1 squared, which is 1. Okay, so correct, 1, 0 is fine. How about when it's ln 2 and ln 3? Let's also find out the values. If y equals to ln, let's say 2, then we get ln t equals to ln 2. So t equals to 2. So x equals to 2 square, which is 4. So that means over here, it will be a 4 comma ln 2. Over there, the other coordinate, let's say we sub in y equals to, this time is what? Ln? Can you tell me?
Oh, 3.
Ln 3, exactly. So that means that we'll get what? Ln t equals to ln 3, t equals to 3, x equals to 3 squared. Then you get 9 comma ln 3. Okay?
Yeah.
Okay, good. So now we have to sketch the graph from 4 less than equal x less than equal to 9, indicating clearly coordinates of the endpoints. So here your graph wrong already. Do you know why? Because they already stated the domain 4 less than equal x less than equal to 9. You gave me extra. You gave me the parts that's 1 comma 0. So that means wrong. Your graph should actually just be these two part, this part of the curve only. So the graph is very simple. Just like that only.
Oh.
You label the points 4 comma ln 2, 9 comma ln 3. That's the graph that they are expecting. Your graph is too much already. To the left, to the right. And also you didn't label the coordinates of the endpoints. Here, solid circle for both. Why? Because they said equal on the 4 and equal on the 9. X can be exactly equal to 4 and exactly equal to 9. So that means you can include both points. Okay, that is C part 1 done. Any questions?
No.
Okay, moving on to part 2, C part 2. Without the use of a calculator, find the area of the region R. Where is R? Let's read the question again. The region bounded by the curve C, the y-axis, so curve C, y-axis, and the horizontal lines y equals ln 2 here, and y equals ln 3 there. So where's the intersection? Correct, you have shaded it correctly, this region here. So I'll color it in purple. That region, we want to find the area. So since it's bounded by the y-axis, what's the smartest choice to pick here? To integrate with respect to which axis?
Oh, the y.
Y-axis. Yeah. So let's see your working. You have if what is going on here? Okay, let me see your working. So here you try to find out the y values, right? We know that y is equal to ln t and x equal to t squared. So what do you do over here? You realize that the x value equals to, why do you have a x equals? Wrong already, because you're trying to integrate with respect to y, right? What are the limits here? Should it be x equals or y equals?
Y equals.
Should be y equals, right? How come you find the value of x? You found the value of x. That's wrong, right? You get what I'm saying?
Yeah.
If you try to sub in, also by the way, this ln 2 and ln 3 is exactly equal to the y value. So you cannot replace it with ln t. Ln, it's not related. Okay, this is sort of like a ln x where x equals to 3. Actually, also not correct. Ln 3 is just a number itself. You basically, it's not really relevant to ln t itself. This ln 3 and this ln 2 is y itself. Do you understand the idea? This is a x value, x equal to 9. This is a y value, y equals to ln 3.
Yeah.
Okay, so that means that your substitution here got a major problem. This is wrong. Do you understand why it's wrong?
Because I find the x when I integrate y.
Yes, correct. And also, yes, that's the first problem. Then also another major problem is I think you don't understand what x equal to t squared and y equal to ln t means. Here, there's a parameter t. So x equal to t squared with a square, you can only substitute in with a value of t. Here, you substituted it with ln 2, is it? And you substitute in with ln 3. Is that what you are thinking?
Yeah.
It's wrong. It's wrong. Right? You can only do that if this is a y. If it's x equal y squared. But that's not true. These ln 2 and ln 3 are y values. So you can only sub in if the formula is saying x equals to y squared. But that's not the case. Do you understand now? You're not allowed to sub in ln 2 and ln 3 here.
Yeah.
The t value is also not 2. T value is not 3. The t value is something else. It's actually it is. Oh, sorry. The t value is 2 and t value is 3. So it's actually x equals to 2 square and x equals to 3 square. If you want to find the correct x value. And if you try to sub that in, you actually get back to 4 and 9. Right. So yeah, this is total nonsense. This is not even correct. This substitution, it doesn't even make sense. Okay, but anyways, let's just solve the question. So we want to find the y values. Here I have already found it, ln 2 and ln 3. So it's just ln 2 to ln 3. Then you integrate correctly. It's e power y because the function is what? The function is a. Wait, actually, let me see. Are you supposed to? Okay, the point of this question, right? When they give you parameter, is for you to integrate using the parametric form. Use parametric integration. But what you did here was you found out the actual function in the explicit form in terms of e power y.
Convert to non-parametric.
Correct. Very good. That's actually also since they never state the method required to get the answer, it is fine. Your method is okay. Let me show you. So how do you get that? So maybe you did something like this. Y equal ln t. Bring the ln over, you get e power y equals to t. So t equals to e power y, but x is equals to t square, which is e power y square. Oh, so you can just simplify a bit. Then you get x equals to e power 2y. Bring the ln over. So ln x equals to 2y. So y equals to half ln 2. Sorry. What? Maybe you should make x a subject. Then that's all you need. That's all you need. Because you're integrating with respect to y. Then you sub in e power 2y. Oh, so it's actually still not correct. Hey, wait, actually. Oh, you have a square here. Oh, okay. Yeah, it's correct. This is fine. Limit is wrong. dy. Okay. Then I think I don't need to go through the rest, right? For your method. But now I'm going to go through with you how to do it parametrically. Okay, so how did they do it? I think your parametric integration is not good.
Yeah, it's not good.
Okay, so first we need the graph and then we need the parametric. So I'm just gonna take a screenshot and then I can speed things up a little bit. So this was from the previous page. I'm gonna zoom in. How do you integrate this? What you need to do is to realize that area here is equals to integral of x dy from y equals to what was that? What was that value? Ln 2 to y equals ln 3. Is this part okay? The setup.
Yeah.
X being a function of y. But now you have to do what are the 3 things you have to deal with? Can you tell me? When you want to convert.
The limits.
Okay, number 1, the limits. What's the number 2?
Like the need to differentiate y.
Okay, so dy need to turn into
dx. Oh,
t. No, it's always the new variable t. Sorry, I reviewed the answer too fast. I should give you some time to think. So you should always convert from the current independent variable into the parameter. What's the number 3?
Like the expression must sub in.
Very good. The expression, or what is technically called the integrand, not important. Integrand need to sub in. Yes. Okay, so you got it. So let's just do that. So the limit here is ln 2 and ln 3. That's your first barrier, first difficulty you must overcome. You need to know that y equal ln 2. So how do you find the t? Equate it to ln t. So because over here, you see, x equal t squared, y equal ln t. So over here, we can replace the y with ln t equate to ln 2. So t equals to 2. Then what do we do? That's it already. T equals to 2. That's your upper limit. Oh, sorry, that's your lower limit. So maybe it will be smarter if I just put it at the bottom. Then at the top, I put down y equals to ln 3. Okay, this is totally extra. You don't really need to do the top and bottom thing. You just make sure you sub in the correct limits, then you won't have any trouble. So t equals to 3, right? So that means I can sub in my upper and lower limits with 2 and 3. Is that okay?
Yeah. Okay.
Then x, x replace, okay, maybe we do step 2. dy change to dt. What do you have to do? Start with what? Do you start with x equals t squared, or do you start with y equals to ln t?
Start with y.
So ignore this, then you differentiate, right?
Yeah.
Y by dt equals to 1 over t. Then make what as a subject? You want to substitute dy, so make what as a subject? dy.
Y, yeah.
1 over t dt. So you can substitute in the dy with 1 over t dt. 1 over t dt. Are we done? No. Step 3 now. Expression sub in. So x is equal to what? Remember, you're going from the y world into the t world. From Singapore, go to Malaysia. Must change the currency. What is x equal to? Hint.
T square.
Exactly, t squared. Then you're done. Is it easier now?
Oh, yeah.
Understand or not? Just 3 steps only. Limits change, the expression, the integrand change, then the dy differentiate, then you make dy the subject and sub in. There you go. So now you just need to simplify this. I think this is a lot easier to find, right?
Can
Look,
it be like y dx?
Can. If you're integrating with respect to x, can.
Okay.
If you're trying to find area with respect to x. But here currently we're finding the purple region now, which is with respect to y. That's why we do x dy.
Oh, okay.
Can understand now? Okay, okay. Good. I hope you're starting to understand. Yeah, this one is dy. This one is dx. Yeah. Maybe I should label this guy is integral y dx, this guy is integral x dy. Then maybe I'll call this AB, so it will be AB. And if I call this CD, then this will be CD. Can you understand?
Okay.
Maybe I don't use AB and CD, a bit confusing for you. So I'll just use actual numbers. I'll use like, I don't know, 5, 6, and 5, 6. This one is 8, 9. This will be 8, 9. Hopefully you can understand what's going on. So now we can just simplify. T squared over t is just a t. Then you don't forget the dt. Do you realize how simple this is to integrate now?
Yeah.
Much easier compared to your integral of what was the thing? E power 2y. Okay, also quite easy, but this is even simpler. So t squared over 2, sub in 3 and 2, get 3 cubed over 2 minus 2 cubed over 2. Yeah, blah, 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 you can get the answer. Okay? Okay, moving on. Okay, now question 14. This is a weird question. Huge graph with a very weird shape. Let's read the question. The diagram shows the curve C1 and C2. Maybe I'll just draw a quick sketch of it. Okay, there's a y equal -1. There's a set face. There's a volcano here and there. Then there's a very weird cosine phi x square graph. Looks something like this. Looks like a bat. Looks like a bat. I'm not sure. Looks very weird. This is C2. That's a C1. And then you have a region R. I'll just color it in gray. Supposed to be symmetrical. Sorry for my art skills. Supposed to be symmetrical. Okay, close enough.
Yeah.
So can okay, good. So read the question. Diagram shows the curve C1 and C2 given by the equations y equal 1 over 4x squared minus 1 and y equal to 2 minus cosine phi x squared respectively. C1 cuts the x-axis at x equal -½ and +½ So over here it's a -½ there is a +½ there and there. And C2 has a y-intercept at y equals to 1. So over here there's a 1. The shaded region R is bounded by the curve C1, C2 and the x-axis. Okay, so basically the shaded region is this gray color part. Part 1, state the coordinates of the point of intersection between the curve C1 and C2 correct to 3 decimal places. Just use the GC. Let me see if you get the right answer. I'm just checking the answer now. Answer key. Oh my goodness. Why is it upside down? Oh no. That's bad. Let me sorry, give me a moment to. Oh, okay. I have to flip the page for you. Sorry.
Okay.
Yeah, I'll do it later. I'll edit the file and send you. Okay, so let's see. This question, using the GC, you got these 2 points. Yeah, correct. Good. Can. Perhaps it would be better if you use the more exact value as an intermediate working, because you might have to use it later. Oh, so you don't have to keep on referring to your GC. Write down the strong, the more accurate working, and then later final answer you round off 3SF is fine.
Okay.
You might have to use these values later. Okay, then moving on. So part 2A, since both what is part 2A talking about? Let's read the question first. So for part 2A, if I can just see the question. Part 2A, find the volume of the solid formed when R is rotated through 4 right angles about the x-axis. What does that mean? It just means find volume of revolution. But what is the key thing you have to identify is that sharp points. Always identify sharp points. Do you understand what I mean by sharp points? Can you draw on the diagram? Where are the sharp points on this graph?
Like here. Oops.
And
here.
Correct, very good. So those are the sharp points you must identify. And then you need to draw vertical line drop down because it's with respect to x-axis. So you sort of cut the volcano into 3 parts. Now these 2 are supposed to be symmetrical. Sorry, my graph not very nice. Can I just try and make it look a bit nicer? Yeah, something like that. Okay, and okay, you need another leg like this. Okay, then make it look almost symmetrical already. Then we can like this. Yeah, okay, close enough. So it's now symmetrical. Then what we want to do now is we want to take each region, rotate, rotate, rotate. Why do you have to split it up like that? It's because every time you try to find a volume of revolution, it's top minus bottom. Top minus bottom.
Yeah.
Top minus bottom. So because of these sharp points, the top and the bottom is now slightly different. Okay, the bottom is always x-axis, so it's fine. But the top function is different at the sharp corners. Okay, so we already found, and that's also why they requested for the coordinate of the points. So here is a negative 0.340. There is a positive 0.340. And then now we can proceed to find the volume. Let me see if you did it correctly. So you take 2 times of pi times the integral from 0 to 1. Where is there a 1? Why got 1? Where got 1? Okay, let's continue reading. Of 1 over 4x square minus 1, then you square. Why got 1 over 4x squared? Oh, wait, I'm confused. All right, it's from the question. Okay, 1 over 4x squared, sorry. Minus 1, then square, minus away the other function. Square is not there. Square is not there. You see that there's no square here?
Yeah.
So that's the first mistake. But top square minus bottom square, you integrate from 0 to 1. Can you tell me why you chose 1? Why 1? Is it you're reading like this? 0 to 1. Are you seeing here from 0 to 1? Here is like oh, let me get rid of this. 0 to 1. Is that what you're seeing?
I think so.
Wrong. No. For volume of revolution, must remember the pattern is like this. There's a curve, and then there's a, let's say another curve like this. This is the top function. That is the bottom function. And let's say there's a region from x equals to A to x equals to B. This is region R. Then you want to find the volume of revolution. What would it be? V equals to pi times integral of top square minus bottom square dx. But you go from what to what? A to B. A to B. So you need to identify your A and B first. Where's your A? Where's your B? How can it be 0 and 1? I don't understand. The region is only from negative half to positive half. Where got 0, where got 1? You get what
Oh,
I'm saying? You only because you're integrating with respect volume of revolution about the x-axis, so you focus on the x values. And this region, x values only go from -half to +half. Where got 0, where got 1? Here got 0, but where is 1? 1 is far, far away. Not relevant now.
yeah,
Oh.
I think I see wrongly.
Yeah, so not vertical axis, it's along the horizontal because integrating with respect to the x dx. Okay. So how do we do this? Let's just do it. Maybe I'll call this R1, R2, and R3. So I hope that by symmetry you can see that if you take R1 you rotate, you take R3 you rotate, they are the same, right?
Yeah, same.
So that's why I think that's what you are thinking about this 2 times. But actually there's an even smarter way. Maybe we can do the following. You see, an even smarter way. I'm going to split it up into 4 regions. This is the first one. Here is the second one. Can you see maybe I use different color. First one, second one, third one, and then the fourth one. What you should realize is that light blue and purple is the same because of symmetry. Gray color and orange color is also the same. So that means if you want to find the total volume of revolution of these 2 rotate, or these 4 regions rotate, isn't it just the same as finding 1 region and then you rotate and then you times 2?
Yeah.
Right. So that's a creative way of solving this question. So you just need to, you don't need 1, 2, 3 anymore. You don't even need the negative coordinate. I prefer positive numbers. That's why I focus on the right side. So I just need to take the purple, I rotate. Take the orange, I rotate. Find the volume, each piece, add them together. Is that enough? No. You still need to times 2 to get the other half. Do you get the strategy now?
Yeah.
Okay, so now can you tell me what would be the total volume? Total volume equals to, let's look at the purple. Let me rotate. Okay, I'll write it down in picture form first. Add on the orange color part. Like a fun little primary school game. Just draw pictures and then you rotate. It's useful. I feel that this is useful. And then after that, times 2. Right? So I like to write it neatly. So I write down 2 first in front, multiplied by square bracket, volume of the purple region. Try. Pi times
the 2 minus cosine pi x square square
the whole thing. Good. Minus 0 square. So you don't need to write it down. With respect to x-axis. D. About x-axis, so is D.
The 1 minus 4x square minus 1 square.
No. Oh, sorry. I have dx first. Okay, so you're gonna. Oh, sorry. Oh, right. Yes, you can just do that. Minus away. Oh, wait. Do you say minus?
Plus.
Plus. Okay. Much better. Plus the 1 minus 1 over 4x square minus 1. Bracket.
Square.
Okay. Then D.
Dx.
X. Okay, good. This is orange part. But something is missing. Limits. What's the limit?
Think cannot put together. Because it's different.
Yes, exactly. That's why I'm a bit confused. How come you can suddenly plus? I wanted to end off your dx already. Okay.
Cannot. The limits are different.
All right, very good. So now you have to split it up. So let me show you this one. Tell me the mistake I'm making.
The pi in front.
Pi is missing here. Very good. Okay, please remember. Okay, then limits. Why is it?
The 0 to 0.340, then 0.340 to half.
Very good. And then did they request for exact value?
3,
Did they read the
no.
question? No, then just use GC. Understand?
Oh, okay.
You must know when you can take shortcuts. Here, never ask for exact value, just use GC. Okay? The setup is what they are looking out for. Okay?
Can.
Then don't forget 2 times. Okay, that is for part A done. Then how about part B? 2 right angles about the y-axis. 2 right angles is 2 times 90 degrees, 180 degrees. How come volume of revolution this time is 180 degrees, half of 360? Does it mean I times half straight away? So I cannot get the total volume, I just times half.
No.
No, if you read my comment in the question, I said, Qi, no, it is still a full volume, still quite standard. It is still a full volume. Okay, basically you must visualize this one. It's because it spans 2 planes. It spans Q1 and Q2. So you got 2 pieces here. If you rotate 180 degrees only, you'll sweep out a region that is already a volume of revolution. You'll get the full volcano. Can you see the volcano?
Yeah.
Yeah, so that means if you want, you can just find out take one of such region, then you rotate 360 degrees. It's the same thing. Okay?
Yeah.
And so how would you do it? If you want to rotate about y-axis, it has to be dy. So what do you need to do with your functions? Can you still let it be y equals y equals?
Cannot.
Cannot, you need to make x the subject now. So is there a simpler way? Because I see, y equals to y equals to, what is that function? 2 minus cosine phi x squared. I want to make x a subject. I need to cosine inverse. That's so difficult. If only there was a simpler way. Is there any simpler way? Okay, probably not. Actually, thinking about it. Yeah, not really. Okay, so never mind. It's okay. It's okay. We will just deal with it. So we have to make x the subject. So let's start with the 2 functions first. This is what question is this? This is still question 14 part. Oh no, 14 part 2 part B. First thing you must do is convert into x. Make x the subject. So what we have is y equals to 1/4. Sorry, 1 over 4x squared minus 1. Make x the subject. How do we do that? Bring the 1 over y plus 1 equals to 1 over 4x squared. Flip it around. So we get 1 over y plus 1 equals to 4x squared. Then here, you can be strategic. I'll make x squared a subject instead of x. Do you know why? Because eventually you're going to find volume of revolution. What do you need? Pi times integral of top square minus bottom square. You still need a square. So that means you don't need to bother about square root plus minus anymore. You don't have to worry whether it should be positive or negative. Just take the square. Make x squared a subject. Is that okay?
So I make x squared the subject, so when I sub in, I don't square.
Correct. Very good. Yes. So no need to square once substituted into the volume of revolution formula. Okay, because it's already squared. Yes. Okay, good point. Sorry, I forgot to mention that. So how about C1? Oh, sorry, that was C1 already. So how about C2? Let's take a look at C2. It is y equals 2 minus cosine phi x squared. Sorry, there is no choice. You need to involve a cosine inverse. So maybe I'll bring this over. I'll get a cosine phi x squared equals to 2 minus y. Then you can get phi x squared. It's cosine inverse of 2 minus y. So how do you make x squared a subject? Just divide by 5. So 1/5 cosine inverse of 2 minus y. Okay, good. So now you got the 2x squared. How do you deal with it? Remember the shape of the curve? It was volcano, the region R. The top curve is what? The bottom curve is what? With respect to the y-axis.
The top one is 1 over 4x squared minus 1.
Yes, it's this guy, right? This is top. Maybe I'll highlight like this. This guy will be my top. Then this guy will be my, this guy will be my bottom.
Yeah.
But actually, you have to be a bit more careful now because let's look at the curve more carefully. If you look with respect to the y-axis, do you notice that if you want top and bottom, you imagine the parachute, remember this idea?
Yeah.
The gravity, imagine, is dropping this way. From here to here, up to this point only, maybe I need pink color. Let me change to pink color. Up to here only, like this, the parachute, if you drop down, the top curve is the C1, bottom curve is 0. Is that clear to you?
Yeah.
But if the parachute moves a bit more to the right, okay, he moves a bit more to the right, then he starts dropping down. What do you notice? Who's the top curve now? Still C1, but who's the bottom curve now?
It's C2.
It's not 0 anymore. So actually, at this point, you need to split the integral up. You understand?
But how I know?
Parachute idea? How do you know you need to split it up? Is that the question?
Yeah, so the original one cannot. It's still like slightly curved. No?
You see, if you take this C1 square minus C2 square, x square minus x square, you will not get a logical answer because here from 0 to 1, you try to integrate. If you take top minus away this curve, it's undefined. This one is undefined for the region from 0 to 1. This guy is undefined from 0 to 1. So I think that's also why you told me, I think you mentioned somewhere over here that it was undefined. Got error, right?
Yeah.
It's because this function here is undefined from 0 to 1. You see, the graph is floating above 0 to 1. From 0 to 1, it's undefined. Okay? You try to sub in, you will get something that's illogical.
So like that, I know I will have to like do y equals to 0 x equals to 0.
X? What do you mean x? We are integrating with respect to y?
Yeah, like if I get the errors, then I know I have to. It's not with respect to C2.
Sort of something like that, yes. But actually, more importantly, when you want to find volume of revolution with respect to a certain axis, you should think of the parachute idea. Just think of the parachute. You start from the bottom to the top, but you must land down from the right to the left. And then as you see, as he is moving, he lands here. The top graph is this region here. Can you see?
Yeah.
This is C1. Then after that, for the other half, maybe let me just try and make the quality of the animation a little bit better. So like this, let me try and improve it a bit more. I hope it's a bit faster now. Is it?
Yeah.
Lower quality, so that's why I can have smoother animation. So as you drop down over here, this part here, can you see it's the top curve? Then this part here is the bottom curve. Focus on his legs here. So like this. Oh no, I don't want the x-axis to move. This guy is the top. He drops down. This is the curve. Drops down a bit more. Bottom curve. Can you see the green color part I'm highlighting?
Yeah. Okay.
Then after that, for the other half, you drop down. Then you hit this part. This part of the curve is the top curve. Right? Then the bottom, you drop down a bit more. This part here is the bottom of the curve. Okay? That's how you split. That's how you see it. And also maybe you can recognize it as a sharp point over here when you view it from right to left.
Oh.
Okay? A sharp point. So you need to split it up. The function changes. Or you could, that's how you see it. Okay, so anyways, you need to split up at that point. So maybe I'll just take a screenshot of this so I can have an easier time setting up the equation. I'll shrink this and put it at the side. I know it's very blurred. Let me change the quality. Is it better?
Yeah, better.
Okay, good. Can I finally figure out how to do this? Okay, so the volume of revolution with respect to the y-axis now will be top curve minus bottom curve, but you need to split up into two separate regions. The first region, maybe I'll draw the curve again, and then like this, and then you split it up over here, right? So maybe I will call this region. Let me draw finish first. Hold on. Then there's a x-axis here, and there's a y equals -1 here. Maybe I will call this the light blue region. Can you see the light blue? I mean sort of just blue color. And there's also the brown color region here. Gray, brown. Top two. So this is the brown part. Sorry, the blue part, and then that is the brown part. We're gonna split it up like that. Okay?
Okay.
Then we're gonna find the area of those two. Maybe more like this. Okay, so we're gonna find the volume of revolution of those two parts separately. Let's find the first part, the light blue one, the blue one. Here it's 1, right? So we have to integrate from what to what? 0 to 1. But don't forget a pi in front. Then you have to do top square minus bottom square. So remember the parachute idea, top then bottom. So top is actually the C1, right? This guy is C1.
Yeah.
So here is C1, there's the x equal to 0. So that means we'll have C1, which we have found out to be C1 square, which is 1/4 times y plus 1. Do you still need a square? Don't need, because that's already x squared. So you get rid of that. Then you subtract away 0 square, because here is 0. Well, x equal to 0. Or x, so you need 0 square, but you don't need of course 0 square is just to emphasize to you that there's a top square minus bottom square formula. You don't have to write it. Then now you add on the second half, plus pi times, here what's the coordinates of the point now? The coordinates of that point, if I recall, okay, I cannot recall. I need to go back and check. 1.162.
Yeah.
0.340, 1.162. So here the y coordinate is 1.162. 1.162. This is 0.340. Not relevant anymore, the 0.340. We focus on the y coordinate because we are integrating with respect to y dy. So what should be the limits? Can you tell me? Now is this half, the brown region?
The 1 to 1.162.
Well done. And what's in between? I'll end off with a dy first. You need to figure this out. I cannot give you an answer. Think.
Hey, I forgot what is C2.
Sorry. Okay, zoom up.
1/4x square minus 1 square.
Wrong. You're still using x?
No, I'm using y.
Try again.
Oh,
Top minus bottom, Top here, bottom here. Refer to your question paper for the nicer diagram. Top, bottom.
Is 1/4 bracket y plus 1.
Okay. Need to square?
No.
Well done. Good. Then that's your top. That's your top.
Then minus the 1/5 cosine inverse.
Yeah, you got it. Just copy that one. 2 minus y.
Yeah.
Do you need to square that one?
No.
Typically, you need to, but here I made x square the subject. That's why you don't need. Special case. Okay. So we don't have to deal with the square root and the plus minus case. Square will always be positive. You don't have to think so much. Okay, good. So now that you have the setup, all you need to do is to type inside the GC. That's all. Is that all? Yeah, that's all. There is. Okay.
Okay.
Yeah. So learn how to draw the parachute. Okay, good. Can. Let me think. Is there anything else I should cover? Oh, the question, they did it a little bit differently. What they did is they took the entire curve here. Then they found this entire volume. So let me show you what they are doing. Okay, let me erase away. So what they did is they found this orange region first. Then after that, they actually want this inside region, right? So what they do is they subtract away this gray region. Okay, I don't use gray. Maybe I'll use purple. Okay, can you see? If you take the total orange minus away purple, you'll get the answer as well. Then you just rotate. That's what they did. So they found the volume of revolution from 0 to 1.162 of the 1 over 4y plus 1. That's this guy is 1 over 4y plus 1 x squared. Then after that, they subtract away. Okay, no, they found that volume first. So that is the orange color. But then that's not enough because we need to subtract away the purple region. This is orange. Then they subtract away the purple region. I'm running out of space. Minus away the purple region, which is from 1 to 1.162 of here it's easier. Do you see top and bottom?
Yeah.
Can you see? Maybe, yeah, okay, you can see top and bottom. So that means that all you need to do is to use the curve, which is the cosine, 1/5 cosine inverse. Do you need a square?
No.
We already have a square, x squared equal 1/5. So no need to square again. Yeah, so just no square, and then you subtract away 0 square dy. So that's what they give. Of course, there's also a pi. Sorry, I forgot the pi. You can factor out the pi if you want to. Okay, that's another way that you can do it. I'll highlight this in purple. Orange. Okay, that's another way. So the setup is what's most important. They don't want the exact answer. Just give the setup and then use GC. Is it clearer? I hope.
Yeah.
Okay, let's move on to the next question. Let's go to question 15. How much time do I have? Do you need to run away or another lesson?
No.
No, okay, good. Let's just continue. So 15 part 1, find the derivative of this guy giving your answer in its simplest form. So product rule, take one, differentiate the other, then chain rule minus 2x, good. Then add on 4 times sine inverse. So sorry. Oh, sorry. That's the first half. Take one, differentiate the other. Add on, take the other, which is 4 minus x squared power half. Differentiate 1, which will give you a 1. So here you shouldn't have an x anymore. Is it not correct?
Yeah.
Oh no, differentiation. You cannot get differentiation wrong. Take 1, then you differentiate the green. Then you take the green, and then you differentiate the purple. Yeah, it should be a 1. No. This should be a 1. Differentiate purple x, you just get a 1. Here you go and copy, you treat this as the entire function, you differentiate to get a 1. No. Thing got confused. So there's an extra factor of x. Then the 4 sine inverse differentiate, standard formula 1 over square root 1 minus x over 2 square. And just like your integration by parts, I think you forgot as well. Here is x over 2, so you need to use chain rule times half. Same mistake as your integration by parts. Remember, you need to use chain rule. So here you need to multiply by half. So everything, so error carried forward. I don't mark the rest already. You go work it out yourself. Differentiation. Okay, the final answer to that would be what is it? 15 or let me see the question. Let me see the solution. What do they have? 2 times square root 4 minus x squared. So let's just write down the final answer. The derivative of the monster expression. Let me change my font size down to x times square root 4 minus x squared. Add on 4 sine inverse x over 2 is equals to 2 times square root 4 minus x squared. So every time they give you this kind of question where they differentiate to get an answer, what they need you to do is to integrate both sides again. Confirm one. Always the same pattern. Oh. What happens if you integrate a derivative on the left side?
Then it just becomes the thing in the bracket.
Yes, they'll just cancel each other off, then it just becomes the things inside the bracket. Then you can integrate. So you found a new formula for the integral of 2 times square root 4 minus x squared. So now you take a look at part 2. Let me see your working for part 2. What is, let me read the question first. Part 2, hence or otherwise show that half of the integral of whatever equals to whatever, where a is to be found in terms of k, 0 less than k less than 2. Sorry. 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 Yeah, you need to show the integral. Then what do you do? I'm a bit confused. What do you do here? Okay, you got the wrong answer. That's why I got error carried forward. Should we try the question again? This is totally wrong already. Let's just try the question again. We do it together. Okay, so we know that the derivative of that guy equals to 2 times square root 4 minus x squared. That was from part 1. If you did it correctly, then this is now for part 2, hence or otherwise, we want to show the integral of square root 4 minus x squared with a half in front. So what you should realize is that it looks very similar to part 1. So that's exactly what we're going to do. Copy and paste, but then you integrate with respect to dx. Integrate with respect to dx. The integral and derivative cancel each other off. You're just left with the expression inside. Maybe I'll increase the font size and change the thickness a little bit. Then this will be equals to the integral of the right-hand side. This is very good because the right-hand side integral looks almost exactly like what we want. We want to integrate 0 to k of half times half of 4 minus x squared dx. How can we make this look like the integral there?
Like put the 2 in front, then become 1/4.
Very good, exactly. You know this trick. So times 2, then times 2. So it becomes 1/4. Okay, you simplify straight away, 1/4. Then this integral of 2 times square root 4 minus x squared, we already have the answer over here. Copy and paste. Copy and paste, right? Is that clear?
Yeah.
But don't forget, because now it's a definite integral, you need the limits 0 to k. Is that okay?
Okay.
Good. Now continue. Maybe it will be, I don't know, maybe it will help you if you use blank paper. Maybe you can see clearer with blank paper. And it also can save money. Printed paper costs money. Blank paper is probably cheaper. I don't know. For your future practice. Okay, anyways, now you just need to sub in. Sub in x equal to k. So k times square root 4 minus k squared plus 4 sine inverse k over 2. Then you bracket, subtract away. Maybe I'll put square brackets to make it look nicer. Minus away, sub in a 0. 0 times anything is just a 0 plus 4 sine inverse of 0 over 2. 0 over 2 is 0. So sine inverse of 0 over 2 will be just sine inverse of 0, which is 0. Then you get 4 times 0, so it's just a 0. Okay, very nice. We don't need to deal with the zeros, so we just focus on this front part here. Simplify a bit. Actually, nothing much to simplify. We just need to show that it's a times square root 4 minus k squared plus sine inverse k over 2. So just times the 1/4 in. You get k over 4 times the square root whatever plus 4 times 1 over 4. So it's 1. So it's 4 over 4 times the sine inverse whatever. Is that okay?
Yeah.
Cancel off. Then you're left with 1, 1. Can just ignore it. So what's your answer for A? What's your answer for A? Look at the question 15 part 2. You have the PDF open, right?
Yeah.
Cool. Question 15 part 2. What's A? What is A?
K over 4.
Exactly, K over 4. This guy, right? This guy. Can? Oh, by the way, if you are using Telegram on desktop, you can just press the search button there. Integration to JJC prelim revision pack question, ref pack question. Yeah, then you can find the worksheet if you cannot find it. Okay, Ken. So that is in for 0 less than K less than 2. That was given by the question. Okay, good. Why do they have to give this condition? Do you know why?
No.
What is the key rule you need to remember for square root? Square root x. If you don't want to deal with complex numbers, x must be
more than 0.
no, can be more than or
Equals
equals
to 0.
to 0. So it can also be equal. So yeah. So if you want x to be more than or equal to 0, notice there's a 4 minus k square here. Equivalently, square root of 4 minus k square must have 4 minus k square more than or equal to 0. This is a quadratic inequality. You know how to solve this since I don't know, since secondary school, A max, times -1 on both sides. Then you can factorize as k minus 2, k plus 2, more than less than or equal to 0. Then you just need to draw happy face, k axis. Then this will be -2 and +2, so more, less than or equal to 0, so -2 less than k less than 2. Here they restricted it to a stricter version, so it's even better. This is a subset of this, so we are safe, I guess. Oh, equal, sorry. Can?
Can.
Yeah, that's why they gave this condition. This is just extra knowledge. From functions, you need to remember this from functions. Okay, moving on. So that's part 2. Part 3 there. Part 3, hence sketch the curve and show by shading a region whose area is given by the integral in part 2. So I'll start a new page first. Yeah, so here the function we are dealing with is a 4y squared plus x squared equals to 4. This is really just what kind of shape? Same sign but different coefficient.
Ellipse.
Ellipse, very good. So how do we get an ellipse? Make sure your right hand side is equal to what?
1.
Equals to 1 divided by 4. So you get y squared plus 1/4 x squared. But I like to rewrite it as something square over something square plus something square over something square. So that I can straight away tell my center, which is
0, 0.
And how about my x radius? This guy, like you have a over. This is x radius.
2.
This is 2. Then how about y radius?
1.
1. Okay, then you can draw the sketch the curve already. So x is 2, right? That means it's a bit longer. So maybe -2 here and +2 here, and 1 there, -1 there for the y radius. So you can get your oval shape. Close enough, huh? Then what do they want? If you try to make y the subject here, what do you get? Maybe from here, what do you get? You get y squared equals to 1 minus x squared over 4. Then if you try to take the square root, what do you get? Plus minus square root 1 minus x squared over 4. If you try to combine 1 minus x squared over 4, what will you get? Maybe I'll do it at the side. It's 4 over 4 minus x squared over 4. So it's really just 4 minus x squared all divided by 4. So square root of 4 minus x squared all divided by 4. Yeah? Is that okay? Then now, when we are trying to, they ask you, sketch a region of this curve that is given by the integral in part 2. What is the integral given by part 2? Half integral 0 to k square root 4 minus x squared dx.
Yeah.
Where they say k is in between 0 to 2.
So I don't use the right hand side.
Yes, because wait, sorry, say again.
Oh wait, never mind.
Which region? Do you want to try shading?
Uh, Here.
Exactly, yes. But more specifically, it's actually from 0 to k. So you actually need to integrate in you need to indicate x equal to k, and then you shape this region here.
Oh,
0 less than k less than 2. Okay.
okay.
Also, but wait, this is square root 4 minus x squared. Here is 4 minus x squared with an extra 4. Not the same one. Actually, it is if you just try to separate it out. Square root 4 minus x squared over square root 4, which is just a 2. So in other words, plus minus half times square root 4 minus x squared. So if you try to find the area from 1 to k, 0 to k, area from x equal to 0 to x equals to k, we will be able to obtain integral of, do we want the positive half of the negative half? Here, since we are using positive square root, we should just take the positive square root, right? So positive square root of half square root 4 minus x squared from 0 to k. This will be our pink region, right?
Yeah.
But now we can factor out the half. And there we go. That's our region that was in part 2. Can understand?
Okay.
Okay, good. Yeah. So that is part 3. How about part 4? Hence, find the area of the region lying inside C, inside the ellipse, and between the lines x equals -1 and x equals to 1, giving your answer in exact form. So where's -1? It's actually over here. Where's +1? It's over maybe there. Okay, this x equal to k. Maybe if I just move it a bit more to the right, so I have more space. My x equal to 1 is somewhere over here. Can see?
Okay.
Then you want to find the region that is inside the ellipse that's bounded between line x equal -1 and +1. So what is the region they're looking for? It's actually this region here. Can you see?
Okay.
By symmetry, I hope you know that since this is -1 to +1, and it's the center is here, the area of these two is actually the same, right? Actually, the region of these 4 regions are actually the same. Do you agree?
So I can just times 4.
Yes, correct. You just need to find one of them. I prefer my quadrant 1 region. Then I times 4. Okay. So what does it mean? You just need to use the formula here. What if you want to find this region? Let's say I color this in purple. Oh, what is that line? Why is there an extra line? Okay, let me remove that. What I mean is, in order to, for part IV, part 4, you want to find the area of that region. It's really just 4 times of the purple region. Which means that it's really just 4 times of the integral from 0 to +1 of the function, which is positive half square root 4 minus x squared dx. Agree?
Yeah.
Yes? Can we make use of the formula from part 2 to help us?
Okay.
And do you see that it's the same? It's just half times 0 to 1 of square root 4 minus x squared dx. But you substitute the k with what? We have a formula here. Substitute the k with?
1.
So we just need to copy the formula from part 2, substitute in k with 1. That's all. Understand? So even if you cannot do your part 2 and part 3, please go and do part 4. Part 4 just needs you to use the answer from part 2. So 4 times, just use the formula. What did it give us? A times square root 4 minus k squared. A in this case is, we found out to be k over 4. So k over 4 times square root 4 minus k squared plus sine inverse k minus sine inverse k over 2. But wait, what's k?
1.
1. So you have to replace, contextualize. Don't just write down k, must replace with a 1. And did they ask for exact? They asked for exact. So you have to really go and manually integrate this one by one. Can I just leave that to you? This one requires integration by parts, sine inverse. Actually, does it? Oh no, it's just a constant. So never mind, we don't need. This one is already an exact answer. You can just simplify, no need to integrate anymore. Sorry, I was confused there for a moment. This is already the answer. I'll leave that to you, the rest. Okay, moving on, next one, question 16. Let's see. Never tried. 16, 17, all the way, haven't tried.
Yeah.
Oh no. Then you got try integration. Okay. How much time do I have? Do you have? Can I continue?
Can.
Okay, let's try and finish. I want to finish integration. I want to move on already. Okay, Ken. Since you haven't do, I'm not go through. I'll just look at the questions you've done already. We will. Okay, this will be the last lesson for integration. Is that okay?
Yeah, can.
And then we move on to other topic already because no time. Come back to it if we have time. So let me find the worksheet for EJC first. Yeah, where is it? Hold on a second. EJC. This is integration. Question 1. Question 1? Oh, supplementary. Okay. Is it not supplementary? Oh, no. This is integration application. Where is the worksheet? Sorry. Okay, Ken. This is from 2015 paper. Okay, question 1, part 1. Given that f is a continuous function, do you know what's continuous? Very simple. Continuous means you can draw it without lifting out your pencil. So you go all the way. You never lift out your pencil. So for examples of non-continuous functions would be something like just now the piecewise function. Remember this one?
Yeah.
You have to. There's a what we call a jump discontinuity. It's like imagine you are Mario. Then you have to jump down. Then after that, climb up, then jump down again to different platforms. Right? So that's what we call a jump discontinuity. You have to draw, lift up your pencil, and then you continue drawing. This is what we call discontinuous. Discontinuous, not continuous. To be honest, if you're not studying math or science, you don't need to know this ever. Yeah. So okay. Anyways, continuous graph is required as a condition for you to do any of the calculus stuff. I mean usually. Explain. So let's just read the question. Given that f is a continuous function, explain with the aid of a sketch why the value of this limit is the integral of 0 to 1 fx dx. So yeah, you just need to know it's base times height, right? So base here is all 1 over n multiplied by the height. So f of 1 over n. Let me see. So you decided to go with this left endpoint, right? So you start off with f of 1 over n. That's not super accurate. Because that means that this is not 1 over n. This is not f of 1 over n for this area. Do you see that? What's the height? I mean, where's the base? It's over here, right? Where's the height? It's over there, right?
Yeah.
So the height is actually what? The height is actually f, the y coordinate of this point. The y coordinate of this point. But what's the x here? It's actually 0 according to your diagram. So this will be f of 0 according to your diagram.
Yeah, I put f of 0 n.
Oh, 0 over n. Oh, no I see a 1 I see a 1 then I see a 2.
I don't know. I labeled on the.
Oh, you label on the diagram, but you never write down here. So that's why not so accurate. Actually, it would be smarter if you. Okay, here they just use f in general. It would have been smarter if you use a different curve, or rather, a different kind of rectangle where you use the right endpoint. What I mean is, if you want to use this kind of curve, a set face curve, this is what we call concave downwards, by the way. Do you know? Concave downwards. You're supposed to know this from differentiation.
Yeah.
This is concave upwards. d2y by dx squared. What's the sign for concave downwards? More than 0 or less than 0?
Less than 0.
Less than 0. Good. And upwards? Other way around, more than 0. Yeah. Okay, good. Can you know this? So for this guy, set phase, you actually maybe should draw a curve like this. Okay, I just draw 3. Can you see? Here will be 1 over n, 2 over n, 3 over n, so on. So this height, can you see that it is this guy over here, which is the y coordinate of this point here, which is 1 over n comma f of 1 over n. Then you can find the area of this rectangle, and the area of this rectangle, and the area of this rectangle. Okay? Base times height, base times height, base times height. So your diagram, okay, but anyways, you can disregard the diagram because they never ask you to draw. This will not be, okay, this one, maybe they will mark it, but I don't think it's that important, even if you use the wrong endpoint. As long as you follow the question for what they requested for 1 over n, then you can just, I think you should get the marks, okay? So 1 over n times f of 1 over n, then 1 over n times f of 2 over n, so on and so forth, until you eventually get to f of, oh, you should plus dot, 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 dot. Make sure you got a plus dot, dot, dot. I think it wasn't scanned in or something. Make sure you have that.
Yeah.
And then finally 1 over n times f of n over n is okay. So now, what happened? No. You see there's a common factor of 1 over n. You need to factor out the 1 over n. So where's my 1 over n? Never write down. Very bad. You have to leave it there first. Then after that, you get this. Okay? Can okay, so sum of the area will just be equal to this guy. But then, what do you say? As n tends to infinity, estimation of the area under the curve gets more accurate as the graph flattens and becomes less steep. Actually, this part, no, don't need. Flattens and become less steep. That's not the point. The point is that as you let n tend to infinity, the error gets smaller. Remember the experiment I did with you? I can bring it up again now. Over here. Okay. You see? I need to change the presentation mode. Hold on a second. I need to show single page. Okay, before, after. This one, 2 rectangles. The error is like this. 2 huge white areas. Very, very inaccurate. Very, very inaccurate. Let me shrink down the diagram so it's a little bit easier. This two region, very inaccurate, very large error. But as you increase the number of rectangles, it's not that it flattens. You see my graph, this one not flattening. It's going all the way up. The graph is not flattening. That's not the main reason. It's that the sum of these 2 white color areas is getting smaller. This white area is called the error of the estimation. The error, right? The exact area versus the estimation. If you take the difference, you subtract big minus small, you're left with the white color region. It's getting smaller. Let me show you a third diagram. If you have 3 rectangles, this guy, this guy, this guy, even though you have an increasing number of white, but each, okay, as you increase the number of white, but each area is actually decreasing. There's a decrease in the area, net area. You take the sum of these 3 white regions, it's getting smaller. Then if I now increase to 8 regions, even though you have 8 of these triangle shapes or white color region, it's not really a triangle because it's curvy. The sum of all these white areas is getting smaller. Can you see that?
Yeah.
So that's the main reason. The estimation is getting more accurate. The error is dropping. That's the proper reason. This reason is the more accurate is the correct statement. As this one not so accurate. You should say as the error gets smaller.
Oh.
That's all. Sorry, I'm saying too much. Okay, so when gets more accurate. So the exact area, then you can say the exact gets more accurate as the error gets smaller. Gets more accurate. Actually, maybe gets more accurate. I will add on an extra line and say and tends towards, means approaches. You can also say approaches. Tends toward or approaches the exact area. Then the reason is because the error gets smaller. Just now I explained already. The tiny squares tiny triangles. The sum of those white color areas getting smaller. This is the reason. Then you have to link it to the integral of 0 to 1 of f of x. The exact area is given by, don't be so fancy. The exact area is the integral from x equals 0 to 1, i.e. integral 0 to 1 fx dx. Correct or not? Finding area under a curve, just integrate. Oh, just tell them that. Just write down something along these lines, then you can get the mark.
Okay.
To be more accurate, should be above the x-axis, bounded between integral from x equal to 0 to x equal to 1, and bounded between fx and x-axis. That's why we have a dx here. If it's dy, then it's with respect to the y-axis. How? Can
Okay.
Yeah. Okay, get next part 2. Let me change the quality of this screen. Hold on a second. Good. That is question 1, part 1. Then hence evaluate the limit. Okay, so this guy, what you need to understand is that it's really just the integral. It's really just an integral. You must convert it into an integral. Here the function is actually cube root of x. Can you see?
Yeah.
Cube root of x, how does it look? I think it looks something like this. But we focus on the right half. And then you have a cube root. Okay, here is here is a limit as n goes towards infinity of 1 over n. That's your base. So it means you got a rectangle here of base 1 over n. Then how about the height? The height will be f of 1 over n. But here they gave us, instead of f of 1 over n, you have cube root of 1 plus cube root of 2 plus cube root all the way, all divided by cube root of n. So we can simplify down as like this. Right? You can split it up into a bunch of fractions like this. Is this clear to you? Plus dot 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 plus until you reach the last one, cube root of n divided by cube root of n.
Yeah.
So simplifying everything down, you actually get the limit as n tends to infinity of 1 over n multiplied by huge cube root divided by 1 over n. Huge cube root 2 over n. Plus all the way to huge cube root n over n. So can you tell me what is the function now? It must always be f of something, f of something, f of something. So from here, you can deduce that it must be cube root of n. Sorry, x. Does it make sense?
Then x is 1 over n.
The x is replaced with 1 over n, 2 over n, 3 over n. Right, let me show you back the example. Like in this case, if we had y equal fx equal x squared plus 1, we sub in with 1 over n, 1 over n, 1 over n. 7.5 is 1 over n. The other 7.5, okay, sorry. I mean over here, 7.5, 7.5 times 2, 7.5 times 3, 7.5 times 4. The 7.5 is the 1 over n. So this is 1 over n, this is 2 over n, 3 over n, 4 over n, 5 over n. And then you get f of 7.5, f of 7.5 times 2, f of 7.5 times 3. In other words, it's, wow, why did I pick such a huge number? It's 7.5 squared plus 1. That's your y coordinate there. This one is 7.5 times 2 square plus 1. And the other guy is 7.5 times 2 times 3, sorry, bracket square plus 1, so on and so forth. Does that make sense?
Yeah.
So you just need to see the pattern where there is the repeated cube roots. Cube root of the 1 over n, 2 over n, 3 over n, n over n, which is similar to my 7.5, 2 times 7.5, 3 times 7.5. This is like a 1 times 7.5. This is like a 2 times 7.5. That's your n times 7.5, where the 7.5 in this case is a 1 over n in general. So the function that's surrounding it is cube root. So that's why it should be the cube root. But you want the exact area, right? Limit as n goes to infinity of the base 1 over n of all the heights will give you the total area, which is really just the integral from where to where. What do you think? They already gave you a hint, right? From the part 1. If you have f of 1 over n plus f of 2 over n plus dot 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 until plus f of n over n, it is the integral from what to what? What's the limit?
0 to 1.
Exactly, 0 to 1. There you go, that's it. So this is the exact area. You just need to calculate. I mean, did they ask for exact value? Yeah, just give them, it's quite easy. Power 1/3. So you add 1 to get the 4/3, then divide by 4/3, sub in 1 0. So you get 3/4. Right, okay, maybe I do it step by step. 1 power anything is just 1, divide by 4/3, minus away 0 power anything is 0, divide by 4/3, which is 3/4 minus 0. Can?
Yeah.
So this is really conceptual, huh? There's not much working. But you must understand cube root something, cube root something, cube root something means it's cube root of x. Then from 0 to 1 because of the part 1. Can? Can, huh? Okay, good. Actually, my graph also not so accurate. I should continue all the way until I reach maybe dot dot dot, and then finally we reach one more rectangle like this. Ayo, very not nice. Let me try again. Something like that. And this here will be n over n, which is 1. Also, we can find the total area by estimated by this region from 0 all the way to n over n, which is 1. That's why we have integral from 0 to 1. 0 here, 1 here. Total area. Maybe I'll add in another gray color box. All right. And moving on. That is question 1. Let's move on to question 2. The graph of y equal to 2 power x for 0 less than equal x less than equal to 1 is shown in the diagram below. Rectangles, each of width 1 over n, where n is an integer, are drawn under the curve. Show that the total area of all the n rectangles is 1 over n multiplied by 2 power 1 over n minus 1. Okay, so let me see your integral first. You try to integrate 2 over 2 power x dx. Wait, no, sorry. Oh, 2 power 1. Right. 1 over n is the width, the base, multiplied by the height, 2 power 1 over n. Correct. Then you just repeat for 2 over n, 3 over n, n minus 1 over n until 1. Very good. Well done. Yes. Then that means that you can get the total area by factoring out the 1 over n, 2 power 1 over n, plus 2 power 2 over n, plus dot dot dot, plus 2 power n minus 1 over n. One step before the last one. Then finally 2 power n over n, which is just a 1. So you don't need to write it. Okay, good. Then you need to show that it factorizes into that. You cannot just stop there. Even if you don't know how to do it, just pretend. Just write down the conclusion, okay?
Oh, okay.
Pretend that you know how to factorize. It's actually geometric series. Can you see or not? I haven't go through sequence and series.
Yeah.
Remember the formula? Sn for geometric series, GS geometric series is first term multiplied by 1 minus the common ratio raised to the power of number of terms, close bracket, or divide by 1 minus common ratio.
Yeah.
Remember or not? Must know. So what's the first term here? A. Look at our series. First term.
The 2 1 over n.
Power 1 over n. 2 to the power of 1 over n. Bracket 1 minus r to the power of number of terms. Then close bracket. Can you tell me what's the number of terms here? 1 over n, 2 over n, 3 over n, n over n.
1.
How many? There's only one term. How many of these guys are there? How can it be 1? 1, 2, 3, 4, 5, infinity.
But
how many?
How do I know?
Okay, I give you a simpler pattern. Let's say you have 2 power 1 over 4 plus 2 power 2 over 4 plus 2 power 3 over 4 plus 2 power 4 over 4. How many terms do you see? 1, 2,
4.
3, 4. How do you get 4? That guy over there.
Oh,
1,
so
2,
there's
3.
n.
Yes, correct. Yes, so the power here is n. Take note, it is not always n. Here I'm saying number of terms, it is not always n. Sometimes can be n plus 1. Sometimes can be n minus 1. You have to be careful. Not always n. Please remember that. In this case, yes, it's just n. Then how about the base, the r, the common ratio? How do you go from this term to the next term? Multiply by what?
1 over n.
No. Multiply by, no. You want to add 1 over n to the power. So what do you need to do? It's like your VIP pass, your invitation card. You want to go from 1 over n to 1 over 2 over n. Can you just multiply by 1 over n? Cannot. You must have the same level of, I don't know, social status or something, then you can match up. So you need a base 2 first to the power of 1 over n. Does that make sense?
Oh.
Let's say it's 2 power, I use whole numbers, 3, jump to 2 power 4. What do? Do you just times 1? Because 3 plus 1 is 4?
No.
Cannot be, right? Should be 2 to the power of 1. Must have the same base so that you can do same base, different power, multiply, add the power. 3 plus 1 gives you 4. Okay, must have the same base. Let me show you another example. Let's say you have x plus 1 to the power of half. You want to turn into x plus 1 to the power of 5 halves. What do you need to multiply by? X plus 1 to the power of 5 half minus half, which is 4 halves, right?
Yeah.
1, 4 gives you 5. Right? But you need the x plus 1 base. Is that clear?
Yeah.
Okay, good. So now it's just 2 power 1 over n. You can verify for the other guys. 2 to the power of 2 over n, jump into 2 power 3 over n. 2 to the power of 3 over n. You still need to multiply by this 2 power 1 over n. All right, 2 power 1 over n can? Then that's your common ratio. The blue color 2 power 1 over n. So that means you fill in the blank over here, 2 power 1 over n. Coincidentally, n times 1 over n, what happens?
Becomes 1.
Yes, it becomes a 1. So we can simplify that later. We'll just keep that in mind, simplify into 1. Then all divided by 1 minus r again. What's r? Common ratio. What's the common ratio?
2 to the power of 1 over n.
Okay, good. Then you can simplify now. So this is equal to 2 power 1 over n multiplied by 1 minus 2 power 1, all divided by 1 minus 2 power 1 over n. Is this clear?
Yes.
Not enough, because did I do something wrongly? Let me see. Yeah, need to simplify a bit more. No, I wasn't wrong. 1 minus 2 is what?
-1.
Good. So -1 on top, 2 power 1 over n, all divided by 1 minus 2 power 1 over n. I'm running out of space. Let me add a page. Okay, add a page. Okay. Then I will copy and paste this to the bottom because I need more space. Cut. Go down, paste. Let me make it a little bit neater. Then how do you simplify this? Look at the numerator of the desired answer. They want us to show that the numerator is all. Read the question. 2 part 1. Show that. Open the EJC tutorial. Area and volume. I just sent you on Telegram the shortcut.
Oh, okay. I think I opened the wrong one.
Yeah, area and total volume. Sorry, I didn't name it nicely. I should rename. Okay. Wow, my file naming is very bad. Sorry, not consistent. You have that. Have you opened it?
I'm trying to open.
Okay. No worries.
No, I cannot open. Oh, never mind. I go and find.
Yeah. Oh, did I send the solution already? Okay. I think it's getting quite messy. I should send you a compilation. Cannot open?
Oh, this is downloading. I don't know what's so wrong.
Or maybe you stop the download and then download again. Sometimes
Oh,
it will like that. You cancel and then download again.
okay.
Okay, let's go. So now in this case, what you need to know is the numerator should be what? Scroll down to supplementary section 2. Oh, and then supplementary section 2, question 2. Oh, what do you want to show? 2 part 1.
Question
Show that the
2?
section 2 part 1 of the EJC application question. Section 2, sorry. No. Section 1. Oh my goodness, I got confused.
Okay. Is n times
No.
2
No, numerator should be
1.
1. We look at the simpler number first. Don't look at the complicated one. So compare and contrast. Previously, you got complicated minus 2 power 1 over n. Wow, so many things. But now we want the 1. How do we go from complicated into 1? Let's say 2 over 3, I want 1 over something. Isn't it just 1 over 3 over 2? Reciprocal, right?
Yeah, so I bring down the.
But you also need to flip it around. Bring down the 2 over 3, but then you need to flip it around, become 3 over 2. So here, you can rewrite it as, think of it like a fraction like this. Then you just bring down. So you get 1 over the negative 2 power 1 over n. Can you see that?
Can.
This is the entire expression, but multiplied by 1 minus 2 power 1 over n. Is that okay? Can you understand? Okay, I can explain another way later. Then this one will simplify down to 1 over, here you got 1 over negative. Let's just bring the negative in first. So we end up with 1 over 2 power 1 over n. Negative bring in 2 power 1 over n minus 1. Clear?
Yeah.
But now you have this guy, you can bring it up to the top. So that means we have exact same thing, but you just multiply by 1. So it goes to the numerator here. Maybe more like this. And something like this. Can see? Can, good. So now you got a fraction like this. Something minus something over something. How do you simplify this?
Can split up.
Split up. 1 over, what happens when they are the same thing?
Becomes 1.
Comes a 1. Minus away. What happens when you have a 1 over 2 power 1 over n? Bring on top. You get 2 power.
Negative.
Oh, that's not correct. Something is wrong. Did I do something wrongly? Let me see. Let me see again. Sorry. First term. Oh, right. I forgot the 1 over n. Sorry, my bad. Here I was focusing too much on the geometric series, but I forgot that there's actually a 1 over n. Notice that there's a 1 over n here. We will go back to the original working out. It's over here. There's a 1 over n multiplied by our geometric series.
Yeah.
So we should actually take 1 over n multiplied by that geometric series we found. So I forgot the 1 over n. So the dot is actually 1 over n multiplied by Sn, which is 1 over n multiplied by what we found just now, which is currently this guy, 1 over 1 minus 2 power negative 1 over n. Then how do you simplify this down? Something is wrong. I shouldn't have a negative power. Let me double check. Did I do anything wrongly? Two power negative 1 over n. Oh no, that's not good. That's not good. Right. Sorry, if you look at the diagram, I cannot I cannot mark this as correct. This is wrong. Sorry, this is wrong. There's a mistake over here. Let's look at the diagram. So what they had is this diagram. It starts with this rectangle, then this rectangle, then this rectangle, so on and so forth, until it reaches the last tree. It becomes something like this rectangle, and then this rectangle. Now, what are the coordinates of these points? One here, one here, one here, and a last one here. It's n minus 3 over n. Okay, I use a different color. Wait. This guy is n minus 3 over n. This guy is n minus 2 over n. This guy is n minus 1 over n. This guy is n. Now, the area of this last rectangle, can you tell me what is the height here? F of what? Where f is 2 power x. F of what? What's the input?
N.
No. What is the height here? It's actually the y coordinate of a certain point. Can you tell me, is it the top left point or the right?
The left.
It's the coordinate of the y. The left has to be the one that intersects with the intercept here. So can you tell me again what's the y coordinate here? X and y. What's the coordinates of this point? Right?
Minus 1 over n.
N minus 1 over n. Very good. So then after that, it will become f of n minus 1 over n. Yeah? Which means that you should actually stop at n minus 1 over n. You shouldn't include the 2. Sorry, I didn't see that. I wasn't looking at the diagram. I trusted you're working. No, cannot. This last term is wrong. Please get rid of it. This is wrong. You need to get rid of that 2. So let me just redo the entire question. Yeah, this geometric series is wrong because we started off with the wrong expression. So the area there, this is question 2 part 1. We should actually just ignore the 2. It's just the 1 over n. You multiply by the sum f of 1 over n plus f of 2 over n plus dot 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 until plus f of, in this case, it's n minus 1 over n. But wait, you have to take the limit as n goes to infinity. Oh wait, sorry, no, sorry. That's if we are finding exact area. Now we are finding just the area of rectangle, so don't need to find the limit. Don't put the limit there. It's wrong to put the limit there. But f is what? Is 2. So 2 power 1 over n plus 2 power 2 over n plus dot 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 plus 2 power, last one is n minus 1 over n. Then now we know that this is a geometric series. So a equals to 2 power 1 over n. Common ratio is 2 power 1 over n. Then how many terms are there?
N minus 1 over n.
Wrong. No. If let's say it's 2 power 1 over 5 plus 2 over 2 over 5 plus 2 power 3 over 5 plus 2 power 4 over 5, then we stop there, right? Because it's n minus 1 over n. The n in this case being 5. So how many terms are there?
So there's n terms. Huh?
No. If n in this case, sorry, my handwriting, my 5 looks like a 6. If the n in this case is 5, how many terms are there? 1, 2, 3, 4 terms instead of 5. How do you get from 5 to 4? Minus 1. So it's n minus 1. Understand?
Yeah.
5 minus 1. You can try with other numbers. If it's 6, there will be 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, and you stop there because it stopped at n minus 1. You focus on the numerator. 1, 2, 3, 4, 5 until n minus 1. So there are n minus 1 terms. By the way, to count the number of terms, it should always be big minus small plus 1. Big minus small plus 1. So in this case, big is what? N minus 1. Small is what? 1. Focus on numerator only. When you're counting, like for example, you have a bunch of apples. Here's an apple. Here's another apple. Then index 1, index 2, index 3, all the way until index n minus 2, index n minus 1. I think it's quite obvious. It's big minus small. Then you plus 1, which will give you n minus 1. So let's give another example. This is a very important concept. Big minus small plus 1. Number of terms in a series. Let's say that you have index 3, 4, and 5. How many terms are there? Okay, wait, sorry. I add on one more. 6. How many apples are there? Index
Uh,
3, 4, 5, 6.
4.
How do you get 4? You count it manually, 1 plus 1 plus 1. Primary school kid also know. JC kid must be different. You have to learn another way to count it. Big minus small plus 1. That's the formula. Biggest limit, smallest limit, plus 1.
So it's always like that.
Yes. However, that is only when the common difference here is plus 1. What if it's plus 2? Let's say I give you another apple question. Counting apples. I hope it's not confusing. I'm just counting apples. Let's say that now we have another diagram with apples, but I changed the index number. Okay, 4 apples, But now let's say I start with 4, I plus 3, plus 3, plus 3. Then how many apples? 4. How do you get 4? What's the common difference? Plus 3. Pattern here. Big minus small. That's the total number, total distance. Then the in-between distance is 3, 3, 3. So if we divide by 3, what do we get? Calculate this. What is it? 13 minus 4 is 9. 9 divided by 3 is 3. Is that our number of apples? No. So you must always plus 1. You get 4. Big minus small divided by the common difference, plus 1. Just now I told you big minus small plus 1. Technically, it should be big minus small divided by 1, then plus 1. But nobody will say divide by 1, right? If the common difference is 1. But the difference here is 3, then you must divide by 3. Do you want another example? Okay, I'll test you now. I have to test you. Let's say I have now 5 apples, but then I change the index number. I don't know, let's say it goes from 5, then 7, then 9, then 11, then 13. 5 apples. How do you get 5? What's the formula? You got 13, you got 5.
13 minus 5 over 2 plus 1.
Yeah, exactly. Okay, you got it. Good. Yes. Can I always big minus small over the difference plus 1? Can? Okay,
Yeah.
good. So now we move on. So now we count how many terms are there. 1 over n, 2 over n, until n minus 1 over n. Focus on the numerator. It will help you to tell you the number of apples. So big minus small, the difference is plus 1, right? So we can take n minus 1 big minus away the small 1, divide by the difference 1 plus 1. Of course, that's just n minus 1. Okay, Ken, so now we can use the generic formula for Sn, which we know is a times 1 minus r power n, or divided by 1 minus r. So let's just use that formula. It's equal to 1 over n multiplied by, use the formula. A is 2 power 1 over n, multiplied by 1 minus r, in this case is 2 power 1 over n, raised to the power of n, close the bracket, all divided by 1 minus the common ratio, 2 power 1 over n. Is that okay?
Yeah.
Just use formula, boring, nothing special. Now is the tricky part. We want to deal with the expression there. I realized something. Look at the fraction we want at the end of the day. It's 1 over n times 2 power 1 over n minus 1. Notice that they look very similar. Yes? No?
Yeah.
Why are they off? Why is it off? Here
Negative.
is minus 1. Very off by a negative. Good. So that means that 1 over n times, you can actually, how about if we times -1 top and bottom? Does that change the value? Of course not. -1 over -1 is just times 1. But now we can times -1 inside the bracket, which means we will swap them around. It becomes 2 power 1 over n minus 1 over 2 power 1 over n minus 1. So in general, the general formula can also be rewritten like this. A times r power n minus 1 over r minus 1. They are equivalent. Is that clear? It's like 2 minus 3 over 5 minus 7 is the same as 3 minus 2 over 7 minus 5.
Yeah.
So, top and bottom, left and right. Yeah, so anyways, now that we have the denominator which we want, I notice, actually denominator, I still need a what? I still need a what? Extra n here, right? So how about if I just times n at the top and bottom? Instead of bringing things down to make it a 1, I just make sure my denominator is the n has the n first. So what do we get? Oh, actually, sorry, don't need. Sorry. Undo. Actually, don't need. You know why?
No.
We already have an n at the left side. Can you see? Remember the base times the sum of all the height? The base is 1 over n already. If we take fraction times fraction, we just have to multiply numerator, denominator with denominator. Primary school fraction. But secondary school, because there's algebra. So n multiplied by 2 power 1 over n minus 1, right? Which now we can be simplified as n multiplied by 2 power 1 over n minus 1, which is very close to what we want already. Can you see? Yes, no?
Yes.
Yes, okay. And I realized I made another mistake. Oh my goodness. I am so sorry that it's taking so long.
Where's the mistake?
I should have started the question from the beginning. Okay, here is the mistake. Because let's take a look at the diagram. What did they have? The diagram starts with this rectangle, then this rectangle, then this rectangle. So we need to figure out the first rectangle, the base here, 1 over n, and the height here. Can you tell me what's the height? Do we focus on the left endpoint or on the right endpoint? Focusing on this rectangle. Do we focus on the one that cuts the curve or the one that doesn't cut the curve? Left or right? To find the height.
Left.
Left endpoint here. Can you tell me what's the coordinates of this left endpoint?
Y, 1.
Something common, something, what is it?
It's 0, then 2 to the power of 0.
Which is actually 0, 1. So that means that the height here, the first height is actually 1, no? Right?
Yeah.
So the first term is actually 1. It is not 2 power 1 over n. It should actually be f of 0, which is 1 or 2 power 0. Okay? Can or not? Can. Sorry, I didn't realize that. Another mistake. So the first term I made a mistake. Last term I also make a mistake. Sorry, I didn't check carefully. So I have to be careful. First term is 1, last term is 2 power n minus 1 over n. So the first term is not 2 power 1 over n, it's actually a 1. Right? So that means we have to change accordingly everything. Change to a 1. Is that clear so far? Mic test, can you hear me? Uh-oh. I cannot hear you. Mic test, can you hear me?
Can.
Can.
Yeah, can.
First term should be 1. So I change accordingly. Is it clear so far?
Yeah.
Anything? Can. Okay, good. Then yeah, so I have to redo. But the number of terms now, since I added on one more extra term, how many terms should there be now?
It's n.
Correct. It's actually n. Sorry. Let me add on another 2 power 0 here. So this one should be n equal to 6. Yeah, so n equal to 5, sorry. So n equals to how many? I cannot count. 5. Yeah, so n. There's basically n many of these. So let me modify this part here. It should also be a 1 over here. And then we can proceed. I think this is getting closer to what we want. But here, let me just check first. Let me just check first in case I get anything wrong again.
Okay.
Yeah, and it made another mistake. I did too fast. Over here, I'm going to do it step by step first. So this one, 1 over n times n is what? 1 over n times n is?
1.
1. Okay, so we just do that. Don't do anything extra. Just do it step by step. Make sure we get an accurate answer. That's more important than anything else. Don't times -1, just do it later. So that's a 1. So we just simplify it as 1. Okay, good. Then we don't need the bracket anymore. So it's just 1 minus 2. What's 1 minus 2? What's 1 minus 2?
Oh, -1.
What's 1 minus 2 is -1. Yes, so equals to 1 over n times. So we simplify that. This one becomes -1. 1 times -1, just a -1. Divide by 1 minus 2 power 1 over n. Then you look back at the goal. What do we want? Oh, we actually want 2 power 1 over n minus 1. So what should we do? There's a negative here. Bring it down. So what will we get?
Huh? Can bring down the negative only?
-1 over 5 minus 2 is the same as 1 over -5 minus 2. Agree?
Yeah.
Can bring down.
Oh, okay.
So we bring down. But I think we can go a little bit faster here. -1 times in. What will we get?
2 to the power of 1 over n minus 1.
Very good. Yes. So 2 power 1 over n minus 1. Okay, good. Then in this case, we are done already. Finally, n multiplied by 2 power 1 over n minus 1. Shown. Okay? Okay, great. That is 2 part 1 done. Okay, let's move on to 2 part 2. So now, what did you do? Let's see. Let me read the question. By considering the area of the region bounded by the curve y equals 2 power x equal to 1, and the x's, briefly explain why ln 2 is less than that fellow. Okay, this is correct. You should probably find out the exact area. Okay, let me read your answer first. The estimation of the area is inaccurate as there is a gap between the curve and the rectangles. No lah, that's not what they're asking for. That's a bit too general. That's a bit too obvious. It will be less than because it's an inaccurate. No. There's a more precise way to explain this. Okay.
Oh.
Yeah, okay. Let's try part 2. So what we should realize is that we have found the area of n rectangles to be equal to 1 over n times 2 power 1 over n minus 1. Now, what do we want to do now? We want to show that what do we want to show? We want to show that ln 2 is less than n multiplied by 2 power 1 over n minus 1. Now, we are given this guy. To eventually reach here. Here is 1. Here's n minus 1 over n. They told us that you already okay. They gave us n rectangles that's underneath the area of this curve. Underneath the curve, which is an area and under approximation of the exact area. What would this exact area be? It's the integral of the function, right?
Yeah.
But it's not just a normal integral, it's a definite integral. What are the limits?
0 to 1.
Very good, 0 to 1. So your answer, you got what is that? 2 power x divided by ln 2, right? Is it? Over here is fine, but you need the definite integral instead. Divide by ln 2 plus c, don't need the plus c anymore. 1, 0. So you get 2 power 1 over ln 2, minus away 2 power 0 is 1 over ln 2. Actually, hold on. Let me think a bit. Are you supposed to divide by ln 2 or times ln 2? Differentiate 1 over y times dy by dx. Differentiate ln 2. dy by dx ln 2 times y. So it's ln 2 times 2 power x dy by dx. So it's the derivative of 2 power x. So if you want to integrate this on both sides, you end up back with 2 power x, integral of ln 2 times 2 power x dx. Ah, correct. You're supposed to divide. Okay. Let's see. Okay, it's correct. So that case, you get this expression. That is correct. Okay, this one not important. I forgot the rule. All right, you have to divide. Then in this case, this is the exact area. So you know that the exact area in this case, because there are gaps, right? Who is bigger? Is it the exact area or the area approximated by these rectangles here?
The exact area.
So that means you can form an inequality now. It's bigger than the area that we found from part 1. So even if you don't know how to do your how to derive from part 1, you can still do the following. Form this inequality. That's what they are looking for. The area of the rectangle, sum of all the n rectangles, is less than the area of the, what do you call this? The exact area. It's less than the exact area because of this particular diagram. Sometimes it's an over approximation, so it will be more than. It depends on the diagram, okay?
Okay.
You can understand from this diagram why it's smaller, right? Because it's
Okay.
underneath it. Okay, good. So now we also know that this is 2 over ln 2 minus 1 over ln 2. So that means actually we can factor out a 1 over ln 2. Then we will get, what is it? 2 minus 1, which is just 2 minus 1 is 1. 1 times 1 over ln 2 is 1 over ln 2. Less than 1 over n times 2 power 1 over n minus 1. Is it clear so far?
Yeah.
Okay, then now you can cross multiply. Ln 2 is positive. So if I multiply over, I will get ln 2 here. Do I need to flip the direction of the inequality? Positive. No. Ln 2 is more than 0. How do I know that? Because I know the standard graph. Here is 1, 0. Now ln 2, I can type in a calculator. Actually, let me double check. Oh, sorry. I am wrong. No. Ln 2 is not more than 0. Ln 2. Let me think a little bit. Sorry, I'm getting confused. Ln 2 is more than 0, yes, because here, if this is y equal to ln x, 2 will be somewhere to the right side, then this will be ln 2, which is positive. Yeah, so don't need to flip the symbol. Flip the direction of the inequality. All right, then here, n is positive. 2 power 1 over n minus 1. Do you think it's positive or negative?
Positive.
Should be positive. Actually, let me think a little bit. How do I know for sure that it's positive? I don't actually, but it has to be positive, yes, because it has to be the area of our n rectangles, right? This expression over here originally was the area of n rectangles, and the area must be positive. So that's why, and n here we know is positive, right? And you're being multiplied to something. 1 here we also know is positive. So if you know the total area of all rectangles, which should be positive, that means this guy must also be positive. Cannot be negative, cannot be 0. If it's 0, you'll end up dividing by 0, which doesn't make sense. If it's negative, you'll end up with a fraction being negative, which contradicts the left-hand side. Total area of all rectangles must be positive. So yes, positive. So you agree, do you agree that n times, do you agree that n is positive and 2 power 1 over n minus 1 is also positive?
Yes.
Good. Then that means that we can multiply both sides by that denominator. Do we need to flip the symbol? The direction of the inequality?
No.
We multiply by a positive. Don't need. Keep it. Okay, you must go through this kind of logic. Don't just anyhow copy and paste the inequality. You need to think, are you multiplying or dividing? Are you multiplying by or dividing by a positive or negative value? Negative need to flip. Positive don't need to flip. Okay, continue. So now, there you go. That's your answer. Explain. Don't need to write the 1 times. 1 times is extra. Okay, that's all. Good. Ken, moving on. So now continue. I will go through everything. I don't care.
Must finish by today. Oh no, 12:47. Okay, let's go. So find the area of the region R. Let's see. No, straight line and a curve like this. Okay, so what do you have? At the point of intersections, what do we have? Some value here and here. According to, you can just solve it simultaneously, or you can just use the GC and you can get the value. You got a 0.90098, 11.099 and 11.09902, 0.90098. Let me check with the solution. Is it the same? Okay, it is. Yes, it is fine. Okay. That means that you can just integrate from 0.90098 to 11.09902. And you take the top minus bottom. Okay, top minus bottom is correct. By making y the subject, you get 10 over x. Okay, then you get 36.1. Correct. Good. They didn't ask for the exact area, so it's fine. How about part B? Part B is, very good. You identified the sharp turning point, then you split up into two halves. So you get y equal 1 over x squared and y equal to x. So if you make x a subject, you get square root 1 over y. Why did you take the positive? Why you never take the negative?
Because it's area.
No, wrong. It's because x here, look at the graph. Look at this part of the curve. Look at all of its x comma y. Look at, and then you focus on all of its x coordinates. It's to the right of the y-axis, right? So it's all positive. Agree?
Yeah.
It's more than 0. So that's why you take the positive root. It's because of the graph. If the curve gave you this, you should be using -1 over negative square root. Maybe. But then by symmetry, you should use the positive one, so it's easier to integrate. And you get positive area. Yeah. Okay, so let's see your working first. This is correct. Okay, if you use the correct answer, then nobody will fault you. But you must know the reason. So from 1 to 4. Okay, Ken. This is a 1. X-axis. Make sure you draw x-axis. Very confusing. This one is y equals 4. So you integrate from 1 to 4 of this 1 over square root y. Can. Then plus half times 1 times 1 because it's a triangle. Okay, can. Actually, what's the coordinates of this point? Is it 1 also? Yeah, it is. So half times 1 times 1. Okay, working is perfect. Good. 2.5. Okay, good.
So if it's negative x, then do I take modulus?
I guess so. If let's say the graph gave you, if the question was like this, if they gave you this guy, y equals 1 over x squared, and they give you the right side, and then they have the other guy, let's say this is y equal -x, and then they want you to find this area instead. How would you do it? That's the y-axis, that's the x-axis, this is the origin. You still need to make x a subject, but x will now be plus minus square root 1 over y. Which one do you pick?
The negative one.
The negative one, because it's now on the left half. So negative square root 1 over y. Then that's this curve, but you integrate from where to where? From here to here. By symmetry, it's actually, this point is -1, 1. This point here is, this is 1, this is 4. So actually let's call this r. R is actually equals to integral from 1 to 4 of the negative square root 1 over y dy. But then, yeah, you have to take modulus. I think this will give you a negative answer. So end up, you still take a positive. Maybe we just take modulus outside. Then after that, you just add on the triangle over here. Half times 1 times 1. Okay, maybe your reasoning is also accurate. We should just take the positive because at the end of the day, area must be positive. Okay, Ken, you don't have to take the negative because you need to find area. Modulus will still make it positive.
Okay.
Ken, moving on. So 4A, this I hope is a little bit easier. Find the volume generated when region R is rotated completely about the x-axis. So let's see your setup. So what you have, you equate to 0 so that you solve the roots, x equal to 2 only. No. Whenever you got this guy, something multiplied by something equal to 0, you should split it up separately. So x equal to 0 or x minus 2 equal to 0. Then x equals to 2 or x equal to 0. Two answers, which is the reason why they have two roots here, 0 and 2. Okay, good. Then continuing, you integrate from 0 to 2, then you take the square of this dx. Okay, your setup is perfect. Yeah, you get 3.35. Okay, can. Good. Next one, part B. You have y equals 1 over x, y equals to x. You have a region R from 0 to 2. So you notice that there's a sharp point here, so you need to split it up. Let's see what you did. You integrate pi from 0 to 1 of x squared. Okay, and then 1 to 2 of 1 over x bracket square. Here, because you're trying to find volume of revolution, that's why you have a square. Okay, good, correct. And then you get 2.62. Okay, correct setup. Well done. Next, this is question 5. Find the volume generated when region R is rotated completely about the y-axis. So this one is the one that you are a little bit confused by, but I hope you got it right. Let's see. Y equals to 1 over x squared. Y, so you can make x squared a subject. X squared will be equals to 1 over y. Then you got x squared already. Don't need to make x a subject. Just use x squared. Then you have the coordinates 0.5, 4, and 1, 4. Is that correct? Let me see. 1 over x squared equals to 4. So 4x squared equals to 1. So x squared equals 1/4. Did I do something wrongly? Let me see first. That is the intersection with 4. So this implies x equals to positive half because we are looking at the positive half. So 0.5, 4 is fine. Then the other guy is oh sorry, is this 4,4?
Yes.
Yes, okay, good. Can correct. Okay, good. Then you have a 1, 1 as well. Okay, can. Yeah, because you're just equating, or you can just use GC. You just use GC, you can solve. Okay. What else are you doing? Okay, yeah, you also solved it manually. That's also okay. Then you want to find the volume generated by rotating about y-axis. So you must read from bottom to the top. Here, what did you do? You take dx. Wrong already. Oh no. Read the question. Question 5 requested for about y-axis.
Oh, okay.
Can you try again? What would it be? Try again. Tell me. Do together. V equals to pi times.
Where's the y-axis? I think I never draw. Oh.
Yeah, you can look at the question diagram as well. Question 5 now.
Integrate 0 to
0. The region R here is way above 0. Remember parachute idea? Parachute idea, remember? Wait, let me try and draw my parachute. So yeah. Okay, how do I get this guy? Okay.
is 1 to 4.
Yeah, exactly. So in this case, it is just, maybe if I just draw an arrow, does it help? Yeah, like this. So it goes from here to here, right? So your y coordinate should be your focus. Then it should be 1 here to 4 here.
Yeah.
Then it should be 1 to 4. Okay, good. Then in this case, what should be the integral inside?
Y.
Yes, correct. But we want volume, right? So
Y square.
y square, yes. top, that's the top. You have identified the top. Maybe
Then the bottom is
minus.
square root of y. Oh wait, never mind. It's y minus 1.
Y minus 1, not y equals to 1 over x squared. You want to make x squared the subject. X squared equals 1 over y. It's just 1 over y. Don't need square anymore.
Okay.
Right? Or you can rewrite it as plus minus square root 1 over y. Then over here, it will be plus minus 1 over square root of y. But here, since we are looking at the positive values of y, we should only take the positive root. So it's just positive 1 over square root y. Then you square. Then dy. Okay?
Okay.
Yeah, then just use GC. Okay, whatever. The setup is the most important thing here. Can I move on?
Can.
Wrong. Moving on. So that is, now we move on to part B. Same thing, I believe. Here suddenly you remember it's dy. Not sure what's going on.
Well, sometimes I remember.
Read the question. Don't need remember. Just read the question. Anyways, so the question is asking, find volume of revolution. Let me mark your work first. Y equals to square root 4 minus x. You took the positive one because it's on the right. Because you're looking at the positive part of the y, I guess. This is the positive 4 minus x squared. Sorry, just 4 minus x squared. Then the bottom half is y equals negative square root 4 minus x. The top one is the positive root. Okay, then you have a vertical line over here that's x equals to 2. You have a region R over here, shaded region. How did you do it? Let me see. You found the coordinates 2, root 2 and 4, 0. Where is 2, root 2? Is it over here? This guy? Yes? No?
Yes.
Yes, huh? Then 4, 0 is here. Okay, can. You should draw the diagram. It will help you a lot.
Okay.
Okay. Then how do you solve the question? You integrate pi integral from 0 to root 2. So y coordinate, correct? And then you take top minus bottom. So in this case, top is what? This guy, right? Which is square root 4 minus x. So you square it. Oh wait, sorry. Wrong. You need to make x squared the subject first. So or x the subject first. So you get y squared equals to 4 minus x. So x equals to 4 minus y squared. That means that over here it should be 4 minus y squared then square. Okay, good. Then you minus away the bottom. In this case, there's a bottom here. It's not 0, it's actually
2.
2. So here it's wrong. Then it should actually be pi times 0 root 2 4 minus y square square. Bracket square. Then you forgot to minus away the 2 square. Do you know that you have to subtract away the bottom square? Bottom is here.
Yeah.
Bottom is this light blue. Top is this brown. Oh, okay. Yeah, so it's a mistake. Make sure you remember this to minus away the bottom square. So this answer is wrong. Okay, moving on. So now question 6. You got it's basically a similar question. Just that they changed the numbers. Here you got integral from, the diagram below shows the curve. I'm moving on to question 6 now. The diagram below shows the curve with equation y equals to x squared. Area of the region bounded by the curve lines the lines x equal to 1, x equal to 2, and the x-axis is equal to the area of the region bounded by the curve. The lines y equals to a, y equals to 4, and the y-axis, where a is less than 4. Find the value of a. So basically, they're telling you those two shaded regions are equal. You should draw the curve. Draw the curve. Okay, this is the two regions, the two shaded regions. They are equal. So find the value of a. How did you do it? What is the equation of this curve? Y equals to x squared. So you can make x the subject. X equals to plus minus square root y. Which one do you take? We are focusing on this half here, where y values are positive. So that's why we take the positive. x equal root y. And also you're finding area, so you can just take positive because at the end of the day, you need modulus if you want to make it positive. So let's just take the positive. Then what do? Take the positive root y, integrate from a to 4. Good. With respect to dy. Good, good, good. Then you equate it to integral from 1 to 2 of x squared. Good. You get x cubed over 3 sub in 2, 1 on the right hand side. Good. Let's just continue with the right hand side. Sub in the 2, you get 2 cubed over 3. Sub in the 1, you get 1 cubed over 3 for minus in between. Good. Left hand side, integrate square root y. Square root is just power half. Add 1, you get 3 over 2. Divide by 3 over 2 with upper and lower limits 4 and a. Okay, you factor out divide by 3 over 2 here means times 2 over 3. So you factor out the 2 over 3. Then you are left with a y power 3 over 2. Sub in the 4, sub in the a. So you get 4 power 3 over 2, a power 3 over 2 minus in between. Okay. Sub in a bit more, 4 power 3 over 2. This is really just 4 power half, then power 3, which is square root of 4, which is 2, then cube, you get an 8. Then you don't forget to multiply by 2 over 3, you get 16 over 3. You could just use a calculator as well. Then 2 over 3 multiplied by negative a power 3 over 2 is 2/3 a power 3 over 2. Left hand side is fine. Right hand side, you get 2 cube over 3 minus 1 cube over 3. Just use a calculator. So you get 7 over 3. Okay, good. Then here you got what's going on? Okay, over here you bring over become positive. 7 over 3 bring over become a minus. 16 minus 7 is 9 over 3. Then 9 over 3 is a 3. Good. Then you can divide by 2 over 3. So times 3 over 2, you get 9 over 2. Good. Then you rewrite this as the 2/3 root of a. Okay, can. Equals to a over 2, equals 9 over 2. Is it 9 over 2? Yeah. Then you solve for a by raising to the power of 2/3. That's wrong. Wrong. Do you know how when we try to solve for a, we're really solving for a power 1. So how do you get from 2/3 to 1 raised to the power of what?
3 over 2.
3 over 2. That's all. That's all you have to do. You don't need to convert into a root. So just bracket power 3 over 2. Answer is? Can you try? Do you get this? Please say yes.
Like using calculator. Oh yeah.
Yes.
Oh, okay. I thought you were asking to solve manually.
Oh, sorry. I saw wrongly. You started off with a 3 over 2. My goodness. Did I do it wrongly? Okay. Right. I got confused by your working. Sorry. Your answer is correct, but your writing is a bit funny. Over here, you took the 2/3 root. But the original is 3 over 2. Then you suddenly drop to never write down the a. You should actually continue writing down 3 over 2 here. In that case, then your working is fine.
Huh?
You raise it to power 2/3.
Write down the 3 over 2?
Yes, correct. A power 3 over 2, then you take the 2/3 root. Then they will cancel each other off. Actually, sorry. Wow, I'm getting confused. Sorry. Oh my goodness. It should be, if you want to use this root notation,
Yeah.
it should be 3 over 2 root of a power 3 over 2. Then they will cancel off. I think that's what you meant. That's what you meant. Because you eventually get to a and you raise the right hand side to power 2/3. That's actually correct. Your answer is correct. But your presentation is very fun. I think the simpler way to present it is a power 3 over 2 equals to 9 over 2 is correct so far. Then you just bracket raised to a certain power so that you can go back to a power 1, which was 2/3. Sorry, I mixed it up. Should start off with 3 over 2, which will give you a 2.73. Your answer is fine, but your presentation a bit funny.
But I thought a to the power of 3 over 2, I can just convert into 2/3 square root 3. No, not correct. Yeah, like that. No, not correct.
You look at your working. You wrote down 2/3, right? 2 here and 3 there.
Oops.
So that when I see that, what I interpret it as is 2/3 is your n, and then you have a to the power of 1. You never write anything, it means power 1. Does that make sense?
Yeah, okay.
Is that correct?
No.
No, this is not correct.
Yeah.
Okay. Yeah. So I think the simplest way is to present it like that. Nicer. Don't involve the root. Very confusing. Just use fractional powers, it's fine.
Okay.
Sorry. So question 6 is value of a found. What else did they ask? Yeah, that's all. That's all. Okay, moving on. Question 7. So let's take a look. So you got a sine x and cosine x curve with a a1 and a2 and a point P. With origin O, the curves with equation y equals sine x and y equals cos x, 0 less than equal x less than equal half pi. Can you hear me?
Can.
Okay. Meet at the point where P with coordinates 1/4 pi, comma half root 2. The area of the region bounded by the curves and the x-axis is A1, and the area of the region bounded by the curves and the y-axis is A2. So part 1, show that A1 over A2 equals to square root of 2. Let me see your working first. Integrate cosine x from half root 2 to 1. Half root 2 to 1. Okay, I need to draw the diagram first. So half root 2. Okay, this is half root 2 as the y coordinate. And 1/4 pi. You're integrating with respect to x, then you decide to go from half root 2 to 1. Where did you get your half root 2 and your 1? From the y coordinate, right? But where's my 1?
Like at the end, the y intercept, x intercept.
Yeah?
Yes.
No, it's a half pi.
I think it's supposed to be half
From
pi.
this y intercept. I think it should be the y intercept, right? Cosine curve. There's a 1. Then you go from half root 2 to 1. Do you know what you just did? You're actually you're very confused here, like, because you're using x, but you end up using the y coordinates. You use the y coordinates here. I mean the y values as your limits, but you integrate it with respect to x. So you are very confused here.
Oh.
Wrong already. So this is totally wrong.
Okay. So I can integrate with respect to x, right? Then I split it up.
Yes.
Okay.
Here and there, right?
Then A2 I'm supposed to use y, right?
Can, but there's a smarter way. Big minus small. Can you see? Big minus small.
Oh.
Big here, small there. Okay. The color.
Okay.
Gray minus away orange. Then you can get your A2. I think that's a bit faster.
Okay.
A2 equals to gray minus away orange. But now let's find the orange first. Can you try again? For orange area, that's really just A1. Integral from what to what?
The grade 0 to pi over 4.
Dx. Add on pi over 4 to pi over 2.
Sine x.
First one is sine x.
Then the second one is cosine x.
Much better. Yeah. So did they request for exact value? Yes. A1 over A2 equals to square root of 2. When you see a square root, it means they want exact value. So no choice, I must manually do this. Let's do it together. So integrate sine x, what do you get? Negative cosine x, sub in the limits pi over 4, 0. Plus integrate cosine, what do you get? Sine x. Then you sub in the limits pi over 2, pi over 4. Now sub in. So you get negative cosine of pi over 4 minus away negative cosine. So you can simplify as a plus. I hope that's not too fast.
Yeah.
And add on sine of pi over 2 minus away sine pi over 4. Simplify. Cosine pi over 4, that's 45 degrees. So it's just 1 over square root 2. Plus cosine 0, that's a 1. plus sine of pi over 2. That's 90 degrees. So sine 90 is a 1. Minus away sine of pi by 4 is 1 over root 2. Exact values. Must know this from Amex. Very fast one. Okay, then now you can simplify. Minus minus becomes 2 copies of 1 root 2. So minus 2 over root 2. But then add on 1, so plus 2. Okay, can?
Can.
Good. Okay, that is your A1. Are we done? No, we still need to find A2. I have no space already. I'm just gonna add a page. Yeah, so it's gonna be quite messy. So sorry. No space, no choice. Okay, just to make things neater, I'm gonna bring everything over to a new page.
Okay.
Just redo the whole thing. Yeah, error carry forward. So this is part 1. Then we found our A1. Now how to find A2? A2, you just need to find the gray area first. Then you minus away A1. So let's find A2. A2 in this case is equal to the gray area. What would it be? Integral from?
The 0 to half pi over 2.
Half pi over 2, same. And what's in between?
The cosine.
Yes, correct. This is cosine. Maybe I label cos y equal cosine x. That was y equals sine x. Okay, good. Then minus away what we found. Minus 2 over root 2 plus 2. So let's do that. Calculate. What will we get? This is equal to integrate cosine, you get sine. Square bracket. You get 0 pi over 2. Minus away, become a plus 2 root 2 minus 2. Simplify this, you get sine pi over 2. Minus away sine 0, which is 0, plus 2 over root 2 minus 2. Simplify, sine pi over 2 is what? 1, 1 minus 0 plus 2 over root 2 minus 2. Okay, good. So 1 minus 2 is negative 1, so plus 2 over root 2. Can?
Can.
Okay, then now let's find the answer. Show that A1 over A2 equals 0. Just a square root 2. We just divide. So take the numerator to be the answer we found from the previous part. This guy. Divide by what we just found, negative 1 plus 2 over root 2. Can? Now we need to try to simplify and show that this is root 2. Maybe I will start off by factoring out a root 2 from the numerator. If I factor out root 2, what do I get? I'll get negative 2 over root 2 with an extra root 2. Then I add on 2 over root 2. Is that clear? If you, okay, it's a bit like, let's say I have 3 plus 5. I want to factor out a 7. How can factor out 7? 7 cannot divide by 3 and 5. But you're in H2 max already. By now you should know everything can factorize out anything. You just need to introduce fractions. 3 over 7, 5 over 7.
Oh, okay.
Correct or not? So now we bring it back to more complicated numbers involving square root. If you factor out square root 2, you also divide. But wait a minute. What's 2 divided by square root 2? Square root 2. Square root 2 times square root 2 is?
2.
2 divided by 2 is?
1.
So that means I can simplify now. Square root 2 times negative 1 plus 2 over square root 2 is? Just leave it alone. I know it's 1 over square root 2, but leave it alone. Why? Anything the same?
The denominator.
What a coincidence. Cancel off. Then you're left with square root 2, which is what we want shown.
Okay.
Yeah. Okay. That's why I factor out square root 2. Because I already know I want square root 2. I know that I can cancel eventually. Moving on, that is part 2 now. The region bounded, I am not marking your rest of your part 1 because you had error carry forward. Everything else is wrong. No point now. Oh, sorry. Let's look at part 2 now. The region bounded by y equals sin x between O and P, and the line y equals to half root 2, and the y-axis is rotated about the y-axis to 360 degrees. So volume of revolution. Show that the volume of the solid form, volume of revolution, is given by pi times the integral of whatever square dy. So here you see dy. Straight away, you need to know volume of revolution about y. It will be useful if you draw the diagram and then you draw this curly little this little curve here. Oh, like this, to remind yourself you're turning about the y-axis. Let me just copy down the diagram from before so I can save some time. Sorry, excuse me. Where was I?
You
Oh,
drew
part
the
2.
arrow. Yeah.
Yeah, part 2. Your part 2 is blank. Wait, oh, huh? You never show part 2. Oh, you don't know how to do part 2, is it? They didn't show.
Yeah, I cannot show, so I.
Okay,
Right.
never mind. I show. Let's go. Let's just do it. Don't waste time. Go. Cut and paste. This is question 1, huh? Question 7. Okay, let's go. Question 7, part 2. Go. So this is the region. We have A2 there and A1 there. What do we want to show? We want to show that the volume of revolution of the region bounded by sine x between O and P, and the line y equals to half root 2, and the y-axis is rotated about y-axis. So which region are they looking at? Can you shade for me? Can you try drawing on the diagram?
Okay.
Right, annotate. Which one?
One.
So are you saying this entire A2?
No.
No, it isn't. Try again.
This one.
Huh? I cannot see anything. Oh, the top half?
Yeah.
Let me read the question now. Between O, let's read the question now. The region bounded by y equals sine x. So it's this gray guy over here. Between O and P, so it's this point O and this point P. And the line y equals to half root 2. So it's this guy over here. And the y-axis, so it's this guy over here. Is that clear enough? So do you still think it's the top half?
No, it's the bottom.
It's this half, right? So maybe for you, you should use a lot of scrap paper, and you need to bring into your exam hall highlighters. Just follow the question. Sin x, highlight sin x. Y-axis, highlight y-axis. Y equals to half root 2. Remember your sec 3 math. Horizontal line, y equals horizontal line, highlight. Then O, highlight O. P, highlight P. Then you'll know straight away that it's the bottom region. Okay? Can is it clear enough?
Yeah.
Can Okay, good. Then what do you do with the orange region? Rotate about the y-axis. Turn like this. I strongly recommend you to draw diagram because you keep on making this kind of mistake. Cannot. Okay, good. That's your first step only. Then after you identify the region, I think it should be hopefully easier. When you rotate about the y-axis, you need to integrate x dy. So you need to make x a subject. So over here, you got sine x. So what do you do? How do you make x a subject? X will be equal to sine inverse of y. Correct?
Yeah.
From what to what?
0 to square root 2 over 2.
Correct, yes. But take note that this is y equals. So yeah, that's why. Also, this is volume of revolution. So what's missing here? What's missing here?
Pi.
Pi is missing. And what's in between? Before dy. What's before dy?
The sine inverse y squared.
Sine inverse of y then square. Okay, good. So now did they request for calculator? No, they just ask you to show. Okay, that's it. Which is already given by the question. This is volume of revolution. All right.
Yeah.
And good.
Okay.
Okay, moving on. So now, what do I want to do next? Part 3 lor. Part 3 show that the substitution y equal to sine u transforms the integral in part 2 to pi times integral a to b u square cos u du for limits a and b to be determined. Hence, find the exact volume. Okay, so we need to do our substitution. This is basically integration by substitution again. What are the 3 things you need to look out for again?
The limits, then the dy change to du.
Good. And number 3 is?
Then the sub in the u into the expression.
Sub u. Sub y with u. So you need to travel from the y world into the u
U.
world. Convert into the other variable. So in this case, let's just work with the limits first. What's the lower limit we have? Y equals 0. What's the upper limit we had past tense? 1 over 2 root 2. I mean half root 2. Then we need to transform into u. But what's a substitution? So we should start with writing down the substitution. U equals to, sorry, y equals to sine u. So how do you solve for u? U equals to sine inverse of y. Then here, what would the u be equal to?
The sine inverse of y.
Correct. Good. Let me write it down. So this would be sine inverse of, what is it? Half root 2. Is there an exact value to this? Yes, it's just 45 degrees. Remember?
Yeah.
1 square root 2, 45, which is pi over 4. Sorry. Yeah, so wow, this pi over 4 looks very bad. Let me try again. Okay, so y equals to 0. How to find the limit? Sub in again. So u equals, can you try? What is this equal to?
Pi over 2. Is 0.
0, 0. Yes, yes. Sine inverse means you find the angle, find the x value. If y equal to 0 here, what's the corresponding x? Or in this case, u. So it's 0 lah. Moving on. So dy to du, what do you need to do? Write down the substitution first, then
make du the subject.
before you can have a du, you need to differentiate. So dy by du first. Then you get cosine u. Yeah?
Yeah.
Okay, can then what you were saying, yes? Make what the subject?
The dy.
Very good. So that means that dy is equal to cos u du. Okay, good. Then are we done? No, we still need to sub y with u. So what do we have to do? This one need to do the question already. So what do we want? We want to copy down the expression first. So v equals to the pi times integral from half root 2 of sine inverse y bracket square dy. Now you have to sub in. Pi leave alone, but the limit, we had y equals. Now change into the what world? Change into the u world. So u equals. U equal what? Can you tell me what's the bottom? Lower limit?
0.
Upper?
Pi over 4.
In between?
A u?
U, yes, exactly, u. But that's sine inverse. But you have a bracket?
Square.
Square, right? Remember, because volume must have a v square, top square minus bottom square. dy?
Cosine u du.
Yes, cosine u du. I strongly recommend you to write down the original expression first. Then you differentiate. Then you try to write it as dy, make dy the subject.
Okay.
Okay, good. Then have you answered the question? No, they want us to almost. You want to determine the limit a and b. So a equal what? B equal what?
Pi over 4 and 0.
Very good. Now we can move on to the hence part. Hence, sorry. Hence find the exact volume. Can we integrate this?
No, must use by parts.
Yes. Good. So now you have to find the exact value by using integration by parts. So please don't be confused. This is u of x. Then we got dv by dx, then du by dx, then v of x. Don't be confused with the u. Okay, so what's u of x? What's dv by dx? U square is algebraic, like x squared. Cos u is trivial. So which one do we put as u of x?
U is the u square.
Okay, good. Then what's du by dx? Okay, in this case, sorry, since the variable is u, right? We should be integrating with respect to u. So perhaps it would be easier if we, since this is a definite integral, the variable doesn't really matter. We can just replace the u with x. I think it's easier that way. It is equivalent. Remember, definite integral is just a number. I think it will be easier if we just convert it into x. You'll get the same answer. Okay? Then we ignore the u, we focus on the x, so we don't get confused with the u here. So what's du by dx? Maybe instead of u square, it's now x square.
2x.
Good. Need to change rule or not? Differentiate the x. Get times 1. Oh, wait, it's the same. Don't need. Lucky. We still had to use chain rule, but x is, in this case, differentiate x just a 1. Times 1, don't need to do anything. How about dv by dx? Cosine x. Integrate, what do you get? Integrate,
Sine x.
Sine x. Okay, good. Then this one will become pi times. I'll just put a huge bracket here. Then what minus what?
X squared times sine x minus integral sine x times 2x.
I would prefer writing the 2x in front. If not, you confuse with sine x. Later, accidentally read as sine x square or something because you're handwriting x, and suddenly your 2, you feel suddenly your hand tremble, then your 2 go on top, then it become x square x. Then you integrate sine x cube. Wow, gone. Cannot. Try not to. So I like to write my algebra on the left side and the trigger on the right side because I already did a lot of practice. I make all sorts of careless mistakes. So what's the limit? Here, you still got limit. So you must draw square bracket right down. 0 pi by 4. Upper and lower. Oh, don't forget dx. Upper and lower.
0 and pi over 4.
Okay. Can I leave you to do the rest? This one is again integration by parts.
Can.
Do the rest on your own. ... Then you'll get the answer. Okay, moving on. Question 7. Oh, still not done yet. Oh my goodness. Okay, let's go. Try to submit earlier so I have time to mark it. Okay. Let's look at question 8. Where's question 8? Over here. Can't remember. Let's read the question first. The diagram below shows the region R in the first quadrant bounded by the curve C with equation y equals square root x plus 2 over square root x and the line y equal to 3. The line and the curve intersect at the points 1, 3, 4, 3. Calculate exact area of R. Top minus bottom.
Wait.
Oh, okay, I can wait. Yes.
No.
Huh?
No, nothing.
Oh, okay, I'll just continue. So top is what? Y equals to 3. Bottom is what? The curve square root x plus 2 over root x. So you just have to take top minus bottom. However, there's a faster way, which is to realize that it's a rectangle. Right? It's a rectangle.
Yes.
The rectangle here, the orange rectangle. So there's a length here, which is 3. There's a base, the height of 3. Then the base is 4 minus 1, which is 3. So area is actually just 3 times 3, which would be a 9, but here you gave me a 1, which is wrong. Can you understand what I'm saying?
Yes.
Yes, huh? So it's wrong already. Oh no. 9 minus the area under. What you just found, this guy, yellow color, it's actually this region at the bottom. Okay, maybe my color is not that nice. I'll use a different color. Yellow at the bottom. Then the total area was this guy. Wow, too dark already. Okay, I cannot use yellow. I need to use a different color. Let's say I put gray. It's actually this part here. Then my original 9 here is this region here. Can you see? Can so 9 minus the gray. So error carried forward. Just your working is fine. Yeah. Then I don't go through. Is that okay? Because error carried forward. You know how to solve this kind of integral. Moving on to another question.
So my 1 to 4, that part not correct.
1 to 4, that part is, let me double check. This is correct. 9 is not, the only error is this 9 here. This 1 here should be a 9.
Okay.
Then the rest is fine. Let me just double confirm. Okay, 4 is correct. Sub in 4 and 1 is, yeah, you didn't show the working, so I'll assume it's correct. How come there's a line here? What's that? Should I just ignore it?
I put modulus.
Oh, sorry. Oh my goodness. You sure it's modulus? How come there's a minus sign here?
Yeah, because I thought it's the I think I got confused. Like I thought I was finding R directly because I found the area on top of the curve instead of below. So I put negative.
Because you times -1 because you are above the curve. Wait, I'm confused. What do you mean? Why would you need a negative? Don't need. You see, when you integrate from 1 to 4, you're finding the area bounded by the curve, the x-axis, and 1 and 4, which is this region here. This region here.
Like every time you integrate above the curve is like negative.
Integrate above the curve. What do you mean by above the curve?
Like I integrate, but I'm finding the area above the curve instead of below. So I thought it's put negative.
You cannot find area above a curve. How do you do that? It's always area under a curve.
I thought can find area above the curve.
No. Integration is always like, if it's with respect to dx, it's always some crazy function y equal f of x, x-axis, x value, let's say x equal to a, another x equals to b. There's a region above the curve. There's a region below the curve. When we integrate f of x, let's just pretend it's sine x. I don't know, like maybe sine x plus 5. Then it will be sine x plus 5 from, I don't know, a to b. It will always be the region under the curve. Since when did you integrate above the curve? No. You try to -1 to find above the curve? No. That's only if you only times -1 if it's like, if it goes below the x-axis. Like let's say this is cosine, and you are integrating from, this is pi over 2, this is 3 pi over 2. Then pi over 2 to 3 pi over 2 will give you a negative value, like this. So you have to times negative to bring it back up to become positive. Does that make sense? But it's still sort of the region bounded between the curve and the x-axis. That's the technical definition. And 2 coordinates.
So there's no way to find area above the curve.
So you're saying you want to find this region R already, right? No.
Yeah.
No, there isn't. No, I don't think so. Unless you do some graphical transformation, but not really, no. You can only find the gray area, the region under the curve, above x-axis. or in between the curve and the x-axis. Curve, x-axis, in between. No such thing as finding area above the curve. Never hear before.
Oh,
Okay?
no.
Stop coming out with your own rules. Oh no.
Oops. Okay.
Okay, can huh?
Okay. I
Yeah.
thought that was the way to find for the entire 2 years. Okay. Can.
Okay, can. Okay. Yeah, it's always under the curve, 2 lines, and then the x-axis, so area underneath. Always area underneath the bridge. Yeah. Then you have been drawing all these rectangles. What do you notice? They're always under the curve, right?
Yeah.
Always under lor. When is it above? Only maybe slightly above if you're doing over estimation. But it's actually roughly most of the area is still under the curve, right?
But if you flip the graph like opposite, then doesn't it become like correct?
Yes, but then you need to do a graphical transformation. Flip it upside down. You mean you reflect it. So instead of dealing with y equals fx, you deal with y equals negative f of x.
Yes. Then not correct.
If you do that, no, you will still be getting the region bounded between the curve and the x-axis, which is still this shape. That's still not the region R.
Oh.
Between the curve and the axis. Curve and the axis. Which usually we are in quadrant 1 usually then it will be under the curve. Area under the curve. It's a short form for there's a curve here, there's an axis that you're integrating with respect to, and there are certain boundaries, in this case 2 vertical lines, such that it traps a certain region in between. Then we are finding that area. It's usually under the curve. Or in this case, your gravity is going this way, so under the curve is this region. Never above. Clear?
Yeah, okay.
Moving on. Okay, now that was A part 1. I'm gonna skip A part 1. Maybe I'll write down the answer to A part 1 at the top for reference. We may need to use the answer. So for A part 1, we found the area of region R. Area R equals to, I'll just refer to the answer key. In this case, it is a 1/3 unit square. Moving on, so now we have the part 2. Let me just get rid of that pencil marking on the screen. Clear all drawings. Okay, part 2. Write down the equation of the curve obtained when C is translated by 3 units in the negative y direction. What does that mean? Move left, negative y direction. Move down by 3 units. So that's very easy, right? You just need to minus 3. Okay, good. Moving on. Part 3, hence or otherwise, show that the volume of the solid formed when R is rotated completely about the line y equals to 3 is given by the following integral. Then evaluate this integral exactly. Let me see your working. So root 3 plus 2 over root x minus 3, you square it, then you integrate from 1 to 4. Then bracket square, and then times pi. Let me think a little bit. In this case, if you minus 3, yeah, correct, good, yes. Okay, that's fine. So I think you can visualize what's going on now. So at first the graph was on top here. Then you move it down. So there was a y equals to 3. Now if you shifted it down by 3 units, like this. You see? Before, after.
Yeah.
So now the y equal to 3 is now y equal to 0 x-axis. Then you can just proceed as per normal, integrate top square minus bottom square. In this case, bottom square is just the x-axis already, so y equal to 0. That means you can you don't need to minus bottom square. So your working is fine. Perfect. Okay, now carrying on. Did you get the final answer?
It's very weird.
Very weird. Okay, I check. Okay, let me see your expansion first. Oh, you expand it straight away. Oh, you rotate it aside. Okay, let's check. So this times this is x. This times this is 2. This times this is minus 3 root x. Okay, next one is plus 2. Next one is 4 over x. Next one is minus 6 over x, root x. Next one is minus 3 root x, fine. Minus 3 times 2 root x is minus 6 root x. Minus 3 times minus 3 is plus 9. Okay, perfect, good. Then just transfer over. Hopefully you didn't transfer wrongly. Combine like terms, minus 3 root x, minus 3 root x is minus 6. Okay, this is done, this is done. Minus 6 over root x, minus 6 over root x is minus 12. Oops, sorry. 4 over x is here, okay. Plus 2 is plus 2 plus 2 plus 9 is 13, okay. Then you have an x. Okay, good. Can, so far, okay. So you have shown it, shown, good. Evaluate the integral directly. So x squared over 2 minus x power 3 over 2 over 3 over 2, correct? Plus 13x, okay? Minus square root x at the bottom, bring up is actually negative half. Add 1, you get positive half, divide by positive half. This is okay. And then the last one is 4 over x, integrate, you get 4 ln x. Good. Okay. And sub in 1 and 4. So you get 4 square over 2 minus 6 times 4 power 3 over 2 over 3 over 2. Minus away 13 times 4, minus away 12 times 4 power half over half plus 4 ln 4. Minus away pi times, sub in with 1 now. 1 square over 2 minus 6 times 1 power 3 over 2 over 3 over 2. Minus away 13 times 1, minus away 12 times 1 power half over half plus 4 ln 1. Okay, perfect, good. Now we just need to simplify on the calculator. Let me just double check with your solution key. You're working so far, it's fine. The final answer that they want is pi times 4 ln 4 minus 11 over 2 unit cube. But you got a 167 over 2. Is it just a careless mistake? I think it is because your answer, your working is fine. Maybe I show you. Let me. You have your worksheet with you. I'll show you the calculator how to type it.
Okay.
I mean, okay, you know what? I don't want to use this calculator. Let me use a different calculator. Maybe this guy instead. This is a scientific calculator. Not sure if you still have it, but can see? Can I? Okay, I'll just key in the values that you had. So 4 square over 2. 4 square over 2. Then you have a minus 6 times 4. Power 3 over 2, 1.5. Over 1.5. Minus away 13 times 4. And minus 12 fraction times 4 to the power of 1/2, 0.5 over 0.5. Then you have to now, okay, I'll just evaluate this first. Oh, negative 124. That's from the first pair of brackets, but don't times pi yet, just leave it inside. Then after that, you have to subtract away the following, open bracket. Okay, maybe I'll just leave the 124 alone, negative 124 alone. Shift store as A. Let's start in variable A now. Alpha A, you press equal, you get negative 124. AC, try the other value. You get 1 square over 2 minus away fraction 6 times 1 power anything is 1. So I just leave it alone. Don't need to write anything. Divide by 3 over 2. So 1.5 minus 13 times 1, which is just 13. Minus away 12 times, okay, fraction first. 12 times 1, which is just 1 power anything, which is just 1. Then divide by half, which is 0.5. And then enter. You get negative 81 over 2. Shift store B. Then what do you do next? Take the A, minus away the B. You get this value, minus 167 over 2. Your answer seems correct. but they requested for 11/2. Did I? Let me see. Hold on a second. Your answer seems fine. Could the answer key be wrong? (12.2x). Oh, right. Wait. No. Sorry, give me a moment to think about this.
Okay.
How do you get 12? X half bring up minus half and 1 get positive half. Okay, wait. Let me share screen now. Okay, this is the solution provided, right? I believe they made a mistake over here. Over here, 12.2. When you integrate 12 over root x, you should get 12 times x power positive half divided by half, right?
Yeah.
Yeah, so I think your working is correct. They are wrong. Your answer is correct.
Yeah.
Okay, 11/2 is wrong. No, the answer is correct. Unless I'm making a mistake. Yeah. It comes to 24. Wait. How did they get a 24? What? Huh. Very funny. There's a mistake over here. Shouldn't be 12.2. Should just be 24. Yeah. Okay, I'll get back to you on this one. I think their answer is wrong. Your answer is correct. Okay, but you got the concept.
Okay.
Good. I'll just integrate term by term. Oh. Okay, back to the question. So where was I? Yes, you're working over here. Eventually the value of b was -81/2 here. So you get -167/2. I think your answer is correct. So this part, the answer key may be wrong. Okay, moving on. Next one, question 9. Find the area of the region enclosed by the curve whose parametric equations are parametric, your weakness. X equal a cos 2 theta, y equals b sin 2 theta, where 0 less than equal theta less than equal to pi, and 0 less than a less than b. Okay, answer is 3.14 AB, 3SF. Okay, so in this case, let me see your working first. Yeah, you identify it's a ellipse. Okay, that's good. Then x equals to a cos 2 theta, b equals to sin 2 theta. Then you take x over a, you get cos 2 theta. Then what do you do? Cosine inverse of x over a divided by 2 to get theta. Okay. Then you rewrite it as sine inverse of y over b. Oh, you went from y, you make theta the subject. Can. So these two are equal, but there's no point in doing that. Why would you want to do that? Right? The key is to realize that the area of these four regions are equal. Okay. So you just need to find one. When they're asking you to find the area of the region enclosed by the curve, you just need to find one of them. Then you times 4. Is that clear?
Oh.
Yeah.
Okay.
Alternatively, you can take half of it, then you times 2. I think that's what you did over here. 2 times integral y dx of minus a to a. That's fine. This is okay. Can also. Then in this case, if you sub in the limits, what do you get? X equal to a, x equal to minus a. Sub in, you get a equals a cos 2 theta. Cos 2 theta equal to 1, theta equals to 0. Okay, good. Then if x equal to minus a, you get minus a equal to a cos 2 theta. Divided by a, you get minus 1. Sub in, you get theta equal to pi over 2. Cosine pi is -1. Correct. Yes, yes. So 0 and pi over 2 as upper and lower limits. 0 pi over 2, negative pi over 2, or positive. Or positive, sorry. Okay, then you just replace the insides, the y with something, which is your b sine 2 theta. Okay, then your dx, you differentiate, so you get a times negative sine 2 theta, but you do it chain rule. Well done. Then you get -2 sine 2 theta. Why is there a times 1? Huh? I'm not sure what's going on. How come got +1 here? What did you write here? Shouldn't be there, huh?
Plus 1 cosine 2 theta.
Don't need. No. You're just taking x, you see. Cosine is already linear, ma. Don't need to use any identities. This is your answer already. Here. Don't need the +1 times cosine. No need. Okay. Then, yeah, so error carry forward. How come got plus cos theta? Can you explain to me why you have this?
I think I thought I need to chain rule.
Chain rule. Here there is a times cosine 2 theta. So how many functions can I see? Maybe I see 3 functions. F of maybe f of x is equals to a times x. Then g of x is equals to cosine of x. Then h of x is equals to 2x. Then here, this function is f of g of h of theta. Chain rule. Can you see? A times cosine of 2 theta.
Yeah.
Right? So if you do chain rule, you're just dealing with the a. So factor out the a. Deal with the cosine. You get differentiate cosine negative sign. Then differentiate 2 theta. You get 2. That's all. Chain rule always involves multiplication, not addition. And yeah, you already dealt with cosine, so why would you get another trivial expression? You shouldn't get another one. Like, how did you get another cosine here? Doesn't make sense. Should I demonstrate it step by step?
Can.
Okay, so this is a cos 2 theta. Differentiate x with respect to theta, you will get factor out the a, then multiply by derivative of theta with respect to theta of cosine 2 theta. Then you get a times of differentiate this with respect to theta. What's the outer layer? Cosine. Inner layer 2 theta. So differentiate cosine, you get negative sign. But you must copy and paste the insides 2 theta. Then chain rule tells you must multiply by derivative of the inside, which is 2 theta.
So it's 2.
Which is just a 2, exactly. So times 2. So simplify, you get minus 2a sine 2 theta, which is what you got over here. That's all. Why got an extra portion? Shouldn't have. Understand now?
Yeah.
Okay, moving on. So error carried forward. Basically, you should actually get 2 times the integral of what was y? B sine 2 theta multiplied by dx. But dx, if you just bring over, it means dx is equal to negative 2a sine 2 theta d theta. Also, I can just copy and paste it. Like this. And what's the upper and lower limits? It's pi over 2 to 0. Okay. Then this is wrong because of this part here. So how do we simplify this? How do we integrate this? Well, the question did not require exact value, right? So you can just factor out all the constants here. I see that there's a negative 4b. Is it right? Let me double check. Yeah, there's a negative 4b, integrate pi over 2 to 0 of sine 2 theta times sine 2 theta. Simplify, we get sine square 2 theta, d theta. Is that okay? Oh, I forget a letter A. Sorry, AB. Is it okay?
Yeah, can.
Then this one just use GC. Use GC. You can integrate manually, but no need. Use the double angle formula. Use the ultimate summary. Sine square can convert into 1 plus cosine, I think. Or is it 1 minus? I can never remember it. Cos square theta minus sine square theta. Then it's substitute cosine square is 1 minus sine square, so 1 minus 2 sine square. If you make sine square the subject, what do you get?
1 minus cosine, 2 cosine square.
No, don't use the first version, use the second one. So 1 minus 2 sine square makes sine square the subject. You get 2 sine square equals to 1 minus cos. Then you divide by 2. Can?
Okay.
Yeah. But you don't need to do that. Just use GC, so on and so forth.
Okay.
Okay, moving on. Next one, question 10. Let's go. So this one, a curve has parametric equation x equal cos square, y equal sine cube, 0 less than equal t less than equal to half pi. Sketch the curve. Sorry. Just use a GC. Let me just share screen now. If I can get my calculator out first. Right, so what is the function? Make sure you're in the correct mode. Press mode first, go to parametric, y equals. What did they want? They want x equal cosine square. So we can bracket cosine t, close bracket, power 2. Oh, okay. Actually, second left, delete. Just square is fine. Next one, they have y equals to sine cube. So sine t, bracket power 3. Draw the graph. Oh, cannot see. Then zoom, maybe zoom, press zoom. Number 5 for square. Not very nice, so we zoom again to maybe zoom out. Number 3. Okay, so the graph is very small, but we must also change our t value. Our t value is what? From what to what? 0 to pi over 2. So we must change this to 0 to maybe type in second pi divided by 2. Oh, coincidentally, it's the same value. Not always the same. Then maybe you can do zoom box instead, so we can get a more precise graph. Okay, that's the graph. Can?
Can.
Here, if you change the scale, right, to like, let's say pi, then you'll get extra part of the curve, which is not required. Like, if you change all the way to, let's say, 4 pi or something, you start getting a bottom curve, right, which is what you wrote down in your answer. That's wrong. That's wrong. You see, what happens is that the curve went up, it went back down, overlap, and then it goes down, and then it overlap. That's not what you want, because the graph already mentioned, the question already mentioned 0 less than equal t less than pi over 2. So 0 to pi over 2 actually only stops at the y-axis. Don't have the bottom part. No bottom part. Is that clear?
Yeah.
Okay, so you need to redraw your graph. Your graph is wrong. Can you understand how to use the GC now to get the graph? Make sure your T max is changed, your T min and T max is changed. Here they said 0 less than equal t less than pi over 2, so must change accordingly. Is that clear?
Okay, can.
Then you graph. So there's only one top half curve. Okay, back to the screen, back to the iPad screen. Okay. Can happy face, can you see?
Can.
Okay, good. So your graph is wrong. You should only focus on the top half. It should be only the top half. Bottom half shouldn't exist. Remove. Moving on. So now, you tried to eliminate the t, but you didn't do it successfully. I also don't recommend you to do that. It's a bit difficult. No, don't during A level. Don't waste time. Don't eliminate t. Oh, don't eliminate t. It's a waste of time. Answer straight to the question. Don't eliminate t. So let's answer straight to the question. What did the question ask us? Part 1, sketch the curve. Use GC, you get the top half only. You also get these two coordinates 1, 0, 0, 1. But also, let's just figure out what's the t value. If you were paying attention to the graph as it was being drawn, you realize that it grew in this direction. You realize that it grew in this direction. So that means that it starts from the small value t equals 0 to the biggest value t equals pi over 2 at those 2 points. Okay? Also, you should draw solid circle because why? Because 0 less than equals t less than equals pi over 2. I'll use pink color to emphasize. Equal. So that's why you have solid circle. Solid circle. Clear?
Yeah.
Good. Okay, part 2. Show that the area under the curve for this guy is whatever and use the substitution. Okay, this is, let me see your working. Sine t equal to u, differentiate, you get cosine t. Good. Then you hold on now. Oh, what are you doing? Very, very funny. How come you don't want to just write down? Why don't you just write down an equation? Why you want to write an expression? Like du by dt. I saw this a few times already. Why don't you just write it down? Du equals to, then you bring the dt over, cosine t dt. Why you want to do this something funny like this? Du over cosine t. What are you doing? I don't understand.
I also don't know.
Okay, can. Yeah. Wait a minute. Let me read first. So,
But it's in DT though. So
okay. They use u equals to sine t. So here you notice that the original curve doesn't involve u. It actually involves. Oh wait. Sorry. Oh my goodness. Oh, I understand now. This question is multi-layered, 2 layers. First is parametric. You must convert from x and y into t's. Then after that, you need to go from t to u. Okay, I'm just going to demonstrate to you how to do this question. I think you didn't do it correctly. Is your answer correct first? Let me see. 2 is wrong. Okay, I'm just going to demonstrate from scratch. 10 part 1. Let's go. This is question 10. Yeah. Okay, so let's take a look at this question 10. For part 1, we already have the graph like this. These 2 points, 0, 1, 1, 0, and then you got t equals pi over 2, t equals to 0, x and y, and then you got the function. What is it? Let me just write down first. X equals to cosine square t, y equals to sine cube of t. What we want to find in part 2 is the area under the curve for 0 to 0 less than equal t less than equal to half pi. So it's basically asking you to find the area underneath this curve. How do you find the area? It will just be integral of what over integral of what? Can you tell me?
0 to 1.
Okay, then what is the function? D what?
Cosine square t.
Wait, slowly. What would this be? Standard form. We're integrating with respect to
X.
so dx first. Then what's the function here? It is really just a y. Then you proceed to substitute. So this is x equals. What do you do next? This will be our starting point. Y then dx. X dy or y dx. Standard formula. Next one. Replace y with
the sine cube t.
Okay, maybe I should start by mentioning the 3 things. I already did number 2. Replacing the y with something in terms of t. What else do you need to do? What are the 3 things to take note of?
The substitute inside.
What? Substitute what?
Oh,
Wait, that's integration by substitution. I know integration by parametric integration and substitution look very similar, but you actually need to do 2 levels. First, you need to do the parametric first. From y and x go into the t world. Then later you go from the t world to the u world. That's the point of this question. We are currently still at the first stage. Please focus on the first stage. So what are the 3 things again? I thought you always start off with a L for what? L for?
the limits.
Limits. So in this case, what's the limits? X equals 1, x equals 0. Convert into which world?
The t.
T world first. So it's like you want to travel to a far away country, then you have a transition country in between. Maybe you go to Malaysia first, then after that you go Thailand. I'm not sure why, but okay. So t is equal to what? If x equal 1. So we just write down, maybe not a bit too fast, we just do it step by step. So 1 equals to cosine square of t, right?
Yeah.
Then solving for t, what do we get? We get t, maybe we take the square root first. Cosine of t is plus minus square root of 1, which is just 1. But which one do we take?
The positive.
Why? Correct.
Because
Why?
the curve is like at the positive side.
Very good. Yeah. More specifically, this cosine is not really related to the curve. It's related to the t, right? Cosine is related to t. What do we know about t?
Must be more than 0.
And less than?
Half pi.
Pi, which means 90 degrees. So in between 0, 90, and 90 degrees. So cosine 0 degrees until cosine 90 degrees is always?
Positive.
Exactly. That's why. That's the reason why. You don't look at it. It's not because of the graph. It's because of the t. It's possible that the graph is, it is possible for you to have a function such that the graph is over here. Then this is maybe t equals to 0. Then this is t equals to 1. Or something along those lines. It is possible that it's negative here, but then you will still, because of the t value, still take the positive root. Are we clear on that?
Yeah.
Focus on the t, not the graph. Focus on the t, not the graph. Because cosine here is related to t. Maybe I should write down some reason. Focus. Why? The reason why is because 0 less than equal to t less than equals to pi over 2 is quadrant 1. And you know this from AMAX, ASTC rule. Quadrant 1 is this region here, A. So all are positive. In other words, cosine of t will be more than 0, positive. It's not related to the quadrant of the graph. Not linked to the graph. Okay, no link actually. Focus on the t. Okay, so positive 1, then how to solve for t?
Cosine inverse.
Okay, which is? Special case, you forgot the crash course on trigo already.
Oh.
Draw graph. Y equal to 1. Intersect. But restrict within the domain 0 to pi, half pi.
Is
Answer
0.
is 0, yes. Can see here is 0, x is 0, and here is pi over x to pi over 2. So the only time when it intersects the y equal to 1 is at the top. Do you understand this diagram?
Yeah.
Okay, good. Then next one, x equal to 0, 0 equals to cosine square t. Then that means that you take the square root, so cosine t equals to 0. How do you solve for t?
Then take the cube root.
Why cube root? We're still at the limits. We're still substituting x equal to 0 into the cosine square t.
Oh.
What cube root?
Oh.
Hello, are you awake?
No.
I've been talking more than you. I should be more tired.
Pi over 2.
Pi over 2. Let me double check. Yeah, correct. Yes, good. So now that we have finally found our lower and upper limit, what do we do over here? Fill in the blank now. Lower is
pi over 2,
good. Upper is
0.
well done. Good. Now we have also replaced our y with t already. Now the third one is to replace what?
Replace the limits. I mean the dx.
Yeah, replace the dx. So how do you replace dx? What do you do? Copy down the relevant part that involves x. So x equals to cosine square t. Or replace it with what? D something. What's the letter?
D theta.
D theta. Since when got theta?
Dt.
T, right? In this case, there's no theta, it's t. So how?
Differentiate the dx.
So what do you get? Dx over?
Dx over dt is
Waiting.
negative 2.
Let me rewrite it as cosine t and bracket power 2. Does that help? You're saying negative?
Yeah, negative 2 sine t.
Wrong. Chain rule requires you to copy and paste the insides first when you bring down the power. So for example, if let's say you are differentiating with respect to x, or like let's say y equals to 2x plus square root x power 3. How do you differentiate this? Is it just 3 times differentiate 2x, you get 2, then square root x, you get half x power negative half, and then power 2. Is this correct?
No,
What's wrong?
I never copy the thing.
Copy the old expression inside, right? Must do that. Must copy the old expression inside before you proceed to differentiate the inside. So d outside times d inside. The outside layer, can you see that it's like an onion? This one, the onion outermost layer is 3, power 3. So bring down the power minus 1, get the new, you get a power 2. But the insides must copy and paste.
Yeah.
Then you times the derivative. So 2 plus, okay, I don't make my life so difficult. I'll just use the x square or something. X square. Okay, x4. Make it a bit different. Then you get 4x power 3. Do you need a power 2 here? Do you need a power 2 here?
No.
Don't need, just differentiate the inside. Okay, now that you know this, can you try again? What's the outer layer? Onion.
Is 2 cosine t.
Then times
negative sine t.
Well done, much better. Okay, so simplify, you get minus 2 sine t cos t. Sine t cos t. Yeah, okay, can. Then in this case, okay, I'm gonna get rid of this example. Dx you can now replace with. Okay, make dx the subject first. Then you get dt. Is that okay?
Yeah.
Good. Then now you can sub in. So what do you get? You get the dx to be replaced with whatever expression you had on the right hand side, copy and paste. Then after that, bracket, then you realize that, oh, here got sine cube times sine. It's just sine power 4 times the cosine. Which is exactly what they requested for. So you just copy the question. Cosine t, sine power 4t, dt. There's a factor of 2, bring it out. Yeah, bring it out. But then there's a minus sign. So let's say I bring it out as well. Doesn't matter. But then you realize, read the question. What did they ask you to do? Can you read for me? Question 10, part 2.
Cosine t sine 4t.
But look at the limits. Lower is, upper is
0 to pi over 2.
What's the problem here? Symbolic.
The limits.
Upside down.
Yeah.
So what do you need to do? flip it around, but you introduce an extra minus sign. But there's already a minus sign there, so it's minus minus 2. So it's like, maybe you can write it like, just simplify it straight away to positive 2. Are you confused?
No.
No? Yeah, then that's it. Okay, please pay attention to the limits. Finally, shown. Then this is only the first part of this A-level question. We only did integration by substitution. Now we need to do the substitution so that we can solve this question. So now we have a brand new integral. We need to use the substitution u equals to sine t. Again, what are the 3 things you need to replace? Just now it was parametric integration. Now it is integration by substitution. You realize that they look very similar. It's really just the same thing. So what's the 3 things again?
The limits. Then the expression.
Okay.
Then the dx.
Now it's currently what?
The dt.
Currently it is dt. Now you want to bring it into what world? Look at the substitution.
U.
So you're going to bring it to the u world. So what we have done just now is starting from integral y dx, from the x world, we did a few things, and then we teleport to a new world, which is involving the t, ft dt. Then now we are traveling from the t world into the u world. Okay?
Yeah.
X into t into u. Complicated or not, this question?
Yes.
A level, this is A levels. Okay, moving on. Yeah, so expect this kind of level. I need more space. Wait, I'm gonna add a new page. Okay, so next one. I hope my Apple Pencil has enough battery. Moving on. So limits. How? Oh, it's not X. We start with what? Over here. T equals lower is 0, upper pi over 2. Convert into, we're currently here.
So it's
Malaysia to Thailand now.
So it's sine pi over 2.
So it becomes a u equals sine pi over 2, which is equal to
1.
Let me think a bit. Sine pi over 2. Correct. Well done. How about the other one? Sine of 0, which is equal to 0. So that means we can now write down our integral. 2 leave alone. Integral. Limit can change already to u equals 0, u equals to 1. Then expression, number 2, step 2. How? Remember when you have trigo substitution, what do you need to draw? Sine, cosine, tangent, torcaso. Draw what?
Oh, the Pythagoras, the triangle.
Right-angled triangle. Very simple one. Then you need to use a bit of Pythagoras theorem. U equals sine t is really just sine t over 1. So torcaso, so means what? What's the, you should always label an angle here. What's the angle? I always like to draw a quadrant 1 angle. Sorry, quadrant 1 triangle. And what's this angle here?
It's opposite over hypotenuse.
No, label the angle first. What is the angle here?
Oh, T.
T. Okay, then opposite over hypotenuse. So it's what? Sorry, maybe it's better if I write down u over 1. Yeah, that makes more sense. Sine t equals u over 1. Opposite over hypotenuse is, can you label on the diagram for me? Label, where's my u? And then hypotenuse. Okay, so what should it be? Opposite should be? So opposite should be what?
Oh,
value.
U and the 1.
Very good. Okay, u and 1. Okay, help me to clear the drawing. Then over here, adjacent would be what? Square root of 1 square minus u square. Clear? Simplify 1 minus u square. Can? Can? Good. So now we can move on. So this one expression, maybe I should write it neatly so we can have a good summary. Expression. What do I want to do? I have to draw right angled triangle. Label the angle, let's say T. Oops, sorry, maybe I shouldn't do that. I should zoom in a bit. T inside. And then Pythagoras to find the three lengths. Don't need to show so much working now. Get the three key lengths can already. Then what do you do next? Substitute in. So cosine of T straight away, Picasso. I hope you remember.
Yeah.
So cosine T is?
The square root 1 minus u square
Over 1.
1.
Then don't need to write, divide by 1.
Yeah.
Times sine power 4. Sine T to the power 4. What would it be? You're going from the T world to the U world. Here you got sine power 4. Look at your substitution. What is it? Are you confused by the notation here?
Yes.
This is sine T to the power 4.
Oh, so it's U4.
Yes. Oh, you didn't know that. Okay. For trigonometry, they have this special notation where instead of writing the power on the side like this, we write the power in the middle. The reason we do that is because here, when you put a square beside the T, it looks as if it's sine of T square. When in actual fact, you meant to write down sine T times sine T, which is sine T square. So that's why there's this. So if you try to, if you want to be clear, you have to put brackets. And mathematicians are always very extremely lazy. So they came up with a shortcut to save time and save pen ink. They just decide to put the 2 in the middle so that you can indicate that this is really just sine T times sine T without drawing so much, without writing so much. You can save paper, save ink. Okay, so likewise for sine cube or sine power 4t, it's really just sine T bracket power 4, or rather sine T times sine T times sine T times sine T. I'll just write it down. Okay? Clear? Okay, so yes, it's just u power 4. Oh, you didn't know the notation. Okay. Can. Then dt, the last one. Step 3.
Must like differentiate.
Very good. Yes, so which one do you differentiate?
The sine.
The sine, wait, let me adjust this. The sine, yes, correct. U equals to sine t, in other words, the substitution. Maybe I write down an instruction. D the sub. What does that mean? Differentiate the substitution. Here they gave you u equals to sine t. Please differentiate it. Du by dt. What do you get? D the sub.
Sine.
Differentiate sine, what do you get? Yes.
Cosine.
Cosine. Sorry, maybe I heard wrongly. Then therefore du equals to cosine t dt. I thought I heard sine. Yeah. Differentiate sine, get sine again. No. I maybe the audio disrupted. Cosine. Yeah. Then over here, maybe it's not such a smart idea to make du the subject. You should make dt the subject, because here you're starting with dt, you want to go into u world. So you should make dt the subject, which means that dt is actually equals to du divided by cosine t. Is that okay? Is this okay?
Yeah, can.
Remember, dt must go into, du. I forgot to put. Yeah, so now you got dt equal to du over cosine t. We're gonna replace the dt with du over cosine t. Du over cosine t. Du over cosine t. Light blue. I hope you can see.
Yeah.
Then finally we can proceed. But still cannot. You see a problem? We wanted to travel from Malaysia to Thailand, but then you have a friend who's left behind, who's still stuck in Thailand. Then you leave him alone and move on? Cannot. You must wait for your friend. Over here, cosine t. Must bring him to the other world as well. Need to move together. So cosine t, what do you need to do? Calculate, no?
Is the 1 minus
Square
u.
root. Square root 1 minus u square, right? So
Yeah.
that's why you should replace this with square root 1 minus u square. Alternatively, if you are smart enough, you can realize that cosine t is here. This one, if replaced with du over cos t, you can just cancel off the cos t. Do you see that?
Yeah.
If you didn't replace the cosine t, but I don't think that's so much faster lah. Just use the triangle. Also not that difficult. Then you end up with the u1 minus u squared. Okay, maybe it's nicer if I just do the presentation on the bottom. So over here, I'll just replace the du over cos t with du over square root of 1 minus u square, sorry. Then after that, I replace just to make it look nice, I'll draw implies arrow here, highlight light blue, and then I draw an arrow. So instead of cosine t, it becomes a 1 minus square root u square. Sorry, square root of 1 minus u square. Then you can cancel off these two. 2 times integral 0 to 1 of u power 4 du. Wow, finally, so easy. How to integrate? Mic test, how to integrate? I'm waiting for your answer.
Oh, u5 over 5.
U power 5 over 5, very good. Then you have to have limits as well. What are they? 0, 1. Then you sub in. So 2 times 1 over 5 minus 0 over 5. Okay, good. Then 2/5. Can? How long do you take to do this? I strongly advise you, maybe you don't spend so much time doing so many questions. You make sure you can master the basics. This question you repeat. I don't know how many times you need to repeat until you can get it perfect.
Okay.
Repeat many times. Must do at least like 3-4 times. Redo the same question. Just watch the video if you get stuck. Okay? Ken, moving on. Oh, this is question 10. We are not done yet. Oh no.
Well, how many more questions? Because I need to go work already.
Okay, what time do you have to leave now, is it?
No, I need to leave at 3.
Okay, can I should wrap up already. Okay, question 11. Okay, there's still so many. Still got 4 more pages. How many questions do you do? Let me see. Wow, still got until question 18. Oh my goodness.
Huh? Oh, I did so many questions. Really?
To the end. Yeah, question 18. All the way. Oh my god. Okay, let's take a look at question 11. This one is a periodic function. Okay, for this question, yes, you draw the graph correctly. It is supposed to be periodic. From negative a to positive a, there's a circle. This is really just a circle. Okay, actually no, it's an ellipse. And then you have a 0 from a to 2a, and then you just repeat the graph. Yeah, that's correct. 3a. Then after that, you add on a 3a. Hold on. This is 3a. A. Okay, yeah, your graph is correct. Okay, fine. Then what do you want to find? The sketch of the graph y equal f of x from minus 4a to 6a. Okay, Ken, it looks okay. Let's move on. So part 1 is fine. Perfect. Use the substitution x equal to a sine theta to find the exact value of the integral of fx dx from half a to root 3 over 2a. So where is half a? You must draw on the graph over here.
Yeah.
Where is root 3 over 2a? Root 3 over 2, if you type in a calculator, it's actually a 0.86. So it's just a fraction of a. So that means that it's actually still over here. Okay, these 2 lines. So you're just trying to find the area in between over here. Let me see your working. You get x equal to a sine theta, good. Differentiate, you get a cos theta, that's good. Then you get x equal to root 3 over 2a and half a. Then you sub in, so you get root 3 over 2a equals a sine theta. Cancel off the a, get sine theta equal to root 3 over 2, which is the exact value pi over 3, correct. Then you get a half, so it's pi over 6, 30 degrees. Good, correct. So now that you have these information. Let me just bring it down to the bottom so I can have a reference. Then after that, you try to integrate this. So you copy down the function first. You realize that the relevant part is the one with the circle, not the 0 in the piecewise function. Then you just write down. Then you sub in the limits. Good. Square root 1 minus x squared over a squared. So sub in the x with a sine theta square bracket over a squared. Then the dx you replace with what? Dx you replace with the derivative. So a cos theta d theta. Well done. Very good. Oh, okay. You can do. You can do.
Because I go and reread the notes, then I try to do this.
Yeah, it's roughly the same. So yeah, then a square sine square, the a square cancel off, you're left with 1 minus sine square. Then a cos theta d theta. Good. So 1 minus sine square is cosine square. Take the square root, get cosine. Good. Times a cos theta d theta. Well done. Limits just continue bringing down. A factor out, then you get cosine theta times cosine theta, cosine square theta. Then you use the formula 1 plus cos 2 theta over 2. That's fine. Reminder, it's cosine square theta equals to 2 cos square minus 1. Oh, sorry. Did I? Yeah, correct. 2 cos theta no square. 对不对? Sorry. No. It's cosine of 2 theta. Then after that, you make cosine square the subject. It's just cos 2 theta plus 1 divided by 2, which is exactly what you had over here. Sub in, then you get half integrate, you get half theta. Cosine 2 theta divided by 2, integrate, you get sine divided by 2 because of the 2 over here by chain rule. Then you get a 4. Perfect. Good. Then after that, you sub in the pi over 3. Good. Sub in the pi over 6. Good. Then just simplify. You get pi over 12a. Blah. Yeah, correct. Well done. Very good.
Oh, okay.
Good. Okay, now question 12. Curve has equation y equal fx. Fx equal x times e power negative x squared gives a curve of C. Good. Then you want to use the substitution u equal x squared to find the integral from 0 to n of fx dx for n more than 0. Okay, hence find the area of the region between the curve and the positive x-axis. So if you have the substitution u equal x squared, you differentiate, you get 2x. Good. Then you make du the subject. So du over 2x equal dx. That's fine. You also make x equals to square root of u. Is that useful? I'm not so sure. Then let's take a look at the integral 0 to n of the fx dx, which is x times e power negative x squared. Substituting the x, we get square root of u. Substituting the x squared, we get a u. So square root u times e power negative u. But then the du, I'm sorry, the original dx, you replace it with a du over 2x. But wait a minute, we know what's x. X is square root of u. So we can immediately replace x with square root of u. Anything to cancel? Square root of u can cancel. So you're left with e power negative u over 2 du.
Yeah.
Integral. Limit. So 0 to n becomes if you replace it, so you are calculating here. You sub in the x equals to n, you get u equals to n square. Good. Sub in the sub in the x equal to 0, you get u equals to 0 square, which is 0. Good. So you substitute in and you get n square over u. Good. E minus e power negative u du. Well done. With a half factor out. Perfect. Very good. Okay, then did they request for exact value? No, then you can just use 3C. But over here, unfortunately, it's n. Sorry, I didn't realize that n square is a variable. You cannot type n square in a calculator. So no choice, have to do it manually. Integrate this, not too bad. You just have to divide by a negative 1. Integrate e power, you still get by e power, but you need to do chain rule. That's why you have a negative here. Good. Sub in the n square minus 1. Sub in the n square, sub in the 0, and you subtract. Good. Because e power 0 is 1. That's how you get this 1 over here, the green highlight. Good. Distribute, you get negative half e power negative n square, and then plus half. So you get half minus half e power n square. Very good. Perfect. Now you want to hence find the area of the region between the curve and the positive x-axis. Yeah, that's it. That's here it's a bit special because the question is actually testing you on the idea of a limit. The curve looks like this. Okay, wait, your curve is on top. So it actually just goes all the way to the x-axis. It actually goes all the way to infinity. So the question actually requires you to do one extra step. Area is equals to the limit of the integral of 0 to n fx dx as n goes to infinity. In other words, you need to take limit as n goes to infinity, substitute in this integral here with whatever you found, your perfect answer. Half minus half e power negative n squared. So what you need to realize is that as n goes to infinity, this guy here actually goes towards 0. You can draw a graph of this and you can see it.
Oh.
So this becomes 0. This goes to 0. You get half minus 0, which is equal to half. That's your answer. Okay, one last step. Notice that they never say x equal to something to x equal to something. They say and the positive x-axis, a bit special. This is what we call what do you call it? Okay, never mind. I don't introduce the name. I also forgot the name. But you will learn this in the future if you are doing engineering. This is the basic example. Okay, good. That is part 2. Just one more step. You lose 1 mark or half a mark because you never write down this limit, the final answer. Moving on, so now we got a part 3. Find the exact value of this in the modulus of this guy, but from -2 to +2. So if you take the modulus of that fx, you shouldn't have a negative anymore, should you? Actually, there is a even sneakier way, which is to realize that the graph is symmetrical. Can you see? Can you see? Sorry, more like this and then like this. It's symmetrical, right?
Yes.
Yeah, so the area under on the right side and the left side is actually equal. So that means that if you want to find the total area from -2 to 2 of modulus fx, right? Modulus fx means the graph just reflect on top like this. Can you see? The bottom goes on top, the red color. So the new graph is like this. Mustache, two mustache. Okay. All you need to do is to take 2 times of the integral from 0 to 2 of the original function x e power -x squared dx. No need to put an extra minus sign here because from 0 to 2 it means x equal to 0 to x equal to 2. Which part of the graph are we looking at? Left or right?
The right.
Right side, which is already above the x-axis, so no need to times -1. And we already know the answer to this. Okay. We have an expression for this. Right? It's just the half minus half to half minus half e power -n squared. Oh, but you have to replace the n with -n squared. The n replaced with n is the upper limit and 2 is the upper limit. So replace n with
2.
Exactly. Just use that for answer. This is very common in questions with part 1, part 2. Just use the answer from before. Then times 2. Okay. So simplifying, you get 1 minus 2 times how is 1 e power -4. That's your answer. Make it nicer. 1 minus 1 over e power 4. That's your answer. Okay. Can. Okay, now last part. Find the volume of revolution when the region bounded by the curve, the x equal to 0, x equal to 1, and x-axis is rotated completely about the x-axis. Give your answer correct to 3 significant figures. Let me see your working first. So you integrate 0 to 1, take this square dx. Perfect, exactly. Correct. Easy. Good. Okay. Do I have time for one? I don't think so. I need to go already.
Hi, easy question.
I guess so. You go. Oh wait, you did until 13 only. Oh, you only did until question 13.
Yeah, I think so.
Oh, one more question. Should I just go through?
Yeah, can.
Can I? Okay, I'll go a bit fast. Okay, so if you got any questions, you watch the video again, then let me know. I will answer again. Okay, it is given that fx is equal to 2 minus x. So you can draw the graph first. 2 minus x is like this. But then because it's mod, you want to draw on separate diagram the sketch of the curve y equals to f of mod x. So the idea behind f of modulus x is that every time you have negative values of x, you plug it inside. What happens? You take the modulus, so it turns it into positive, which means that your x is -2, it will turn into x equal +2, and then you get f of 2. So f of -2 is the same as f of +2, which means that they will be reflected about the y-axis. So how you draw the graph is you chop off the left half, and then you copy and paste the right half, which is what you have over here, and you restricted it to -2 to 2. They didn't give you domain, so don't restrict, continue drawing the graph all the way. Okay? Yeah, it's a bit misleading if you stop there. Just draw all the way because it's
The GT show like that. So I need to extend myself.
Yeah, you should extend yourself.
Okay.
Yes. Okay, then why not? You should extend. Why did? I think it's because of your settings in your x minimum, x maximum. Okay, moving on. The next half is y equals modulus fx. So this one, right, is the other way around. For this one, step one is to toss left side. Toss left side, keep right side. Toss left, keep right. Then step two is to reflect right about y-axis, the right half of the graph about the y-axis. That's how you do it for the graphical transformation. Reflect the right about the y-axis. Reflect the remaining right side. That is y equals f of modulus x. Now we move on to modulus fx. When the modulus is outside, what happens is that you draw the graph first, but then everywhere that's negative, you reflect on top. Exactly what you did here. Reflect bottom to top. Toss bottom. You toss away the bottom, get rid of it, reflect it on top. Correct, perfect. Here is 2,4. 2,4. Sorry, did I see wrongly? Oh, 0. Oh, sorry, that's a 0. Okay, Ken, your graph is fine. Moving on for part 2. State the wait, haven't finished part 1, sorry. Giving the coordinates of any points where the graph meet the x and y axis, you should label the graph clearly. Got label, got intercepts. Intercepts, got label. Intercept as well. Very good. Your graph is perfect. Moving on, part 2. Blank. State. Oh, wait, no, that's the answer. State the set of values for which this guy equals that guy. So you should draw the graph. In this case, yeah, this is correct. This is correct. But the answer key, they gave you the set of values now, because here they mentioned set. You need to use set notation. So you should actually be using this guy like this. It's until 2, right?
Yeah.
Which is the square bracket notation. It's actually short form for this set of values. I hope you remember what our sets are. Set an element of all real numbers such that 0 less than equal x less than equal to 2. Okay? Set notation. So basically all the numbers that's in between 0 and 2. This is set notation. Set builder notation. Here you cannot use you cannot list down all the numbers in between 0 and 2, right? There's too many. There's 1, 1.1, 1.01, 1.001, 1.00001, infinite number. So you have to use this kind of notation. Can maybe this one I'll have to give you a half take because you are required to give a set. Okay, moving on to part 3. Find the exact value of the constant a for which this guy equals that guy. Let me see your integral. From -1 to 1, good. From 1 to a, that's good. So over here, after you, okay, yeah, you need to check which part of the curve is relevant. Okay, -1 to 1. So you're using, okay, cannot, this is wrong. Cannot, wrong. Because over here, -1 to 1, you see, there's a sharp point. There's a sharp point. Can you see a sharp point?
Yeah.
Every time you have sharp point, you need to chop off the graph into 2 separate halves. Left half over here, right half over there. And they are 2 separate functions, different functions. What you should do, what you should realize is that this left half is actually the y equals to positive x plus 2. The right half of the graph is actually, okay, don't put so many ticks. Basically, the whole thing is correct. The right half is y equals minus x plus 2. Then you have to integrate them separately. Alternatively, the smarter way is to realize that if this blue and purple, what do you notice about their areas? They are actually the
Same.
So you just need to find total area. You just need to find one of them. Then you times what?
Times 2.
Times 2, exactly. So that's what we're gonna do instead. So the left half should actually be this one should actually just, you shouldn't integrate it straight away and sub in 1, -1. This is wrong. Okay, this one is you're just copying the question, is fine, but this one not correct. Actually also not correct. Should be fx. Should be fx. You cannot sub in 2 minus x. The moment you sub in 2 minus x it's wrong already. The question didn't f of mod x, sorry. The question didn't give you 2 minus x itself for f of mod x. So left-hand side should actually be equals to 2 times of the integral of the, let's say we use the 2 minus x, but from 0 to 1. And then let's just quickly calculate that. That's just 2x minus x squared over 2. The integration technique shouldn't be difficult, right? The difficulty is in interpretation. So 2 times 1 minus 1 squared over 2 is 1 over 2, minus away is 0. Then you get 2 minus half is 1.5. 1.5 times 2 is 3. Okay, so left-hand side, you go to 3. But the right-hand side, now let's calculate that. Right-hand side, we want the integral from 1 to a. So of the f modulus fx dx. So again, this modulus fx dx is actually made up of 2 functions, just like the f mod x. Can you see the 2 functions? This left and this right? Can see or not?
Can.
The left guy is actually what? It's actually y equals to minus x plus 2. Then the right half is actually what is this? If you reflect it, let me think of it. This is y equals to x minus 2. Okay, so what is 1 to a? It's over here to here, right? Can you see?
Yeah.
Here to here, you don't know where does a stop. You don't know what is the value of a. So here is 1, here is 2. Maybe I use pink color to make it different. Okay, so that's the total area. You don't know what is it, but more importantly, you know that there's a sharp point over here. So you actually need to split it up into 2 separate halves, the left half and the right half. Can see or not?
Can.
So what would the integral be for the left half?
Uh, 0
1 to something plus a to something, dx.
0 to 1.
No, start from 1. No. Look at that.
Oh,
Start from
1.
the left. 0 to what's the in between?
I
Sorry, that's
I wrote. Oh.
sorry, this is a. I zoom in.
Oh, 1.
1, 2, then a. Sorry. So sorry, yes, 1 to 2. Correct. You said the answer already. But what's the function?
1
to 2, the left half is the gray one, which is?
Negative x plus 2.
How about the other guy? A to what? Oh, sorry, shouldn't be 2. Shouldn't be a. Should be upper limit a, but the lower limit should be 2. Does that make sense?
Yeah.
Here is a 1, here is a 2, here is a a. Got the left half, got the right half. This guy is minus x plus 2. Y equals. Then that's why you try to integrate minus x plus 2 from 1 to 2. Must take note of the sharp point and the x coordinates. Then the right half is y equals to x minus 2. You can quickly work it out. You have you just need to reflect it. Okay, reflect it. So that's why the gradient will times -1. From instead of negative, it will become positive. And then the y-intercept, the y-intercept minus 2, you can work it out by like a quick example like x plus c. Then you sub in a point 2, 0. So 0 equals to 2 plus c. Solving for c, you get -2. That's how you get -2. I'm sure you know how to do that, huh?
Yeah. Can.
Okay, can. Then what will be the function inside? It will be the right half, which is x minus 2. X minus 2. Okay, then you can integrate this. So this one, step by step, you get minus x squared over 2 plus 2x. Oops, sorry, should be square bracket. I'll just draw vertical line also, okay, faster a bit. X equal to 2. Then add on the integral x squared over 2 minus 2x, square bracket. Okay, I'll just draw square bracket to be consistent. 2 to a. Sub in, what do you get? You get minus 2 squared over 4, which is minus, I'll just write it down, plus 2 times 2. Minus away, minus 1 squared over 2 plus 2 times 1. Right, that's the first term. Then you have to add on the other guy. So plus a squared over 2 minus 2a minus away, sub in the 2. 2 squared over 2 minus 2 times 2. Okay? So you get an expression in terms of a, you can simplify. So that's your right-hand side. Then since you have left-hand side and right-hand side, what can you do? Equate them, then solve for a. Is that okay? Can then I leave that to you already. And that's all. Okay. LHS equal RHS given by question. Solve for A. Solve for A. All right, then the rest haven't do all. I think we can have to move on already. We don't do those. We have to move on to new topic. Yeah. So okay, you know what? I'll make a video for you on sequences and series. Go and watch that video before, then you go and try some homework questions. I'll assign you questions on sequence and series. Is that okay?
Okay.
Can then we move on. Okay, that's all. Go for your work. Bye bye.
Thank you so much. Bye bye.
Bye bye.